Are you ready to embark on a transformative journey into the world of microservices with Spring Boot? So this is a complete masterclass that covers everything you need to know about microservices and Spring Boot. So in this particular course, we will first learn how we can build a traditional monolithic application, and then we will convert that same application into microservices. We will first begin with the very basics of Spring Boot, where we will set up things and we will dive into the magic of Spring Boot. Then we will move beyond basics, where we will create a couple of projects using Spring Boot. And then when building a monolithic application, we will learn about things like JPA, Spring Boot Actuator, and tools like Postman. We will then understand what microservices are, and we will begin converting the application that we have built into a microservice. Now, when building microservices, we will learn about concepts like Service Registry, distributed tracing, ZIPKIN, RABBITMQ in a hands-on way. We will also cover topics such as API gateways, fault tolerance, circuit breaking using RABBITMQ. This course will also cover things like packaging your microservices, containerization using Docker and Kubernetes. Well, this course has hours and hours of content that is really valuable and will bring in a very comprehensive learning for you all. And this course is the ultimate roadmap to master Spring Boot microservices. So this is going to be a complete hands-on session where we will be actually doing things in a hands-on way practically. Now, if you have been watching my videos and if you haven't liked or subscribed yet, I would highly recommend doing so, because every subscriber or every subscription that I get on my channel motivates me to bring in more such amazing content for you all. The support and love that I get from my viewers impacts my ability to bring in more such amazing free content for you all. So I would highly recommend that you hit the subscribe button, like this particular video, and turn on the bell notifications. Also, feel free to leave a comment to let me know what kind of videos I should bring for you all. Now, without a further ado, let's jump right into the session. Hey there, welcome to this class. So let us start talking about this concept of Service Registry and why do we need it in our microservices architecture. So first, let's start talking about what is a Service Registry. So a Service Registry is used in a microservices architecture to enable dynamic service discovery. Now, in microservices, inter-service communication is really important. And for inter-service communication, we have hard-coded URLs that we can use. So you can hard-code the URLs and you can use those URLs to communicate with other services. But this is not a good practice. Now, this can be cumbersome, error-prone, and this is not a good way of talking to another service. So this is another approach, which is with the help of Service Registry. So what happens in case of Service Registry is you have a Service Registry which looks something like this, and you have other microservices like this over here. So you have company, job, and review service, for example, and you have a separate Service Registry. So what will happen is every microservice will register itself with the Service Registry, and Service Registry will help with service discovery. So Service Registry essentially is like a phone book for microservices, or you can call it like a database, or you can think of it like a database that has been populated with the locations of different microservices that exist. So Service Registry will know all the microservices that exist in a particular architecture. And if you want to talk to any microservice, you need to go to the Service Registry and get the location of that particular microservice and communicate to it. So this is how the service registry concept works. And like I said, you can think of it like a database populated with network locations of service instances. Now, all the microservices will register themselves with the service registry. So by all, I mean all, or whoever wants to get discovered within the network. So they will register themselves with the service registry, and service registry will help with the service discovery. And when the microservice shuts down, they can deregister themselves. Okay. So they automatically deregister themselves whenever they shut down. Now let us talk about this entire process as to how the service discovery process works. So let's say you have a job microservice and you have a review microservice. Okay. So job microservice will register itself with the service registry that exists in the microservices architecture. Now, whenever the review service wishes to communicate with the job service, review service will instead go to service registry and do a service discovery request. So a service discovery request is like a request to communicate to a particular service. And then service registry will help the review service to communicate with the job microservice. And this way the communication happens. So the benefit over here is, instead of relying on the individual microservices to discover themselves on their own, so instead of using hardcode URLs in that place, what we can do is we can have service registry, which is a centralized server to which every microservice can register. And whenever you have to communicate to any microservice, you do a service discovery request and then you communicate. So this helps, and this is a better approach as compared to those of hard-coded URLs. Like, you can't have hard-coded URLs everywhere. Okay. So this is about the concept of service discovery and service registry. Now let us talk about how it will work for us. So if we have multiple microservices, we will be registering all the microservices with the service registry over here. Okay. And everybody will register. So whoever wishes to get discovered in the network. And then whenever there is a request that is supposed to be done to another microservice, service registry will help with that. Let us talk about why using a service registry is beneficial. So there are several reasons as to why this concept is really beneficial. So the number one benefit is dynamic service discovery. So with a service registry, microservices can dynamically discover the locations of other services at runtime. Okay. And this essentially eliminates the need for hard coding URLs. So imagine if you don't have this concept, how would you communicate? So if you have one service that is being hosted on a server, and then you have another service that wishes to communicate. So what you will do is you will take the URL of the second service. Okay. So the service that you wish to communicate with, you will get the URL of that and you will hard code it into the service that wishes to communicate. So that's one way of doing it. But with service discovery, this need of hard coding URLs is completely eliminated. And this hard coded URLs thing can be problematic, okay, in dynamic environments where services can be added on the fly and removed on the fly or even relocated. So if, let's say, you are hard coding the URLs, let's say, and the service location has changed. So the URL will also change, IP will change, of course. So in that case, this becomes an issue. And that is why there is a need for something that manages this dynamically. Okay. Because in microservices architecture, everything is loosely coupled, like multiple services are loosely coupled. And there is a possibility. So if you are using IP address to communicate, let's say, okay, you are using the server IP. So there will be a requirement or a mandate that that server IP cannot change. And what if it changes? So there will be errors all over. Okay. So if we move the server, the IP changes. And if you like do anything like service, you added a new service, you removed some service, or you do anything with the microservice. So the possibilities of failure with hard-coded URL are higher, and it's not a good practice to go about that. Okay, so that route is not good, and that is why this particular concept exists. So this is about dynamic service discovery is what it helps with. Then we have load balancing. Okay, so a service registry can also provide load balancing capabilities, and it does so by distributing the incoming requests across multiple instances of a service. So if you are having a microservice, and let's say if there is a lot of load on that microservice, you can add multiple instances of that microservice to scale the needs of the traffic. Okay, and in that case, you might need some load balancing features, and that is even what service discovery can help you with. So service discovery is beneficial in that way with load balancing as well. Then you have fault tolerance and resilience. Now, what does this mean? So in case of microservices architecture, where everything is loosely coupled and there are different services, there can be a possibility or a scenario where a service instance fails or becomes unavailable for a certain period of time. And this way, how can service registry help in this? Okay, so let us say if a service fails and other services in the network are not aware of this failure, then what will happen? Like there will be errors all over. So other services will also try to communicate to that service without knowing that it is down. Okay, and in this particular scenario, service registry comes to the rescue. So if a particular service instance fails or becomes unavailable, service registry can detect the failure and update the registry accordingly. So like I said, it's like a phone book. So it updates that, hey, this particular service is down for a while. Okay, and this allows the other microservices in the network to know that, okay, this is something that we need to be aware of, and we need to redirect the request to healthy instances accordingly. Okay, and this can improve the fault tolerance and resilience of the network. So resilience is basically not failing. Okay, and fault tolerance is essentially the ability of a network essentially to survive the faults. Okay, so in this way, since service registry is aware of service instance not being available, it can update and it can be aware as to how to route the requests. Then we have scalability and elasticity. So as number of microservices and instances grow, managing and coordinating the interactions becomes much more challenging. Okay, so if you don't have a service registry, it will be a chaos. Okay, so you won't know who is communicating with whom. So in that case, if you have a centralized service registry, then service registry provides a centralized mechanism to manage service endpoints, and it makes it easier to scale the system up or down based on a particular demand. All right. So this is about scalability and elasticity. Then you have service monitoring and health checks. So service registries include features that enable you to monitor the health of the registered microservices. And they periodically check the availability and responsiveness of the services. And they have a mechanism using which they mark them as unhealthy or healthy based on some criteria that they have. Okay. And this information is used then by the rest of the network for better visibility, decision making, and managing the system. So service registry indeed is really beneficial, and it's a great thing to have in a microservices. Okay, but now the thing is, how are we going to implement service registry? Okay, so there are several service registry solutions out there, but the most popular one that we'll be using with Spring Boot is Spring Cloud Eureka. So if you head over to Google here, so I'll just switch over to my browser, and here I'm going to say Spring Cloud Eureka. Okay, so you'll see this first link over here, which is Spring Cloud Netflix. Okay, so Spring Cloud Eureka essentially is a client, and that is a part of Spring Cloud Netflix project. And this Netflix is like the Netflix.com. Okay, so yes, this was built and developed by Netflix, and it was for its own internal use, and then it was made available for everyone else. Okay, so Netflix Eureka was developed by Netflix, and it's a service registry and discovery server that allows applications to locate and communicate each other in a distributed system. Okay, so you can think of it like a centralized repository for service registration and discovery, and it makes it easier for microservices to find and connect with each other. So you can read more about Spring Cloud Netflix, and you can see it has some service discovery features that have been mentioned over here. Okay, so we will be making use of the dependency for including Eureka server into our project. Okay, and you can see it's mentioned a few times over here. All right, so yeah, how it will work is whenever we include the dependency, we will get a separate Eureka server, which will act as a service registry for our network or for our microservices project. So yeah, that's about Spring Cloud Eureka. And that's about service registry and the importance of service registry in microservices architecture. Welcome back. So let us start implementing and setting up the service registry with the help of Eureka server. So we are going to make use of Spring Cloud Eureka, which is a part of Spring Cloud Netflix project. So what I'm going to do is I'm going to head over to start.spring.io. So to add Eureka server into our microservices architecture, we will need to add it as a separate server. And adding as a separate server will require us to create a new Spring Boot application. And that is why we have landed on this website, start.spring.io. So this is our favorite website from where we create new Spring Boot projects. So select Maven, select the latest version of Spring Boot. Make sure you're not selecting snapshot version. Then add the group ID. So I'll add the group ID as com.embarkx. All right. And artifact ID, I'll keep as service reg. So I'll say service reg. So this is service registry. Okay. And I'll have service registry for our microservices. So description is service registry for our microservices, and you will see package name auto generated. We have packaging as jar, and Java 17 is what we are using. Okay, so this is something that we have added. Now what we need to do is we need to add some dependencies. So I'll say add, and here I need to say web. So this is one dependency that we will have to add. We'll have to tell Spring that this is a web application. One more dependency is we will say Eureka. So you will see two dependencies come up. So Eureka discovery client and Eureka server. So since we are setting up this server, we need Spring Cloud Netflix Eureka server. So I'll select this. You can explore the pom.xml if you wish to. So here you can see there are two dependencies that have been added, the web and the Netflix Eureka server. Okay, so I'll say close and I'll download this as zip file. So after you have downloaded this as a zip file, you can extract it. Okay, so I'll say extract here. Once the file has been extracted, you will see this folder appear. Now what we need to do is we need to add this as a project. Okay, so I'll head over to IntelliJ IDEA. Now in IntelliJ, I'm going to add a project to this layout here. So I'm going to head over to Maven here on the right hand side. I'll click on this plus icon. So we'll add a new Maven project. I'll scroll down and here we have this project service reg. So service registry, I'll say okay. And you will see the service registry project appear on the right hand side. So it's been added to our unified view now. Okay, so I'll just collapse this a bit. Now, once this is added, I'm going to close all the tabs and I'm going to expand the service registry. Okay, so we are getting an error here. Okay, so the error I got was related to syncing issue, and if I clicked on sync again and the issue was resolved. Okay, so there was some problem with the network to get the dependencies, which is fine. So we'll head over now to main Java, and I'll open this Service Registry application. Now in this particular file, we need to add an annotation. So we need to tell Spring Boot that this is a Eureka server. Now, how do we tell this? With the help of a simple annotation, which is enable. So I'll say enable Eureka server, and I'll say enter. Now you can take a look at this dependency here, or this import statement here. So Spring Framework, Cloud, Netflix, Eureka server, enable Eureka server. So this is coming in from the dependency that we have added. So if you go to pom.xml here, we added the dependency which is for Eureka server. So this is a dependency that we have added. Okay, Spring Cloud Starter Netflix Eureka server. So because of this dependency, we have access to this particular annotation here. Okay, and this is the annotation responsible for enabling or converting this particular application into a Eureka server. Now by specifying this annotation, we have all the features enabled for having a service registry over here. Okay, so now what we can do is we can head over to resources, application.properties. Now here we need to specify some properties here. Okay, so I'll first say spring.application.name. So we need to first give this particular application a name. So I'll call this as Service Registry, like so. Then I need to say server.port. So we'll have a different port for this particular application. So I'll say 8761. So this particular application will run on this particular port. Okay, I'll say eureka.client.register, and I'll say hyphen with Eureka. So this is one property that we need to specify, and one more property, eureka.client.fetch registry. So these two properties we have to set. Okay, so this property says whether you need this application to register to Eureka. Okay, so this particular service or this particular application itself is a service registry, which is nothing but Eureka server. Okay, so I need to say false because a Eureka server cannot register with itself. So we need to set this as false. Okay, now fetch registry. So what does this mean? So does it need to fetch the information of the registry? It's a registry itself. No. So I'll say false. So we need to set these two properties to false, and we need to add these two properties which specify the service registry, which is the name and the port here. Okay, so with this we are done configuring our service registry Spring Boot application, which is nothing but Eureka server, and we have done this with the help of the Netflix dependency. So we have added this dependency from Netflix Cloud Starter project, which is of Eureka server. Okay, and we are making use of Eureka server here to get the service registry up and running into our application. So we are done with the configuration. All right. So if you have done this successfully so far, it's great, and we will run this application shortly. Welcome back. So we have the service registry project set up and created. Now let us run this project. So I'll go to service registry application and I'll say run. So our service registry application is running as a service now, as you can see here, and it is running successfully. Okay, so here in the port, we have specified the port number as 8761. So let us head over to this port and let us see what we see over here. So if you come over here, you see this page that has been made available to you. And this page says Spring Eureka here. You have the status of environment here, okay, some information, and here it says application, no instances available. So this is under instances currently registered with Eureka. So what this means is we have Eureka server up and running successfully, but there are no instances that are currently registered with Eureka as of now. And that is totally expected because we have not configured anything to work with Eureka yet. But this is how you can run the project and access this page here, which gives you a gist of what all services are available with our Eureka server. So let us start registering the first service. So the first service that we'll register is the job microservice. And to register job microservice, we will have to do some configuration changes in the job microservice. And for that, we need to add some dependencies as well. So I'll head over to Spring Initializer here, and I'll remove these dependencies. And if you click on Add Dependency, and if you say Eureka, so you will see two files, like two dependencies over here. So you have Eureka Discovery Client and Eureka Server. Eureka Server is to set up the Eureka server, but this time we'll make use of Eureka Discovery Client, which is for registering purpose. So I'll go to Explore now, and here, if you scroll down, you will see this particular dependency appear over here. So I'll just copy the dependency. I don't need to get or download the entire project because we have the project already set up. And I'll head over to my IDE. Now here, I'll minimize this and I'll go to job microservice. Here, pom.xml. And here under H2 database or anywhere within the dependencies tag, I'm going to paste the dependency that I have copied. So you will see after pasting, everything turns out red immediately. And that is because we need to get the dependency. So this dependency is not found. And how do we get the dependency? So you will see this icon appear over here on the right hand side whenever you do any changes to the pom.xml file. And if you click on this, you can see resolving the dependencies. Okay, so we got an error, could not find this dependency here. So the reason this has failed and we got this dependency error is because we are missing one more thing. So if you head over to start.spring.io here, if I zoom in, let me zoom in a bit. And here, if you scroll down, so here we have the dependency like Eureka client. And if you scroll down, you also have the dependency for Spring Cloud. So this is something that you need to add. Okay. So I'll copy this. So under dependency management, this needs to come in. Okay. So we'll head over to our pom.xml. And if we scroll down here, okay. So we don't have dependency management. So we need to add this after dependencies and before build. So after dependencies and before build over here, like so. So let me resync now. Okay. So we even need to add the cloud version. So here we are making use of this variable, or we are saying we need to specify the cloud version here. And if you scroll up, here is the tag that specifies the cloud version. So I'll get this tag and I'll scroll up here and we'll add the tag here. Okay. So this specifies the Spring Cloud version. The Java version is also specified and we are using the Spring Cloud version over here. Like so. So to resync, I'll click on this Maven and I'll click on reload all Maven projects. Okay. So you should see the error go away and everything should sync perfectly fine. Okay. So remember whenever you are adding this, like this Eureka client to your project, you need to add Spring Cloud as well, like this tag over here. And you need to add this tag as well. Okay, this specifies the Spring Cloud version that your project will use. And this is because Spring Cloud Starter Netflix Eureka client is part of Spring Cloud project. Okay, of course, Spring Cloud Netflix project, but you need Spring Cloud as well. All right. So this was not needed when we did this for Service Registry. And the reason is because we downloaded the entire project. So everything was set up. Okay. But this is needed. And once you have done this, you have all the dependencies that you need to register job microservice as the client. Okay. Now what we are going to do, so we need to add some properties now over here. Okay. So these are the properties that we had added for our Eureka server, but we need to go to job microservice, src, main, resources, and application.properties here. Okay. So here we will add, I'll say Eureka. Okay. And these are all the properties that we'll need for Eureka server. Okay. So to register this as a client, what properties do we need? So a couple of properties that we'll need is these. Okay. So I'll just paste this over here. So here we are saying Eureka client register with Eureka. Instead of false, we will have true, because job microservice needs to register with Eureka. So this is true. Does it need to fetch the registry? Yes, it needs to. So I'll say true for both. Now, how does job microservice know where Eureka server is? So where is Eureka server running? Eureka server is running on this particular port on localhost. So we need to give this address. So if you go to our browser here, we have Eureka server up and running over here. Okay. So what I'm going to do is I'm going to come to this application.properties and I'm going to say Eureka client.service URL dot, I'll say default zone, like so. And here I'll paste the URL and I'll add Eureka in the end. Okay. So this is the URL which will be used by our microservice to register as a client. And we have specified two properties here. We are telling the job microservice to register as client with Eureka and also to fetch the registry. Okay. Now let us reboot our job microservice. Okay. So what I will do is I'll go to the services tab and I'll click on job microservice and rerun. So this will start running our job microservice and let us wait for it to completely boot up. So it's running now successfully. Now, so you can see over here some logs appear. Okay, you can see discovery client. Okay, and here if you scroll down, okay, you can see over here registering the service. So the service is registered. Let us see here. So here if I refresh, okay, so the application is unknown. Okay, and why are we getting unknown? In logs also we saw unknown a bit, and there is a reason for this. The reason is we don't have a name for our job application, okay, which is not good. So we need to add a name over here. So to add a name, I'll just scroll down and here I'm just going to say spring.application.name and I can say job-service. Okay, like so. And now once the application name is set, okay, you can even move this to the top somewhere over here. Okay, and let me rerun this particular service. So I'll go to services tab and I'll rerun the job application. Now let us see what the logs look like. So ideally in place of unknown, you will have job service everywhere. Okay, because that's the application name now. So yeah, you can see quite a few logs appear. So you can see this is the Netflix discovery client, initializing Eureka, resolving Eureka endpoints. Okay, there are some more logs. And if you scroll down, okay, there are some checks that are happening and here getting all the instance registry info from the Eureka server. Okay, so it's fetching the registry and here like com.netflix.discovery client, the response status is 200. Fair enough. So if you scroll down here, so registering application job service with Eureka with status up. So our application has been registered as per the logs with Eureka server with this particular name, job service. Okay, and there are some more logs that appear. Okay, and then the server starts. So if you head over now here, and if you restart, you will see this particular application up. Okay, and this is the URL of this particular application, and it's called job service. So we have successfully registered our first service with Eureka. So the registration is successful. Okay, you are getting this alert, which is fine. Okay, so this is a warning that is coming up because Eureka is not able to ping some of the instances, service instances, which is fine. So we can ignore this. But the main part is we have successfully registered the job service. So that's about how you can register a microservice to Eureka server. Welcome back. So now it's time to register the company microservice with the Eureka server, and company microservice will be registered as a client. So we have already followed this process for job microservice, and what I would request you all is to take this up as a challenge. So try to do this yourself and try to register company microservice with the Eureka server. So there are a series of steps that you need to follow, which we have already taken a look at. So try going hands-on on this, and what I would request is you can pause the video right now and come back and watch the solution. So welcome back. I hope you all had a chance to pause the video and attempt this yourself. If you were able to, congratulations. If you were not able to, that's perfectly fine. The goal of this is to get you hands-on with coding. Okay. So if you're not able to, that's perfectly fine. So in order to get this done, or in order to get or register company microservice, we need to first start with dependencies. Okay. So I'll head over to Spring Initializer. We'll copy the Spring Cloud version. Okay. And I'll just paste this below the Java version. So the Java version is mentioned here. I'll add this here. And then let us add the dependency for so this entire tag, the dependency management for Spring Cloud. Okay, so I'll go over here and just below dependencies, I'll add this. Okay, and then I'll add the dependency for the Netflix Eureka client. So this is something that we will need so that it registers successfully. Okay, so here I'll add this dependency. Now, once you are done making changes to pom.xml, refresh or reload. So once you reload the Maven changes, dependencies are brought in. And what you can do is I'll just go to jobs application.properties and I'll copy all these properties. Okay. And then in the company microservice, I'll go to main resource application.properties. And here I'll paste the same properties. Okay. But here we also need to add name. Okay, so what I'm going to do is I'll pick up this name over here and I'll paste it over here. And here, instead of job service, I'll change this to company service, like so. I'll hit save. Okay, and now it's time to run our application. Okay, so this should work perfectly fine. Now, one thing I want to make a note over here is we have just added the dependency here. Okay, and we are just adding some properties to application.properties. Okay, and the entire mechanism of registering this application with Eureka server is taken care under the hood. Okay, now this is what auto configuration of Spring Boot in action. Okay, so here we are not doing much. We are just telling Spring Boot that, hey, I need this dependency to be added. Okay, and why would you add this dependency? So you would add this dependency if you want your application to be registered with the Eureka server, right? Now, if you're adding this dependency, so Spring Boot knows that, okay, so it needs to register this with the Eureka server. And that is when it starts looking for these properties that, hey, where is Eureka server? You need to tell me, and what all I need to do, and what is the name of the application. So if the application name is not there, it will register it as unknown. Okay, so if I comment this, so let me comment this and let me try to run the application without configuring the properties. Okay, so I'll go over here and let me rerun the company microservice. So let us see what happens. So the application is up and running. Okay. And if you scroll up over here, let me scroll up. So here you will see this message, registering the application with company service, registering the application company service with Eureka with status up. Okay. This is something weird right now. So if you go over here and if you refresh this Eureka page, you will see company service appear over here. And if you come to our source code, we have actually commented these properties. So what is happening actually over here? So if you comment this out and if you run the application, it will still register. And this is because of the auto configuration. So what happens is, by default, the values for these are provided. So this is the default value that is provided, even if you don't add this. This register with Eureka property is also set to true by default, and fetch registry is also set to true by default. Now, if it's set to true and if it's auto configured by default, why would you explicitly specify this? So you should explicitly specify this because it's a good practice. And in future, if you make use of Spring Boot profiles, so there is this concept wherein you can have different application.properties file for different environments. So in that case, it's best to have these definitions across different properties files for different environments so that you know which environment is pointing where. So you might have different environments like dev, prod, and so on. Even QA, you might have a QA environment. So that's the best practice that you should follow from day one. Okay. And this was like Spring Boot auto configuration in picture or in action, I should say. Now, if I save this and if I run this again, I'll absolutely get the same output. Okay. So let me rerun. Okay. So it's rerunning. So essentially it's really good. So I'm teaching you the concepts, but it's really good that you experiment with things. Okay. What happens if I comment out a certain thing? What happens if I modify a particular thing? This is really, really important when you are learning programming because it helps you understand what's exactly happening under the hood. Because right now there are frameworks and everything makes your life so much easier. But what's happening under the hood, that is something that you need to understand. And how will you understand? By experimenting and tweaking the code. So yeah, the service is up. Now, if you go over here and if you refresh, you will see company service appear over here. So yeah, we have successfully registered 2 microservices with Eureka. Hey there, welcome to this class. So far, we have 2 of our microservices registered with the Eureka server. Now let us understand how we can make use of service names to communicate with our microservices. So the entire goal of introducing Eureka server was to make use of service names. Okay. So here in the browser, if I try to access the jobs API, so here I have localhost :8082/jobs. This is going to work with no problems. But what happens if I change this to job service? So if I say job-service. So let us see what happens. So this is not going to work. Okay. And even if you copy this, so if I copy job service here and you can see it did not work. Now, if I copy the job service and if I head over to, let us say, Postman here, and if I paste it over here, okay. So let me remove this extra part. And if I send this, this is also not going to work. Okay. Now, why doesn't it work? Because accessing the service via its service name directly via browser or Postman is not typically possible because Eureka does not act as a router. Okay. So Eureka is a service registry and it is used or intended to be used by other microservices within the system and not by the external clients like web browser or Postman. So if you want to access your microservices via the service names in the browser or Postman, you will need to set up something like a gateway or something like that. So gateway will handle all the requests and it will do all the routing. Okay, so this is not going to work if you try to access it. So I'm just going to press Control Z here. Okay, and I'm just going to revert this to localhost and get this working. Okay, so this is about communicating with microservices externally, all right, using the service name, of course. Now let us see how the communication would work within microservices. So let's say if we communicate to company service from job microservice, okay, how is that going to work with the help of service name? So let us say if I switch over here and here, if I say here in job service implementation, if you go to job microservice, in job service implementation, we are already communicating with the company microservice here using localhost. So let us say if I change this to company-service, like so. So I'm using service name now. Now let me rerun the server. So what happens with this? So I'll tell you what will happen. This is not going to work. And let us test this. Okay. So we have the service register properly. And now if you head over here and if you try to get the jobs, you get no result, 200 OK. Now this worked because if there are no jobs, we are not communicating with the company microservice. So this worked. Now if I add a job, we have a job with company ID 1. Now if I say get jobs, this is going to break. Okay. And this is not going to work. So there is a reason why this does not work. So the reason is because we are using an instance of REST template over here. Okay. So if you switch over to the code, you're going to see all the errors here. Okay. And if you scroll up at the top, you're going to see unknown host exception. Okay. And there is a reason for this. So the reason is we are making use of REST template to make the call. Now REST template instance here is not load balanced. So we need to get a load balanced instance of REST template to be able to make a call to this particular service with the help of service name. Okay. So how do we do that now? So in order to do that, we need to create a new class over here. So I'll create a new class in job package. I'm going to call this class as app config. Okay, like so here. And here I'm going to have a definition. So I'll say public. I'll have a method here, REST template, like so. So this is going to return an instance of REST template. I'm going to say REST template. And this is simply going to return new REST template. Okay. Now, what is the benefit of doing this? This is going to be load balanced. So we are going to add this load balanced annotation over here, as you can see. Okay. Load balanced. And I'm going to tell that this is a bean. Now, what does this mean? So specifying bean tells Spring Framework that it needs to manage this object, or it needs to manage the objects of this class. And here I'm going to specify configuration. So what happens is load balanced annotation configures the REST template to use load balancer client under the hood. And this is a client that is capable of using service IDs registered with Eureka to locate the services. Okay. So in that situation, load balanced annotation is needed, and it's critical when you're working with Spring Cloud and Eureka for service discovery. Okay. So we are making use of this, and this annotation allows Spring Cloud to create a proxy for the REST template that is intelligent enough to understand the service IDs from Eureka and to load balance the requests across instances of different services. Okay. Or across instances of a particular service. So you get better capabilities or a REST template that is much more intelligent in that case. Okay. So here, now what I'm going to do at the top, I'm going to say we create an instance of REST template. I'm going to first say auto wired. Okay. And I'm going to say REST template here and REST template, like so. So we created an instance of REST template and we are saying auto wired. So this auto wire, what this auto wired means is we are telling Spring Framework to provide us the instance of REST template on runtime. And this is possible because we have mentioned or specified this as a bean. So bean means Spring is going to take care of managing that. Okay. So I'll scroll down here. we don't need this REST template. So I'll just comment this out. And now we are set. So we are using the intelligent version of REST template to call our microservice. So let me rerun this. So we'll rerun this and we will see the output as to how it works. Server is up, and if you head over to Service Registry, you should see the registration is successful because you're seeing the name here. Okay. Now let me try getting all the jobs. Of course, it will be empty. So we need to add a job and we need to send the request. So this time it will work perfectly fine, as you can see. So you're getting the results, which means the communication or the inter-service communication between different microservices is working with the help of service IDs or service names, whatever you want to call it. So yeah, these are some important concepts that you need to remember and understand about Eureka server and inter-service communication. Okay. And it's important that you experiment a lot with the code, and that is what we did. All right. So I hope you have a clarity now as to how this works. Now, one thing I wanted to show you is here we have registered job service and company service. Okay. So if you want to deregister, you have to just stop the service and this name is going to go away from here. Okay. So if you want to unregister or deregister a particular service with Eureka server, you have to just stop the service and it will deregister itself. So that's about the communication and load balanced REST template. Thank you. Hey there, welcome to this class. So far, we have 2 microservices registered with our Eureka server. So now I would want you to take up a challenge wherein you would register the ratings microservice with the Eureka server as well. So we are aware of the steps that we need to take, and this will be a good practice for you. So I would request you all to pause the video right now and get this rolling. So welcome back. I hope you all had a chance to do the solution. So let us get started with the solution ourselves. So the first thing we need to do here is we need to add all the dependencies like we have done for the other 2 microservices. So I'll get the cloud version tag over here and I'll set it in reviews microservice. So I'll close everything else. I'll open reviews microservice, pom.xml, and I'll even open up application.properties and I'll close this. So here I'm just going to scroll to the top and just after Java version, I'll add the Spring Cloud version. Now we need to add the dependency over here. So the dependency is Spring Cloud Starter Netflix Eureka client. Okay. So I'll add this over here. So I can add somewhere over here. And also we need to add this dependency management tag for Spring Cloud. Okay. So I'll go over here and just after dependencies, I'll paste. So we have made few changes to pom.xml and I'll hit refresh. So this refresh should work perfectly fine. Now we need to head over to application.properties. And what I can do is I can open up the application properties of any other microservice that we have configured to work with Eureka, and I can like get some tags from there. Okay, so I've opened the job microservice here. Okay, so what we need is we need to copy this entire thing over here like so. So we are aware that this is known as, this is like to make this particular service aware of the Eureka server endpoint. We are telling register with Eureka true and fetch registry as true. We need to specify the service name. So we'll add the service name. Otherwise, our application will be registered as unknown. Okay, so the service name can be review service. So the name is added. Okay. Now what we can do is let me restart this particular service. Okay. So let us see the output and let us see whether it successfully registers or we get any issues. We should not get any issues. So if you scroll down here, okay, so you should see this message over here if you scroll down. registering application review service with Eureka with status app. Now, if we head over to the Eureka page and if you refresh, you should see review service with its endpoint appear over here. So the service has been successfully registered. So this is how you can get review service registered with Eureka server. Hey there, welcome back. So what are we going to do in this lecture is we are going to update the GET request to get a single job. So as of now, if you add a job over here and if you try to get a job, we are getting the job object. But what we need to do is instead of company ID, we can even get the company object. So along with company ID, we'll have the company object as well. So this is something that we need to do, and we will be making use of service discovery and inter-service communication. These are the two mechanisms that we are going to do hands-on, and we are going to implement this. Okay. So without further ado, let's get started. So I'll switch over to IntelliJ and I'll close everything. So I'll close all the tabs. I'll switch over to jobs microservice, and within jobs, I'll straight away go to the file which I need is controller and the implementation. Okay. So here in controller, if you scroll down, you have this get mapping. Now this is a get mapping that is responsible for getting the jobs by ID. So what we are going to do is we are going to go to this service method here, which is being used, get job by ID. And this is the method that we are going to modify over here. Okay. So what is the modification we need to do? So we need to add company object to the response. So instead of job, we need to have job and company. And we already have a DTO class for this. So this is job with company DTO. So this is what we are going to return. So to get all the jobs, we were returning a list object of this class, but we don't need to return the list. Instead, we are going to only return this object. Okay. And the reason is because we are only fetching one job. So I'll add this over here. Okay. And now what I need to do is here I'm getting the job. Okay. So I need to remove return from here. Okay. And I need to accept job into a job object like so. All right. And now we need to transform this job into a job with company DTO object. Now, how do we do that? So we have already done this and we have created a method for this. So this is the method which is job with, which returns job with company DTO, and it converts a job to this particular object and it manages everything, like it does the query to the company service and all. So having this method makes life much more easier, as you can see. Okay, I can call it from multiple service methods and multiple mappings here. So I can simply say return and I can say convert to DTO and I can simply pass the job object. That is it. So our job is done here. Now we are getting these red marks, and this is because in the service class, if you go here, we are returning the job object. So we need to say job with company DTO. And if you come back, the red marks go away. Now there is one more place where we will be getting the red marks, and that is in the controller. Okay. So the reason we are getting this in the controller is because we were accepting the job object here, but now we have changed this. So we can simply change here. We can say job with company DTO, and here also we need to say job with company DTO. Okay, so this will be job with company DTO object. It's important that you rename the objects as well, and the reason for this is it's simple, so that you know, okay, what is this object holding. So if you call this object as job, and if someone else is looking at your code, you will think, or that person will think that this object is holding job, but actually it's not. It's a instance of job with company DTO. Okay, so I'll say job with company DTO here as well. And I believe we have solved it. We have all the red marks gone. So what happens is whenever we get a GET request, we head over to the service class and we call this method. Within this method, we are getting the job, the instance of job with the help of this ID, which we got from the controller. And we are converting this job into DTO. And how are we doing this? We are doing this with the help of this method, which we already wrote earlier. And this is a method which takes the job object. It sets the, it creates the object of job with company DTO class. It sets the job inside. It fetches the company. And for that, it retrieves the company ID here. And then it sets the company over here. And then it simply returns the object. So we are simply making use of this method here, which is enabling us to convert our jobs to DTO. And we are simply returning the output of this method here. Okay, so this is the entire mechanism. Let us rerun our service. So I'll rerun the job microservice. Let me rerun and let us see if we are getting any errors. So ideally we won't get any errors because I believe we have done everything correctly. But still, when it comes to programming, you never know. So yeah, the application is running and here we can try getting jobs. We'll create a job added successfully. You have one job added. Now let us try to get a job with ID 1. So earlier we were getting only the job object. Now you will get job and the company object as well. So we are getting the response and this thing is working perfectly fine. So now we have an API with job and company details. And I hope you all have a clarity as to how the communication works in microservices architecture with the help of Eureka server. Welcome back. So here now I'm on Postman and I have this query executed. This helps me get a single job from my jobs microservice. And as a result, I'm getting the job object as well as the company object. Now the thing is, I don't like this response structure. Okay, so I want to restructure this a bit. I don't want this job keyword over here. I don't want this in the form of nested JSON over here. So this is a JSON within an external JSON. Okay, so how do I change this? So to make these changes, you can head over to the DTO class. So here I'll open the DTO. Now here, since we have added the objects of both the classes, they are being converted into JSON over here. Instead, what I can do is I can go to the job class. So from the job class, I can copy all the properties. I can exclude company ID here and I can just add them over here. Okay. Now let me remove these getters and setters and let me add the getters and setters. Okay. So I'll add the getters and setters for the newly added fields like so. So you can see this class has been modified now. Okay. We don't need to, or we will need to make any changes here. So let me see. Okay. So we are setting the job. So here we won't be able to set the job. So this error says that the setter does not exist, and it's absolutely correct. It does not exist. So what do we need to do? So with the help of this particular thing, we were able to set the job. Now what we can do is to solve this, we can have a mapper created. Now what is the role of mapper over here and why do we need it? So we need a mechanism to map job and companies with the job with company DTO. Okay. So this is a DTO that we have created and we need a way to map the company objects and the job objects to this particular DTO. And that is what the role of a mapper is. So what I'm going to do is, let me head over to the project. I'm going to say new Java class and I'm going to say mapper dot job mapper. So what I'm doing is I'm creating a new package called mapper, and within this package I'm creating job mapper class, and I'll hit enter. So you will see job mapper appear over here, and here I'm going to have a definition of a method which is going to do the mapping for us. So I'm going to say public static. So after static we will have the return type. So I'll say job with company DTO here, and I'll say map to job with company DTO, like so. Okay. Now here I'm going to have the parameters. So I'm going to say job, and this is going to be the job object. And then we are going to have company, which is company object, like so. And I'm going to have open and close square braces. Okay. Now let me close this and let me reformat the code. Okay, so now what we can do over here is we need to create an object here. Okay, so I'll say job with company DTO, and I can say job with company DTO here is equal to new job with company DTO, like so. And here I'm going to start mapping everything. Okay, so I'll say job with company DTO dot set ID. So we need to set the ID. Then we need to set the title. So this is job title. We need to set the description. So we need to set one by one all the parameters here. Okay, location, max salary, and we also need to set the min salary. And let me see if anything is missing. So I'll say set max min ID. We don't need, so we need to set the company. So company is missing. Okay, so these are the parameters that we need to set. So I'll say job dot get ID. Okay, so this is done. I'll say job dot get title. This is also done. Job dot get description. I'll have job dot get location. Job dot set max salary, and job dot get min salary. And I can even have job dot get company or set company, sorry. Okay, so we don't have job dot, but instead I'm just going to pass in the company object. Okay, so this is a company object that we are accepting. Okay, and now I'm just going to return this object. So I'm going to say job with company DTO, like so. And we are done. So this mapper is created. Now what we need to do is we need to use this mapper over here. So I'm going to delete this line here. Okay. And here, what I'm going to do is I'm even going to remove this line. So let us remove that line too. Now here, after we get the company object, I'm going to say job with company DTO. I'm going to create the object is equal to job mapper dot map company with DTO. And I'm going to say, I'm going to say job, comma, company, like so. Okay, and I'll end this with a semicolon. Okay, so this should be fine now. Let me move this to the next line. Okay, so this is much more readable now. And what I've done is I've removed everything. So I've made this code a bit light. So we are fetching the company object using the job object, and we are passing the job and company to a new mapper that we have defined. And this is a mapper that exists here. Okay. And with the help of this mapper, we are mapping the job and company objects to that of DTO. Okay. So this way you can now imagine, like you can modify this to any structure because you have a mapper now and it does the job of mapping. If you do any changes over here in the structure, you have to just change the mapping here. That is it. And it will take care of everything. Okay. Now what I can do is I can simply rerun this application. So let me redeploy job, and this should result in the structure changes in the response. Okay. And that is what we wanted. So application is up and running. Okay. Registration status 204. And if you go over here in Postman, this was the response that we were getting earlier. Okay. Now if I send the request again, we won't get any output. Okay, we got an error. So let us take a look at the error that we got. Let us understand. Job is null. Okay. So we need to handle the null case as well. Okay. So we need to handle null, which we have not handled, but the mechanism is working. So if I create a job and if I try to get a job here, you can see the structure has changed now. Okay. So you can see the structure is working perfectly fine and there are no issues as such. So we have modified this to a better output or a better endpoint. And this is applicable also for this because the DTO is same. So if you try to get all the jobs, you will see this is also updated now. And this is because the DTO is same behind the scenes. So this is about how you can restructure the response to match your requirements. And this you can do with the help of DTO. So it's getting fun and exciting. I hope you all enjoying. So that's about this class and I shall see you all soon. Thank you. Hey there, welcome back. So right now we have our microservices up and running. Now the thing is, if you go to the jobs API and if you fetch the jobs, okay, we don't have any jobs. So let me add a job. Okay. So there's this one job added. Let me add a company also. So there is one company that exists. So I'll try fetching the job. So here, if you fetch the job, you're getting the job details as well as the company details now. But what I want to do is I want to even add the review details. Okay, so we don't have that added yet. So let us work towards adding and bringing in review as the part of the jobs API. So I'll switch over to IntelliJ. Now what we need to do is there is a series of steps that we need to do. So for company, we went to jobs microservices, and here in external, we created the company class. And this is a class that represented the company object. And then we mapped or we added company into the DTO object here. So DTO class. And then with the help of mapper, we created a mapping. Okay. And then there was some functionality that was written in the service class over here, which helped us fetch the company and do the mapping. So this was the process that we followed for company. We need to follow a similar process for review. So what I'll do is I'll go to the review microservice and let us see what all elements we are storing for any given review. So we have these things that we are storing here for the review. So I'm going to copy this. Now let us head over to external package in the job microservice. And here in the external package, I'm going to say new, and I'm going to say new class. And I'm going to call this class as review. Okay. So this class is created. Now what we can do is we can paste in the properties that we copied from there. Now here, I don't need to store or show the company ID. So we can get rid of this. So we can just have ID, title, description, and rating over here. All right. Now what we need to do is we need to have getters and setters for this. So I'll generate some getters and setters. There you see. So the review class is now set. Now, as a next step, what we need to do is we need to add review to job with company DTO. So here in job with company DTO, I'm going to add review here. So here I'm going to say private review like so, and I'm going to have a review here. Now what I can do is I can generate getters and setters for this. Okay, so I'll go to the end like so. And here I'll generate getters and setters. I'll select review. So we have this set now. Okay. Now what we should also do is we should rename this DTO. So this says job with company DTO, but actually now we have enhanced this DTO to also include review information. So we can just call it job DTO because this shows the job information along with the company that has posted the job and the review of the company. So I'll just right click on the class here and I'll go to refactor and I'll say rename. So here I'll just say job DTO and I'll delete this. So this is a new name. I'll click on refactor. I'll keep all the settings as default. So you will see some checkboxes over here and I'll say refactor. Now what it will do is it will refactor everything. Well, alright, so wherever we are using this class, it will refactor. And it is also asking us a couple of details here. So if I'm able to expand this, you can see. So it is telling us IntelliJ, we have created a few local variables for this particular class. And we are calling that local variable as job with company DTO. And this is most likely in the service implementation. Okay, so here, this is how we have implemented it. So since we are changing the name of the class, do we also want to rename the variable name to job DTO? And yes, of course, we want to do that. All right, so I'll say select all and I'll say OK. So the refactoring is done. So if you go to job service implementation class and if you scroll a bit, you will see the class name has been changed everywhere. And also the local variable object name. So this is the local object that we had created. So this is also renamed to reflect or match the new class. And this is also true in the controller. So if you go to controller, you will see job DTO here, which is really good. And this is also the local object that we have created. And this is also renamed. So IntelliJ makes our life easy this way. Okay, so imagine like without IntelliJ, if you're coding here and you rename the class, you will have red marks everywhere and you have to go and see, hey, we're all like, this is not working now. So I need to change, even I'll have to change the imports. So imports are also automatically managed by IntelliJ itself. So everything is renamed automatically whenever you change an object. And that's the magic. So here, if you were not using IntelliJ, you would have to come and manually change this. Okay, so now this is done. We have renamed this. Now what we need to do is we need to head over to the mapper. So here in the mapper, we need to do the mapping. But before mapping, I'd say here in the service implementation, we need to get the review as well. Okay, so here, since we are getting the company, we need to, so every company has a company ID. And with the help of that company ID, you can get the review. So now here, we need to call the review API. So if we take a look at the review API, so let us go over here. So whenever you fetch a review from the company, you get a list. So there can be multiple reviews against a particular company. Okay. And how we have handled this is here, we are getting a single object. Okay. So we won't be using get for object. We will be using exchange. So I'll say REST template dot. So I'll say exchange here. Okay. And here I'll pass in the URL. So I'll copy the URL from here like so. So this is a URL. Now instead of localhost, I need to use the service name. So the service name is review service. So I'll say review service like so. And here this needs to be dynamic. So what we are going to do is I'm going to remove this like so. And I'm going to copy this here. And here I'm going to say space and let me say job.getCompanyID. So here I'm passing in the company ID. Okay. Now exchange method requires some parameters. So this is the URL that we have passed in. And we need to specify the method as well. So I'll say HTTP GET. I'll specify null as the third parameter. And I'll specify this over here. So I'll say new parameterized reference type. And I'll say list here. Okay. And this list is of the type review. So this is what we are getting as the response. Okay. And I'll keep this to empty and I'll put a semicolon. Okay. Now here, what I'm going to do is I need to accept the response. So I'm going to say response entity, like so. And here I'm going to say review response, like so. And response entity has list, and it's a list of review type. So what have we done over here now? Okay, so we have not made use of get for object because we will need exchange method from REST template, and this is used to get the list of review objects. Now exchange method is much more versatile than get for object, and it's useful when the response type is a generic collection. So here you have a generic collection type, and this is where exchange is useful. Okay. Now get for object is particularly useful whenever you know that the response that you're going to get is going to be a single object. But when you get list as the return type from the API, it's better to use exchange. Now what we have done is we have passed in a few parameters. Okay, so the first parameter is the URL here. So you can see the URL that I have specified. I have specified the service name, colon, this is the port, and then I have, like, I'm calling the reviews API and I'm passing in the company ID here. Okay, now, so this is the dynamic URL that is crafted. Then I'm specifying the method type over here. So this can be get, post, put, or anything. Okay, but since it's a GET request, I'm specifying get over here. We have null mentioned over here. So this specifies the request entity that we need to send to the server. And in this case, there is no request body. So since the request body is null, we have specified null over here. Then we have the parameterized type reference over here. This captures the generic type information of the expected response. So we are telling that the response is supposed to be in this format. Okay, this is how it is working, and then we are accepting the response over here. Now what we need to do is we need to get the review response. So I'm going to say list, and I'm going to say review, and here I'm going to say reviews is equal to review response dot get body. Okay, so from the response we need to get body that we need to convert to this reviews, which is of list type. Okay, so this is done. We have the list of reviews that we are fetching from the API call, and we are doing this API call to the review microservice. Now what we need to do is with company, we are mapping job and company, right? So now what we need to do over here is we need to pass in reviews as well over here, like so. So this will be passed to this particular method. Okay, so this step is not needed actually. So I'll just comment this out. Okay. So we are already doing the mapping within this particular method. So I commented this out, and we are passing reviews also now. So I'll go to this method here now, and I'll add reviews over here. So I'll say list, and it is of reviews type. Okay, and I'll say reviews, like so. Now what are we doing with the reviews? So we'll scroll down, and here I'll say job DTO dot set review. Okay, and I'll pass in reviews. Okay, so we are getting an error here because we are passing in the list. So if you go to job DTO, here we have specified that a single job will have only one review, but actually that is incorrect. So we will have the list of reviews. So I'll just make that modification here. Okay, and I'll call this reviews. And with this change, the getters and setters will also get updated. So I'll say generate getter and setter, and I'll regenerate this. So how this works is one job is associated with one company, and then that company can have a list of reviews. Like, of course, many users will post in the individual reviews. So there will be a list of reviews, right? Now here, what we need to say is we need to say set reviews, and we are done. Okay, so this is updated now. What we will do is we'll head over to services, and we'll restart the job microservice. And the reason for this is because we have only made changes to the job microservice and not to any other microservice. So we'll wait till the application is up and running. So it seems that it's up, and we'll head over to Postman here. So we won't have any jobs because we have restarted. So I'll just add a job and I'll try to fetch the jobs. So now if I try to fetch the job, you see reviews are empty. So we need to add some reviews against company ID 1. So I'll say company ID 1, review number 1, description is also 1, and I'll add this. Now let me add one more. I'll say 2 and I'll say 2. Now let us call the jobs API. So now if you call, you will see the reviews also getting populated. Okay. So what we have done is we have added reviews into the jobs microservice, and reviews are also now being a part of the response that we are getting with the jobs API. So this is how you can work with different microservices. Now to outside world, whoever is calling the jobs API, he's not aware of the inner details. Okay, he does not know like how many microservices are being called in the background. Okay, you can even mask this URL. So you can have something like a gateway or something that you can set up. Okay, and that thing will route the request to the respective APIs. So all that can be done. But the main point over here is to show you how you can communicate effectively. And we are also making use of Service Registry, which is Eureka server. So keep that in mind. All right. So that's about this class, and I shall see you all soon. Thank you. Hey there, welcome to this class. So let us start talking about behind the scenes of Eureka server registration process. So we have a couple of microservices, and then we have a service registry, which is Eureka server in our case. So a microservice will register itself. The other microservice will send a service discovery request, and it will do that to communicate with that particular microservice. So this is how the entire process works. Now, for this to work, every microservice in the microservice architecture needs to register itself with the Eureka server. Now the question is, how does Eureka server keeps track of all the microservices and how does it manage everything? So the number one thing is registration. So each microservice instance will register itself with the Eureka server, and the registration does happen with the help of heartbeat signal. And this signal is being sent to Eureka server at regular intervals. So how does it work? So it works with the help of heartbeat signal. And during the registration process, the microservices provide information such as the host name, IP address, port, metadata, health status, and so on. So all this information about themselves is being sent to the Eureka server for registration. Now, after initial registration, so this is not the end. So this was just the registration process. Now, after initial registration, the microservice is responsible for periodically sending the heartbeat signal to the Eureka server. And this signal is an indication that microservice is still active and functioning properly. Okay, so because of this signal, the Eureka server also knows that, hey, this microservice is up and running, and it uses this to keep track of the services that are up. Now, when are these heartbeat signals sent? Now, the intervals between the heartbeat signals is configurable and can be adjusted based on the requirements. So whatever requirements you have, you can even specify a custom duration. All right. Now, Eureka server does heartbeat monitoring. So Eureka server will monitor the heartbeat signals from each registered microservice instance. And if Eureka servers stops receiving heartbeat signals for a particular microservice for a specific amount of time, it will mark the instance as down or out of service. And Eureka server will maintain the list of all the available and healthy microservice instances based on the received heartbeat signals. So this is about Eureka server and how it makes use of this concept, heartbeat signal and heartbeat monitoring, to keep track of all the microservices in the network. Now, heartbeat mechanism ensures that Eureka server has an up-to-date view of registered microservices and the health status. Okay, so now let us do an experiment. So I have a few microservices up and running here, as you can see on IntelliJ, and they all are registered with Service Registry. So if I go here and if I go to Eureka, so this is the Eureka's page. And if I scroll down, you will see like there are 3 microservices that have been registered, and Eureka server is also up and running. So this is working perfectly fine. Now what I can do is I can simply shut the Eureka server. So Eureka server is up and running. I'll simply shut the Eureka server. And now if you go to any of the microservices, you will start seeing some stack trace. So let us wait for a while, and essentially you will see the heartbeat mechanism in action because this is not working. Okay, so if I refresh this, the server is down. Okay, and here now if you go, let's say we go to review, so we see some stack trace now. Okay, so you can see, so this stack trace has started coming in. Okay, so you can see over here com.netflix.discovery transport exception cannot execute any request on any known server. Okay, and if you scroll down, it is saying it was not able to send the heartbeat. Okay, so it is sending the heartbeat to the Eureka server and it is not able to. So you see one more stack trace and it tried to send again. Okay, and you'll see this again and again. Okay, so as long as it tries, it is going to print all this as a stack trace. And you can go in the job also. So here also you will see the same thing. Okay, so if I say Control F and if I search for heartbeat, and let us say if I search in company microservice. Okay, so okay, I need to search on this side. So I'll say heartbeat. You can see a lot of things that have been highlighted with this keyword heartbeat was unable to send the heartbeat. And this is for all the applications. Okay, so you will see this coming in for all the application. So if I search for job also, so here if I search for job, so let me say heartbeat, and you can see send heartbeat is the function or the method that is being used, and it's throwing an exception here. Okay, and you will see this message here was unable to send the heartbeat. So this is from job service. So this is the proof that this is how it works. And now if I turn this on, okay, so let's say I turn on the review, and if I scroll down in job microservice, there is literally an exception in the end. So service was up and running. Now if I refresh, we don't have any instances up and running, and now slowly everything will come in. So you can see company was registered. So if you scroll down here, you can see it got registered. Registration status 204, which means that it got registered. For job, it's not yet registered. Reviews, let us scroll down and see what's up with reviews. It's registered. So jobs is pending. Okay, it got registered too. So now if you go over here, okay, you can see all the 3 microservices have been able to register themselves. So this is how this heartbeat mechanism works. And with the help of this, Eureka server is able to keep track of all the microservices that are there in the network. And this is really helpful. And this entire mechanism is known as heartbeat mechanism. All right. So that's about behind the scenes as to how Eureka server works. Hey there, welcome back. So let us start talking about OPENFEIGN. So what is OPENFEIGN and why should we use it? So Feign is a declarative web service client that is designed to make writing HTTP clients easier. Now what does this mean? So to make regular HTTP request in an application, you might have to deal with a lot of boilerplate code. Okay, so for example, we have a microservice, and in order to call another microservice, we need to do an HTTP request because we'll be making use of HTTP protocol. So in that scenario, you will be using REST template. Now the thing about REST template is there is a lot of boilerplate code that you need to write again and again. For example, this is what the source code for doing a simple call to another microservice looks like. So here you are making use of REST template object, and you're making use of this method, and you're saying get for object, and you're passing in the URL. Now you have also passed in some parameters, like you are expecting the response to be masked or wrapped into this particular class object. Okay. So the return type that you will get will be a company object here. Now the thing is, if you have to make multiple connections, you need to write a lot of boilerplate code, and you need to make connection, you need to handle retry by yourself, you need to process the responses and so on. Now what does Feign do is it abstracts all these away and allows you to write HTTP request as if they were simple method calls. So without Feign, this is the source code. And if you integrate OPENFEIGN into your project and start using it, this is what this line of code will become. So now here you have a client created, and you are just saying get company, and you have passed in this parameter. So this is like a normal method call that you are doing. And in the background, OPENFEIGN will do the job of communicating to the microservice and retrieving the company object and giving it to you. So it becomes much more easy, and you don't have to deal with like a lot of stuff. A lot of boilerplate code is reduced, and also you don't have to type in the URLs again and again. So everything is now managed in the company client over here. So this is how OPENFEIGN makes your life easier whenever you are making use of different web services. Now, why use OPENFEIGN? So the number one reason is easy to use. So Feign simplifies HTTP API calls by creating a sort of proxy, and then it implements HTTP requests behind the scenes. So all of this is abstracted from you, and it just makes things look a lot more easier than you would be doing the normal way. Another benefit is integration with Eureka. So just like REST template, Feign can seamlessly integrate with Eureka for service discovery. Then we have built-in load balancing with Ribbon. So OPENFEIGN has built-in support for Ribbon, which is another Netflix project, and this provides the client-side load balancing. Okay. The next benefit is support for fallbacks and circuit breakers. So with Feign, you can easily integrate Hystrix, which is another Netflix project, and this project can provide fallback options and circuit breaking capabilities. So this is the reason why you should use OPENFEIGN. Now let us compare Feign and REST template. So Feign and REST template both serve the same purpose, and they both do the job of simplifying HTTP requests in the Spring application. But they do so in slightly different ways. So REST template, for example, is older, more traditional way of making HTTP requests. It is robust and flexible solution, and it does offer a lot of control, but it can also lead to a lot of verbose code, especially when you're dealing with complex requests. So this is a very simple request that we have done over here, but if you're dealing with a complex request, the code with REST template can go a lot more verbose and cumbersome. Now, on the other hand, you have Feign over here, wherein you have written some code using OPENFEIGN. And Feign is a modern solution that takes a different approach. And instead of creating a template that you fill in with specific, Feign creates a proxy based on an interface you define. And this results in very clean and simple code. So it may not offer the same level of control for complex scenarios as REST template, but still it's a really good choice for modern web applications. So this is about OPENFEIGN and REST template. Also, I wanted to mention that OPENFEIGN is also developed by Netflix, and then it was later included in the Spring Cloud family of projects. So that's about OPENFEIGN. Thank you. Welcome back. So let us enable FEIGN clients in our microservices project. So I'm going to head over to the project structure, and I'll head over to job service implementation class. Now over here, we are making use of REST template over here. So we need to make use, and we need to replace these calls to microservices with the help of FEIGN clients. So for that, we will need to add a dependency into our project. And to add the dependency, let us head over to our favorite website. So I'll say start.spring.io. Now here in the dependency section, I'm going to say add dependency. So you can search for OPENFEIGN over here, and you're going to see this option come in, and you have to select. So you can read over here that FEIGN is a declarative REST client, and it creates a dynamic implementation of the interface that is decorated. Okay, so what I will do is I'll go to explore. Okay, so this is the Gradle dependency that has been added. I'll change to Maven, and I'll go to explore. Now we have the Maven pom.xml. So what I will do is I'll copy this entire thing, and I'll switch over to my project, and within jobs microservice, I'll head over to pom.xml here, and here somewhere in the dependency section, I'll just add this dependency that I have copied. So I have this dependency in, and whenever you make any changes to pom.xml, we need to reload the Maven changes. So I'll hit reload, and Maven changes are being resolved. So you can see resolving dependencies of the project. So this is done. Now what we need to do is we need to enable OPENFEIGN, and we need to tell Spring Boot that we need to enable FEIGN clients in our application. So for that, we'll head over to our main application file, which is job ms application. Here you will find this annotation, Spring Boot application. So just before this or just after this, you can add this annotation called enable FEIGN clients, and you can add this. So you can see this import statement will be added in the import list, and this annotation will tell your application that, hey, we are making use of FEIGN clients, so please enable them. Now what we can do is we can start defining FEIGN clients. So if you head over to job service implementation, here we have two API requests that we are doing. One is to company service, and another one is to review service. So we can replace these calls with the help of REST template. So these calls are being done as of now with the help of REST template. So we can replace these calls that are being done with the help of REST template, and we can make use of OPENFEIGN here. So I'll go over here and I'll create a new package. So I'll say new, and I'll say package, and I'll call this package as clients. So we are going to have clients defined over here. Now the number one client that we need is company client. So I'll say company client, and we need to declare this as an interface. So just make sure you select interface over here, and I'll say enter. Now here in company client, I have an interface declaration. So I need to add an annotation. So I need to say FEIGN. So you can see this annotation come in FEIGN client. So this annotation tells Spring Boot that this is a FEIGN client, and then here as a parameter you can say name, and the name of the service is what you can specify over here. So I'll say company service, like so. So this is defined. Now over here, what I need to do is I need to create a method. Okay, so I need to declare a method. So I'll say get company. So here, if you go to the implementation class, here we are making an API call to this particular URL, and we are getting the company object as the response, right? So we need to create a method. We need to say get company, and this method will take a parameter because our API takes one parameter, which is the company ID, right? So whatever dynamic parameter we are passing in the API becomes the parameter of the method, and whatever is the return type of this API becomes the return type of the method. So here I'll say get company, and I'll say long ID, like so. Okay, and this method will return company object, like so. Okay, so this is done. Now we need to specify the URL as well over here. Okay, so what kind of request should this client do to this particular microservice or this particular service, company service? So we need to say get mapping. So here we are creating mappings, and I need to specify the URL over here. So I'll say companies slash, I'll say ID. Okay, so this is a structure. We have companies slash ID over here, right? So we have added the same thing over here. Now ID we have added into curly braces, and this is because that it will be dynamic. And how do we tell like from where we are getting this ID? So we will be getting this ID from path variable, like so. Okay, you can even specify the name over here of the parameter, which I'll do. So yeah, so this is the entire definition of the interface. So we have defined an interface which will do the API calls for us, and it will make use of OPENFEIGN. All right. So this is what you need to do. If you need multiple services, or if you need to call multiple URLs from this particular service, you need to add multiple methods, and you need to specify the mapping and the method over here. All right. So that is what you need to do, and the job will be done. So we have now defined company client. So we can go to the implementation class, and now what I can do is I can simply remove this entire thing. Okay, and I need to say company client dot, I need to say get company. So get company is the method that we created, and here I need to say job dot get company ID. So this is what we need to do. But the question is, from where do we get the company client? So to get the company client, what we need to do is we need to create an object of company client, and that is something that we can do over here. So here I can say private company client, like so, and I've created an object of company client, and I can add this over here. So I can say company client, like so, and this dot company client, like so. We have created an object of company client, and the error is gone. Now we need to do the same for the review service as well. So what I will do is I'll create one more interface here, and I'll call this interface as review client. So I'll say review client, and I'll mark this as an interface. Now here I'll say, so I'll add similar things as to what I have added over here. Okay, so I'll copy this first annotation and I'll add it over here. Okay, now instead of company service, this is review service, like so. And here we have this particular method, and I'll come over here and I'll add this over here. Now there are some changes that we need to do depending on which API we are calling. So we are calling the reviews API slash reviews. So in the end, like after the host name, we are passing in reviews. So the path is reviews, and then we have company ID, which is going in as a request parameter. So what we can do is we can say slash reviews, and here instead of path variable, we can have request parameter, and this request parameter can be company ID, like so. And here I can say company ID, like so. Okay. Now this will be get reviews. Okay. And this will return a list which is of reviews type. Okay. Like so. So yeah, so we have created an interface which is review client. It talks to review service, and we have created a get mapping which accepts a request parameter called company ID. And what is the output of this method? We get a list of all the reviews that belong to a particular company. All right, so this is done. Now, in a similar way to company client, we need to create an object of this particular interface. So we'll say private review client, and I'll create an object here. And here I'll say review client. Okay, like so. And here I'll assign this. So I'll say this dot review client. So we are done doing this, and now here what we can do is we can just do away with this entire thing. Okay, and I can simply say, so list of review, and here I'll say reviews is equal to review client dot get reviews, and here I can say job dot get company ID, like so. Okay, so this is done, and we can do away with this as well. Okay, so you can see like how we have simplified this particular thing. Okay, and like it's the code has reduced considerably. Okay, and we are relying now on the FEIGN clients which we have created, which are interfaces, and they will do the job of calling the REST API on our behalf. So let us test this, and what we can do is we can rerun the job application. So I'll rerun this, and let us wait for it to get started. So now our application is started, and let us head over to Postman here. So I'll open Postman, and here let us try calling jobs. So you will get an empty array. Let us create a job. So job is created successfully. Now let us try getting all the jobs, and you can see we are getting all the jobs along with the reviews. So reviews and ratings already exist, okay, because they've already created, and we just created a job, and we can see like the communication happening properly. Okay, now there are a few things that you need to make a note of. Okay, so if you go over here and if you go to app config, we had created app config class in the earlier sections. Okay, and we had defined app config when we were planning to make use of REST template. And the reason we had defined this because we needed a load balanced version of REST template. And that is because we were not able to work with or get this working with these service names. Okay. Now with OPENFEIGN, you must have noticed we have not added any load balance annotation or any such thing. So we have simply created the interface. We have specified the microservices name and everything, the URL as well, and also all the parameters, and we are done. So we don't need to like define all of this with OPENFEIGN. Okay, and as for REST template, like we can get rid of this bean now. Okay, so this is a bean that we had defined, and we can simply remove this bean entirely if we are moving to OPENFEIGN entirely. Okay, so this won't be needed. You can keep this only if you are using this in the other parts of the application where you are not ready to replace those API calls with OPENFEIGN yet. Okay, then we can keep this REST template bean. And remember that FEIGN provides a more high-level way to call HTTP services, and it includes things like automatic JSON conversion, error handling, and more. Okay, now OPENFEIGN, as you have noticed, also reduces a lot of boilerplate code that we were earlier writing, and it makes the code easier to read and even maintain. Okay, so here we had hard-coded the URLs, right? Now, imagine now if any company service or any name changes. Okay, so this name changes from company service to something else. So you have to just make change at one place. It's organized. You have all the clients defined in the package. Okay, so it's easier to maintain, and that's why many developers in the microservices world prefer using OPENFEIGN when they work with microservices. Okay, also keep in mind the load balance annotation is not used with FEIGN clients. Client-side load balancing is done automatically with OPENFEIGN. And when you use the FEIGN client annotation, okay, it takes care of the load balancing for you. Okay, now FEIGN or OPENFEIGN under the hood uses ribbon. Now, what is ribbon? So ribbon is also used by REST template when you annotate it with load balanced. Okay, and it is being used to function properly. So in app config, when we said load balanced, it was like we had ribbon being used internally. Okay, so that is why when you switch to OPENFEIGN, you don't need, in fact, REST template bean with the load balanced annotation anymore, because the FEIGN clients are load balanced and it handles everything for you automatically. So that's about OPENFEIGN and how can you implement it in your project. So let us start talking about this fascinating topic that is really crucial in modern web application architectures, which is distributed tracing. So in monolithic applications, tracing was a simple process. So if you want to track a request from its initiation to its end, all you need to do was to log each step with a single application. Okay, and what I mean by tracing over here is the process of tracking a request from the beginning till the end. That is what tracing is. So when we were building monolithic applications, it was easy to trace a request. You could use logging and all to trace what's happening. However, as we moved to microservices architecture, things became a little bit more complex. Okay, and the landscape has become significantly different. So instead of single large application, we now have numerous smaller ones, and each are responsible for different part or different kind of functionality that they would offer to the application. Now, there is also a possibility like these applications might be written in different languages. So you might have one microservice in Java, another microservice in Python, and so on. Like you don't know. Okay, and even the database might differ. So one might use PostgreSQL, one might use MySQL, another one might use MongoDB. Okay, and everybody is on different server or container. Now, when you make a request in such a distributed system, it typically goes through several of these microservices. Now, imagine a scenario where something goes wrong, like a request is slower than expected or is failing altogether, or something is happening with that request which is not expected. So what would you do in such scenarios? You begin investigation, but investigation in case of monolithic is simpler. But how would you do this in case of microservices? Like there will be several questions in your head, right? Like which service is causing the delay, or which service is giving you the errors? Where is the request failing? Okay. Now, what you need to do is in such scenarios is you have to go and access the individual logs for each service. And this becomes an immense task. Like if you have like 50 or 30 or hundreds of microservices, like this is impossible. Okay. Like, so basically there is a need essentially to get a view of the request as to how it's traversing through different microservices and what is happening with that request. Okay. And we need to get a view of this with every microservice. So if a request is going through multiple microservices, what is happening when it's going to each microservice? Okay, so that detail we need to have. And this is a problem that distributed tracing solves. Okay, so what is distributed tracing? So distributed tracing provides a method for you to track requests. Okay, so essentially it enables you to trace your requests from start to end, or from its inception and as it travels through each microservice and until it's completed. Okay, so this is what distributed tracing is, and it gives you a view of what's happening with the request. And with this, you can solve a lot of problems. You have a holistic view or a Hawkeye view of what is happening with your request and where your request is creating errors. Now, what are the problems that distributed tracing helps us solve? So the number one problem is the request visualization. So distributed tracing allows you to visualize the flow of the requests as they propagate through different services and components in a distributed system. Okay, it helps you understand the dependencies and what kind of interactions there is happening with different services within the microservices network. And it also gives you a clear picture of how your request is traversing your architecture. Okay, so this is a number one problem. Second problem it solves is to identify performance bottleneck. Okay, so since you are now able to trace the request across different services, with distributed tracing, you can now identify the performance bottlenecks and even trace latency issues. Okay, so you can analyze the duration of each step in the request flow. So for example, if your request is touching upon 5 microservices, you can check the duration of each step, like for first microservice, second, third, fourth, and so on. Okay, and you can make a note or pinpoint the services or components that are contributing to the delays or high response time. So this way you have an identification method using which you can know the culprit. Okay, and with the help of this, you can take the right actions, you can inform the appropriate teams, and you can enhance the performance of your overall system. So this is the second problem. Then the third problem we have is error analysis and debugging. So in microservices architecture, there is a possibility that an error might occur. Now, it can be challenging to identify the root cause as to which service caused that error, what happened to that particular service, and why the request was not fulfilled. So with distributed tracing, you can easily identify the error as to where the error is happening, and you can capture the complete trace of the request. Okay, and you can also include the errors any encountered during the way and so on. Okay, so it allows you to trace back the sequence of events and identify the service or the component that was responsible for the error that you have got, and because of which your request was not fulfilled. So that's another problem that distributed tracing solves. Then it also enables you to track dependencies. So this is another problem that is really good and it's solved by microservices. So this is another problem that is really good and it's solved by distributed tracing. So microservices architecture often have complex dependencies between the services. So there is a possibility that one service might be dependent on a response from another service. So with distributed tracing, you can get a view of what sort of dependencies exist in your architecture. And by visualizing the request flow and tracing dependencies between the services, you can identify how changes in one service will impact others, and you can even detect any cascading failures if they happen in your architecture. So it becomes really helpful this way. So the next problem that distributed tracing solves is of performance optimization. So with distributed tracing, like we discussed, you can identify the areas of system that can be optimized. And by analyzing the request flow, timings of various steps, you can identify opportunities to reduce the latencies, optimizing resource usage, and also improving the overall system performance. Okay. Now, this can also help you with capacity planning and scalability. So you can get some insights into how the performance of individual services and overall system is. And you can use this information for capacity planning and scalability efforts. So by understanding the load and performance of different services, you can allocate more resources to a particular microservice that might be having more load and is acting a bit slower. So you can add more resources there and you can scale the service so that the overall system throughput increases. Okay. So these are the problems that distributed tracing solves. Over and above, it also helps you set SLAs. Okay. So if there are SLAs that you have set, like some SLAs for latencies and time that a request should take, this particular method of distributed tracing enables you to maintain those SLAs as well. Okay. And whenever any incident occurs in microservices architecture, distributed tracing helps you there to assist in root cause analysis. Okay. So this is about distributed tracing and how it can be helpful in microservices architecture. So that's about this class. I shall see you all soon. Thank you. Welcome back. So let us start talking about ZIPKIN. So when it comes to distributed tracing is of course a key tool for maintaining, troubleshooting and optimizing distributed systems. And it gives us the visibility of what is happening with our complex applications. Now, what is ZIPKIN? So ZIPKIN is a crucial tool when it comes to distributed tracing. So ZIPKIN is an open source distributed tracing system. And with the help of ZIPKIN, you can gather timing data needed to troubleshoot latency issues in service architectures. So it's a tool that enables you to trace your requests from the beginning till the end. So it provides a lot of things, like it provides the timing data. With the rise of microservices architectures these days, tools like ZIPKIN have become incredibly valuable. So let us talk about what is ZIPKIN and how it works, and we will also talk about the components that exist with ZIPKIN. So these are the different components that ZIPKIN has. Okay, so let us say we have a microservice, which is company microservice, and here you will have a collector, you have some storage, search, and then in the end you have visualization. So this is what ZIPKIN will comprise of. So with collector, this is where your application will send the trace data. Okay, so for tracing, you need to collect data, and this is where your application will send the trace data, and the collector will accept the data over the transport modes like HTTP, Kafka, or even RABBITMQ. Okay. Then we have storage. So once the data is collected, the data needs to be stored somewhere. And ZIPKIN offers a variety of storage systems like MySQL, Cassandra, and even Elasticsearch. Then you have search. So ZIPKIN provides an API and a web interface to search for traces in the storage that you have. So you can find traces based on different criteria like name, annotation, or time. And then you have visualization. So once you have found a trace, ZIPKIN helps you visualize the trace in a way that makes sense to you. And it shows you a diagram of how your request has flowed through the system, where time was spent and what was happened when an issue occurred. So it gives you a Hawkeye view of what is happening with your request in a sense. Okay. And it gives you a lot of information also along, like the time, how much time was spent on each thing and each microservice. So this is how ZIPKIN works. So here we have only one microservice that is sending data to collector, but we can have multiple microservices that exist in the microservices architecture, and everyone can send data to collector, which is within ZIPKIN. So this is about ZIPKIN and how it works, and these are the different components that exist and enable ZIPKIN to function properly. Now let us talk about two different things in ZIPKIN: trace and span. So what is a trace? So a trace is a description of a transaction as it moves through a distributed system. So you can think of trace as a tree of work that is done based on a request. Okay. You can think of it like a journey of a request. Okay. So let me give you an example. So you have a client that is requesting something. Now let's say to fulfill that request, you need to interact with 3 microservices. So for example, we have job microservice, company microservice, and the review microservice. So to fulfill this request, you need to interact with 3 microservices. So the request will go through 3 microservices, and this entire journey is known as a trace. Okay. And then you have another concept which is known as span. So what is a span? A span, on the other hand, unlike trace, is a basic unit of work. So for example, sending an HTTP request is a span as is sending a response. Okay. So here, when interacting with different microservices, the request is performing a unit of work. So this would be 1 unit of work. Then here you will have 2nd unit of work. And then with the review microservice, you will have a 3rd unit of work. So this is 1 span, this is 2nd span, and this would be the 3rd span. Now, a span and a trace are represented by IDs. So for trace, you will have a trace ID, okay, which represents the entire request from start to end. And span will be represented with the help of span ID, and it represents the individual unit of work. Now, span will also include metadata about the work, like the time it started, the time it ended, and any annotations or anything to describe the events that occur when the span was active, and so on. Okay. So if I have to give you a Hawkeye view of how this entire thing works, is when a request enters the system. So let's say this request came in from client into the system, and at that moment, there is a new trace that is started. Now that trace has a trace ID. And as the request passes through each microservice, like for example, job, company, and review. So for each microservice, a new span is created to represent the operation that is performed by that microservice. And each span is linked to its parent span, performing a trace tree. So you have trace ID at the parent level or a trace at the parent level, and then you have multiple spans that show the different unit of work that has happened. And like I said, span will have different kinds of information like start time, end time, duration, and different metadata about the operation. Okay. Now spans and traces are collected and stored and analyzed by distributed tracing system like ZIPKIN, and it gives you insight into the performance and behavior of the microservices. So if you are wondering how ZIPKIN is able to show you the working of the request across different microservices, so it is because of span and trace. So now you can imagine you have trace, which represents the entire request journey, and span, which represents the individual work. So with the help of this data, you can store it and you can create a nice view that can represent and that can show different requests that are happening and how they are happening in your system. So this diagram here that you're seeing provides a simplified representation of the concept of trace and span, and it helps you understand what they do in the hindsight. So in summary, ZIPKIN is an essential tool in the world of distributed services, and it provides a crucial visibility into the performance of distributed system and helps developers like us to troubleshoot and optimize their applications. So that's about ZIPKIN. Hey, welcome back. So in this lecture, we are going to go hands-on with ZIPKIN, and we are going to explore ZIPKIN by installing it, and we are even going to set up it onto our system. So to begin with, let's head over to browser and let us search for ZIPKIN here. Now, the moment you search for ZIPKIN, you will see this official website here of zipkin.io. So you can click on the first link and you will be taken to the ZIPKIN official website. Now you can see ZIPKIN is a distributed tracing system. Okay. You can read about how it works, and this is what the interface of ZIPKIN looks like. Okay, so you can see here, this is an example request. So it has post, /location/update/v4. So this is a request, post request. Here you can see the duration, 10 services, and you can see total spans were 13. Trace ID was this, and you can see the request journey. Okay, so this gives a complete like visual representation of your request. And if you select anything, it gives you some more information and more metadata as to what happened and what was the start time, the value, address, and so on. Okay. Now there is also a dependency tab which shows you the dependency of different services that exist in your application. Okay. So what we are going to do is we are going to click on Quick Start, and here we are going to get started with the installation. So now installing ZIPKIN has 3 options. Okay, when it comes to installation, we have 3 options. We can do it using Java, which is like using jar file here. Then you have a Docker option, okay, and running from source is also another one, which is using Git. Okay, so you can go with either of the approaches. So if you want to try the jar version, you can click on the latest release over here, and this will give you the jar version of ZIPKIN. So what I did is I just downloaded this jar file, and what I can do is I can go over here and open the folder. So this is a jar file that has been downloaded, like ZIPKIN server. You can see over here. Now you can open the terminal and you can run this command. You can run this command java-jar zipkin.jar, and it will just run this particular jar file and it will give you access to ZIPKIN. So if you want to see this in action, I can like open up PowerShell here. Okay, and I can head over or switch over to my directory. So I can say desktop Spring Boot, desktop courses Spring Boot here. And here if I do ls, you can see I have the ZIPKIN server jar over here. Okay, so I'll just zoom in a bit so that you get some better visibility. I'll clear the screen and you can say java-jar, and you can just say ZIPKIN server. So this is a jar name. So you can just type in Z and press tab. So this will give you the name. And if you press enter, you should see something like this. So you might see this firewall access, and I'll say allow access. So ZIPKIN is trying to access the network over here. Okay. So if you see the logs over here, so we have just typed in one simple command here. Okay. Java-jar, and this is a way of running jar file with the help of Java. You see this ZIPKIN, like some icon logo comes in, and then you can see it's being served at localhost port 9411, and you can access it from here. So if I press Control, this becomes a clickable link, and you can see the dashboard over here. So this is the ZIPKIN interface. It's fairly simple and it's relatively easy to navigate and use it. Okay, so the main thing over here is this search bar here. Okay, so the search bar is important, wherein you can search for things with the help of trace ID. Okay, and you also have a way to search over here. So you can search using service name, maximum duration, minimum duration. So this is really nice. Yeah, like you can filter requests that are taking so much of duration and so little of duration, and you can even look at all the requests for a particular service name. Okay, so this enables you to get more insights as to what is happening with your system. Okay, now you will find the trace over here, whatever traces are coming in. Okay, if you click run query, you will see all the traces here, and if you click on any of the trace, you will see a very nice UI that we just saw over here. Okay, so this interface is what you will see when you click any of the trace. And then you have dependencies tab, which show you the dependency of different components within your microservices architecture. Okay, so this interface is fairly simple. All right, but for now we are running it with the help of jar file, which is one option that I showed you. So we won't be using this approach. Instead, we can go ahead with the Docker approach. So I've just shut down the server. Okay, so to shut down the server, you can press
So on command line or PowerShell, I pressed in Control C or Control C. Okay. So if this is running, so I pressed in Control C and it stopped the server. And if you're on Mac, you can press Command C. Okay. So this is how you can stop and start the server using jar. Now there is another option, which is to make use of Docker. So you can simply get this command here. Okay. And we will head over to the terminal. So this is a terminal and I can paste in this over here and make sure you have Docker up and running. So I have Docker running here. Okay. So I'll just run this and it says unable to find the image locally. So what it does is it downloads the image from the internet, okay, or from the Docker Hub, and you're getting this latest image being downloaded. So this will take some time depending on the network connectivity, but you have Docker like ZIPKIN running on Docker up and running. So I can say Docker PS. So here I can type in Docker PS like so. And you should see ZIPKIN over here, like you can see. Yeah. And like we did early on, you can just refresh this page and you should be back. Like this dashboard is back. Okay. So this time we are running ZIPKIN within the Docker container. All right. So we'll be using the Docker approach. Okay. Because we have already configured Docker. And if you have not installed Docker, I would highly recommend you to do so. So for now, we are using Docker, but what I want to do is whenever you make use of Docker, we switch to Docker Compose, because with Docker Compose, it's easier to manage multiple containers in your application. All right. So we have our Docker Compose file defined here. Okay. So this is a Docker Compose file, which has different Docker like images that are being pulled. So what I'll do is I have the setting created here, which is for ZIPKIN. So I'll copy this and I'll paste it over here. So ZIPKIN will be available in our application, okay, as with the help of Docker Compose. So I'll paste this and we are done. Okay. So yeah, we have this configured now. And if you wish to, you can simply remove this image. Okay. So you can say Docker stop, and you can stop this particular container. You can copy the container ID. Oh, so you should say Docker stop and let us paste the container ID. So this is a container ID for ZIPKIN and this will stop the container. Okay. So you can see the container is stopped now. Okay. Now you can remove the image. So you can say Docker RM and let me get the image name. So you can say Docker images. So this will give you all the images that exist on your system. So I'll copy the image ID and I'll say Docker RM and I'll paste the image name. Okay, so it's not RM, it is RM. So RM was not the command, it was RMI. But right now we are getting an error that we are not able to remove this image because it is being used by some container. So what I can do is I can remove the container first, like I can say RMI and this container for which I got the ID, I'll get this removed. But we're getting this error that no such image exists. Okay, that's weird. So what I will do is I'll just force remove ZIPKIN. So I'll say RMI -F. Okay, and you can see this is deleted now. So now if you say Docker images, you're not going to get the OpenZIPKIN image over here. So this was the OpenZIPKIN or ZIPKIN image. So you're not going to see that image here. Okay, so this is gone. So now we can manage, or we are ready to manage this with Docker Compose. So what you can do is you can say Docker Compose down, or you can say directly Docker Compose up. So let me save this and let's see what happens. So you can see when you say Docker Compose up, okay, so it's running. But the thing is we didn't run it in detach mode. So that's a mistake we did. Okay. So what I can alternatively do is I can quit. Okay. And I can run it in detached mode like so. Okay.
So you have the containers up and running, as you can see. Okay, so there are 3 containers now: pgadmin, Postgres, and ZIPKIN. So now you can come over here. If you refresh, you're going to see this. Okay, and this is working perfectly fine. Okay, so what we have done is we went a little bit hands-on with ZIPKIN. We tried different ways as to how you can use and set up ZIPKIN onto your system. And Docker is our preferred approach. So we'll be using ZIPKIN within Docker container going forward. Hey there, welcome to this class. Let us start talking about Micrometer and what it is. So what is Micrometer? So Micrometer provides insights that help you keep tabs on your application's performance. So essentially, it's a tool that helps you check your application performance. Now, let us talk a bit more about this. How Micrometer helps. So Micrometer helps you collect different metrics about your application. And these metrics are measurements or data points that provides insights as to how your application is performing. And they can include things like response times, error rates, resource utilization, and so on. Now, collecting these metrics can be a complex task because there are different tools and systems available for monitoring and metric collection, and each tool may have its own way of collecting metrics and storing them. So this is where Micrometer comes into picture, and Micrometer essentially acts as a middleman or a bridge between your application and the metrics collection system. So it provides a simple and consistent interface for you to instrument or measure different aspects of your application. The key benefits of Micrometer is that it offers a vendor neutral interface. Okay, this means that you can use Micrometer to instrument your application metrics and then choose the metric collection system that you prefer or that works for you the best according to your needs. And Micrometer supports various popular metric collection systems like Prometheus, Graphite, Datadog, and so on. So with the help of Micrometer, you can abstract away the complexities of interacting with different metric collection system. And you can focus on instrumenting your application with the metrics by using a consistent API, okay, that Micrometer provides. So in summary, Micrometer simplifies the process of metrics collection for your application. So in summary, Micrometer simplifies the process of collecting metrics for your application. Now, one thing that I wanted to talk about is how is Micrometer different from tracing systems like ZIPKIN or Sleuth. So while Micrometer and tools like ZIPKIN are instrumental in observing your application, but they serve distinct but complementary roles. Okay, so Micrometer is a metric collection library, and it measures things like how many requests have been made, how long do they take on an average, what is the distribution of the request duration, and so on. It provides the metrics in a way that can be scraped and stored by a variety of monitoring systems. Okay, so you have Micrometer, which is collecting metrics, and then behind the scenes, you can use any monitoring system you want, and it will give you a bird's eye view of your application performance. On the other hand, ZIPKIN, it is a distributed tracing system, and it tracks the path that the request takes as it travels through different microservices in your system. And it provides you a detailed view of a single request, showing you how long each step took and what service was responsible for that delay or that particular step on the way. Okay, so this is what about Micrometer and ZIPKIN is. So while Micrometer provides an application level view with aggregated metrics over time, distributed tracing tools like ZIPKIN provide a request level view. So there's a difference: aggregated metrics level view with Micrometer and request level view with distributed tracing tools like ZIPKIN. Okay, and ZIPKIN enables you to trace the request level view, tracing the path latency of individual requests and not application as a whole. Okay, so they both are essential for different reasons and together provide a comprehensive view of your application's performance and behavior. So that's Micrometer for you. All right, so now the time has come wherein we should integrate ZIPKIN with our Spring Boot microservices project. So we already have ZIPKIN Docker image added here in Docker Compose, and you can run ZIPKIN in multiple ways. Like you can have Docker image running in ZIPKIN, you can have like a jar file running of ZIPKIN and so on. But we are choosing the Docker approach. Now, what we need to do is we need to start integrating ZIPKIN. So in order to do that, so we have not yet integrated, we have just added ZIPKIN to Docker Compose. And this would just enable ZIPKIN to work as a standalone service. But we need to start sending the data to ZIPKIN so that we could view how request is flowing through our system. Okay. Now to do integration, we need to first go to pom.xml. So let us open the pom.xml of this first project, which is company. Now to add the dependency, we will head over to our browser. Now here in the browser, I'm going to go to start.spring.io and I'm going to remove this OPENFEIGN over here. And I'm going to add the dependency and I'm going to simply type in ZIPKIN. So after adding this dependency, just make sure you have selected Maven and just hit explore. Now here we will see the dependencies coming up that are needed for ZIPKIN to function properly. So the dependencies we'll need is like Micrometer Tracing Bridge Brave and ZIPKIN Reporter Brave. So these are the two dependencies that we will need. But before talking about these dependencies, I wanted to add a thing over here. So here you will notice Micrometer is being used when we are integrating ZIPKIN. So in the earlier versions of Spring Boot, we used Sleuth. So Spring Cloud Sleuth was being used to add ZIPKIN into our project and to enable distributed tracing. So you can see over here, Spring Cloud Sleuth provides Spring Boot auto configuration for distributed tracing. So earlier, when you had to enable distributed tracing in your application, you need to add this library. But right now you can see this message over here that with the latest version, you can check this version here. So the core of this project got moved to Micrometer Tracing project. So in order to enable distributed tracing in your application now, you need to work with Micrometer, okay, in your Spring Boot application. And you can see all the details over here when you click this particular Micrometer Tracing link. Okay, so if you are curious, you can just go through this link and take a look. Okay, and you can see over here, these are the dependencies that we are seeing over here. So Micrometer Tracing Bridge Brave, and here we have, okay, Bridge Wave is not here. So here you are seeing Reporter Brave, and that is what you're seeing over here. So ZIPKIN Reporter Brave. Okay. So yeah, this is an update that I wish to share with you, and we will be using Micrometer. So we will be using, in a sense, we will be just adding the dependencies. So I'll copy these dependencies, these two. So Micrometer Tracing Bridge, and I'll head over and I'll paste these two over here. So there are two dependencies. One is the Tracing Bridge Brave and ZIPKIN Reporter Brave. Okay. So what do these dependencies do? So let us also talk about this. So Micrometer Tracing Bridge Brave is a bridge library that connects Micrometer with Brave. Okay. And Micrometer is a metrics instrumentation library for JVM based applications, and Brave is a Java tracing library which is compatible with ZIPKIN. So this is a bridge that connects Micrometer to Brave. And then you have this another dependency, which is ZIPKIN Reporter Brave. So this is the reporter which sends the tracing data to ZIPKIN. And ZIPKIN is, like we know, distributed tracing system. It will gather this data and it will show you with the visualization that you need to work with your services. Okay. So these are the two dependencies that we have added.
and this is how they help us. Now we'll sync this. Now the thing is, after adding these dependencies, Spring Boot auto configuration comes into picture, and Spring Boot auto configuration realizes that we have added these dependencies. So of course we need to send data to ZIPKIN server, and it will start sending data by itself. We need to do some configuration in properties. That is all, nothing more than that. Now here in our project, we are making use of OPENFEIGN as well. Okay. So we are not making use of OPENFEIGN in the company project, but we are making use in job project. But I'll add the dependency here as well. So we need to add one more dependency if you are using OPENFEIGN. So the dependency name is Feign micrometer. Okay. So you need to say group ID as io.github.OPENFEIGN. So this is the autosuggest that we got. So instead of Feign bomb here, I'll just get this removed and I'll say Feign hyphen micrometer. Okay. So, and we'll skip the version tag. Okay. So yeah. And now we'll just sync this. So this should just fetch all the dependencies. All right. So we have configured this, and we need to add this dependency because if we are using OPENFEIGN, which is a declarative web service client, then whatever requests are being sent using OPENFEIGN should be sent to ZIPKIN as well. So for that, we need to add this library as well. Okay. So this is done. So now since we have done the changes in the dependencies, we now need to do the configuration, which will dictate as to how the data is being sent to distributed tracing system. So I'll head over to application.properties here for this particular microservice. And here I'll say ZIPKIN. So I'll add a few properties. Okay. So here I'll say management dot tracing dot sampling dot probability. Okay. And I'll specify this as 1.0. So with this property, we are telling to trace each and every request that goes on. Okay. So in production based environments, you might not want to trace each and every request that is flowing through your system, because sending data, receiving data, storing data, this will all take some process. Okay. This is a process. So this might slow down your system. So in production grade applications, you don't trace everything. So you will reduce the sampling rate. Okay. So you can reduce it to 0.6 or something like, so that will trace the 60% of the request. Okay. But since we have specified 1.0, it will trace each and every request. And the reason we are doing this is because we are still building the application and we are learning. Okay. So there is a possibility that if you are working in a production grade environment, you will see a different sampling rate over here. Okay. So I've specified this over here. You can even mention the ZIPKIN base URL. Okay. So you can say management.zipkin.tracing.endpoint, and you can specify the ZIPKIN URL over here. Okay. But I am not specifying the endpoint because the default one is usually picked because ZIPKIN runs on the default port over here. So 9411 is the default port. So that is a default that even if you don't specify, it's okay. So I'll just have one property mentioned over here, which is the sampling rate. Okay. And we are done with the integration. So integration involved two steps. Okay. One is understanding and adding the dependencies and then configuring the properties. Okay. So I realized I just made a small mistake in the spelling here. So it's probability. Okay. So I'll say probability over here. So this is a spelling. Just make sure you get all the spellings right. Otherwise you will land in errors. Okay. So yeah, that's about integrating ZIPKIN with your Spring Boot application. Hey there, welcome to this class. So we have integrated ZIPKIN and we are now sending the trace data to the distributed tracing system. So what I want you to do is I want you to now
integrate this for job service as well as the review microservice. So you can take this up as a challenge. It's a simple process wherein you need to first configure the dependencies like we did for company microservice, and then you need to configure the application.properties. So pause the video right now and take this up as a challenge and configure the other two microservices. So welcome back. I hope you have configured this. I'll show you how you can do this step by step if you have not been able to. So what we need to do is we need to add the dependencies first. So I'll copy these three dependencies. So the first dependency is tracing bridge brave, and the other one would be reporter brave and then feign micrometer. So I'll copy these three and I'll paste it in the pom.xml of job app. Okay. Then I'll head over to review. I'll open the pom.xml there and I'll paste the remaining dependencies as well. Okay, here. I had already copied the dependencies and I pasted. Now what I can do is I can go over here to the Maven icon, and since we want to reload multiple Maven projects because we have made changes into pom.xml files. So either you can go to individual pom.xml files and reload like this, or you can just click on Maven and say reload all projects. So this will reload everything, and you must have seen the progress at the bottom. Okay. Now the dependency configuration is done. Now we need to configure the properties. So I'll simply copy this property here. Okay. I'll close the pom.xml files, and now I'll open the application.properties for both the applications. So this is for job, and then I will have one open for review, like so. Now what I will do is at the end, I'm just going to paste the property that I have copied. So I'll paste it over here as well as in the job microservice. So we are done configuring both the microservices to work with ZIPKIN. Hey there, welcome back. So now we have configured our projects, like all the microservices, to work with distributed tracing systems like ZIPKIN. We have added all the dependencies and we have configured the properties. Now it's time to test our changes. So I'm going to restart all the applications, review, job, as well as the company. Okay. Okay, so everything is restarted now. Now we can head over to Eureka server and just make sure that everything is up and running. Okay. So all the microservices are up as per Eureka server. Now you also need to make sure that ZIPKIN is up and running. Okay. Because ZIPKIN is where we will be testing the changes. Okay. So now what I will do is I'll switch over to Postman. I'll first switch over to companies and I'll create a couple of companies. So 1 and 2. And then I'll create a couple of reviews here. So I'll create 1, 2, and one review I'll create against company 2. So it's done. Now I'll switch over to jobs and I'll create one job and I'll try getting the job. So you can see the job JSON. We have one job, one company, and a few reviews. Okay. Now what we need to do is we need to head over to ZIPKIN and say run query. So we are not seeing any trace information or any request information, which means we are missing something. So what are we missing? So I guess I figured out the problem here. So here, when we added ZIPKIN to our dependency list, okay, and when we said explore, here we copied these dependencies, right? But we didn't copy the actuator. So we need to have actuator as well for this to function. So what I'll be doing is I'll be copying the actuator dependency and we'll head over to our project here. Okay. And I'll close everything and I'll open the pom.xml for all three microservices. So this is for company, jobs,
and then for reviews as well. Okay. And let us add this dependency to all 3 microservices. So this is 1, this is 2, and this is 3 here. Now we need to reload all the changes, and to do that, I'll head over to this Maven icon and I'll reload everything. Okay, so you will see job, company, and review, all 3 are being resolved in terms of dependencies. So this is done. Now we have actuator added as dependency for all 3. So actuator is important, and that is why when we added this dependency here for ZIPKIN, this was auto added. Okay, so just keep in mind whatever is generated with start.spring.io, like Spring Initializer, it makes sure it gives you everything that is needed for something to run. So here we are using ZIPKIN, so it also gave actuator as a dependency, which was missed. So we added this. Now what we need to do is we need to restart our applications again. So I'll restart this. So I'll say restart review, restart job, and restart company as well. Okay, and we can test the status, or we can check the status in the Eureka dashboard. Okay, so if you hit refresh, so company I believe is not restarted. Let me restart company as well. So company is restarting. Let us see what's happening. Okay, so the company is restarted, and let me refresh this. So you will see company service also come in over here. Okay, so all our microservices are up and running. ZIPKIN is also up and running. Now let us head over to Postman and let us close, or let us keep everything open, and let us try what we tried again. So I'll create a couple of companies. I'll send post requests twice. So 2 dummy companies, and I'll post a review against company ID 1. Okay, and I'll create one more review against company ID 2, and I'll post a job. Now I'll try fetching everything. So you can see this JSON response that we are getting here. Now what we can do is let's switch over to ZIPKIN and let us say run query. Okay, so here is where now the magic starts. So you're seeing all the requests that we did. So this was review service wherein we created the review. This is the post request for company service where we created the company. This is the post request for review service again, where we again created the review. And then for job, we created the jobs. Okay, and then I again created a review. So there are 3 reviews essentially that I created, and 1 job and 1 company. Okay, so all that you can see over here. And if you click on this, like the drop down arrow, you can see review service is what we are interacting with. Okay, and at the top you will see the final API call that we did to get all the jobs. Okay, and you can see different information like route, start time, spans, duration, and so on. Okay, so this is sorted by duration and not by start time. Okay, so if you want to sort by start time, you can sort it that way too. So you will see company, review, and job service then. Okay, so what I wish to show you over here is take a look at this span over here. So this has a span of 5. So 5 spans are there. Rest everyone has span of 1, which means they were only interacting with 1 microservice. So of course, if we are creating reviews, we are only interacting with the review microservice. Okay, but here we interacted with 3 microservices and has a span of 5. Now if you click on show, you will see this nice detailed view which gives you an overview of what's happening with every microservice and every call that happened to each and every microservice. Now with this view, you can get a nice information. So you can see job service get took 132 milliseconds. Then company service with company ID here, it took 44 milliseconds. Then we have job service again, which took this much time, and then reviews took this much time. And in total, the request took this much time. 3 services were interacted with a span of 5, and this is the trace ID. Okay, and you can see different information on the right hand side as well. like annotation, and this is all the metadata, which includes start time, end time, and so on. Okay, the request method was get, status code was 200. So this is amazing. Okay, and if you go over here again, run query, okay, you can view this as well. So you can just experiment over here. You can say show, and you will see this is just interacting with one microservice. Okay, so this is a nice overview. You can like filter over here service name, and I can say give me service name for only company. Okay, and I'll say run query. So I've filtered with job service, and you have only 2 requests that are going to job service. So this way you can filter requests as well to a particular service, and you can examine that particular service as to what is happening. And you can play around with different filters here, like max duration. If I want to filter out the requests that are taking a lot of time, okay, I can do that. Minimum duration, I can do that. Service name, I can do that. Absolutely. In dependencies tab, if you run query, here it generates this dependency diagram, wherein job service is dependent on company and review service. So this is based on the request that we are triggering. So from job service, we are triggering a request to company service. And again, from job service, we are triggering a request to review service. Okay, you can modify the date time as well over here and play around with this. This data, like you can even upload JSON if you wish to, and you can play around with filters here as well. So indeed, it's an amazing tool. Okay, so you can see like how service, if service goes down, also you can play around with this. So let me like take one service down. So I'll just turn down the review service. Let us stop review service, and let me trigger the postman request. Okay, so we got an error. Of course, we have not handled the error, but we got an error. And now if you go over here and if you run the query, okay, you will see this was the request that we triggered, and it has a red mark. If you go to show, you will know, okay, this request failed. So you will know why it failed. Okay, it went to job service, company service also, but it didn't go to review service. So probably that service is down, right? Yes. So this is how you can play around with ZIPKIN, and ZIPKIN can give you lots of information which can be critical in managing your microservices. You can also use buttons like expand all and collapse all. This is just like user friendliness of ZIPKIN. So that's about ZIPKIN and how you can use it to work with different microservices. I hope this was valuable, and I shall see you all soon. Thank you. Hey, welcome to this class. So let us start talking about the common problems that might occur with distributed tracing and how can you even troubleshoot them. So the number one problem that I always hear is the missing trace problem. So what is this problem? So here, sometimes you might not see the traces that you were expecting to see in ZIPKIN. Okay, so you are doing a request to your microservices, but you are not seeing the trace in ZIPKIN. And this could be due to various reasons out there. So one reason that I could think of is it could be because of network issues. It could be because your sampling rate is low. So when we configured ZIPKIN, we have to specify a sampling rate. So if the sampling rate is too low, like very few requests will be sampled for ZIPKIN. So just make sure your sampling rate is a bit appropriate if you want to see some request flow into ZIPKIN. Another reason could be spans are not being reported correctly, or ZIPKIN is not properly configured. So to troubleshoot this issue, you can make sure that your services are up and running correctly and are indeed producing some traffic. Then you can verify your configuration settings, particularly those related to sampling rates and ZIPKIN and reporting. Also, you need to make sure that ZIPKIN server is properly configured and it's up and running. And lastly, be sure to check for network connectivity and make sure that the span is reaching your ZIPKIN server. So these could be few steps that you could take to solve this missing trace problem. Let us talk about best practices and performance management with distributed tracing.
So the number one point that I would like to mention is about the use of consistent naming conventions for your services. So be sure to have consistent naming conventions for your services because this helps in easier identification and also helps with readability. So if you are building an application and let's say if that application scales up tomorrow and you have then tons of microservices out there. And if you're not following a proper naming convention, it would be a mess. So it would be very difficult for you to understand like which request is coming from which microservice and what was the name that you had given to a particular microservice. So it's better if you're building from scratch, it's better to have a proper naming convention in place so that it's easier when things scale up. And naming conventions are particularly important because in ZIPKIN, you see everything by name. The next best practice should be to secure your ZIPKIN server. So tracing data can contain some sensitive information, so ensure you have secured your ZIPKIN server properly. Another point that I want to mention is an informational point. So you need to know that distributed tracing comes with a performance impact. Now, what does this mean? So since you're tracing your requests that are like happening in your microservices architecture, this tracing involves some extra computation and the network calls that happen, like we store data and we are sending data essentially to ZIPKIN. So all of this involves extra computation and therefore it's important to manage the trade-off between the detail of the data and the performance impact. So this is one key thing to keep in mind. Now the thing is, how would you control this? So one way to control this is to adjust the sampling rate. So you don't need to trace every single request, especially in an environment where there is a lot of traffic coming in. So you can lower your sampling rate. So in our example, we had set the sampling rate to 1, which was tracing all the requests. But you can reduce the sampling rate and it can still give you a representative picture while reducing the performance impact, and you can even have a view of what is happening with different microservices. However, beware that lower sampling rate might also mean that you miss some of the infrequent issues, and the right sampling rate often depends on the use cases and the nature of your system and also what you want to track. So this is about best practices and the things that you are supposed to keep in mind, but distributed tracing is one of the amazing things that comes in with microservices and it helps you a lot. So that's about this class. I shall see you all soon. Thank you. Let us start talking about configuration management in microservices. So what is configuration management? So configuration management in the context of software engineering is the practice of managing and controlling the configurations of different systems. And in case of microservices, it simply means managing and controlling the configurations of different microservices. So this is a practice of handling changes systematically so that the system maintains its integrity over a period of time. Now, configurations may include details such as database connections. So if your application is wanting to connect to a database, they might be having some database connection configurations. They might have external service URLs, like if they are consuming some services externally, they might have some caches related setting and more. So these are different configurations that exist and they allow your service to work and function properly. Now, there is a challenge when we talk about configurations. So as the number of microservices increases in your architecture, managing individual configurations can become a complex task. And it's really hard to keep track, update, and hard to synchronize this across all the services. Also, if the configurations are embedded within the applications or scattered across multiple places, it becomes even more daunting and difficult to manage and debug. So there is a need and a room, there is a need for a centralized config server. And this server can be a central place for managing
all the configurations across your all microservices. It simplifies the configuration management and it increases the operational efficiency of the system. So this is what is configuration management and the need for a config server. So let us talk about how configuration management will work. So let's say we have 3 microservices: job microservice, company microservice, and the review microservice. And then you have a separate config server which is hosted somewhere. Now all these microservices will do the job of fetching and retrieving the configuration from the central server. Okay, so this is a central server that saves all the configurations that are needed by each microservice. And this config server can have configurations for different environment as well. Like for example, you might have a dev environment or a prod environment or a QA environment. So different environments have different configurations that are typically needed by microservices, and this config server is capable enough to handle that. Let us talk about some features of config server. The number one feature would be centralized and versioned configuration. Now config server interfaces with a version control system like GET, and this way all the configurations are versioned and changes can be tracked very easily. You can even roll back the configurations if you wish to. So this is one feature of config server. Dynamic updates. So most config servers support dynamic updates, meaning that you can change the configuration in the server and the services can refresh to get the new configuration without needing to be restarted. Okay, so this is another aspect. Then you have the aspect of security. So config server can also encrypt and decrypt the information or configuration properties that you are storing to ensure that sensitive data is secured. So if you have any passwords or anything that you want to encrypt, that is 100% possible. Application and profile specific configuration. So a config server can even have the profile specific configuration like dev, test, prod, and so on. So different configuration files for different environments. So these are the features. Let us talk about the benefits of having this. So the number one benefits is like the single source of truth. So config server provides a single source of truth across multiple microservices, leading to consistent configurations across all services. Secondly, it allows you as a developer to easily manage and update the configurations since it's now centralized, and it also enhances the security and control. Since things are now centralized, so you can implement better security practices and even have better control over the configuration. And lastly, it makes it easy to deploy and scale your microservices, okay? Because you have a central config server where you can manage your configurations very easily. So this is about the configuration management and what it means in the world of microservices. Hey there, let us start talking about Spring Cloud Config Server. So what is Spring Cloud Config Server? So this is a part of Spring Cloud project, and Spring Cloud project is a suite of tools specifically designed for building and managing cloud native applications. So Spring Cloud Config Server provides a centralized external configuration management backed by Git or SVN. And it uses a version control system which helps us effectively track and manage the configurations across different environment and microservices. So this is the official page of this particular service here. So if you search for Spring Cloud Config, and you will land on this official website, which is of docs.spring.io. And you can take a look and read more about this project here. So let us talk about how does this work. So here is a diagram to illustrate the working of Spring Cloud Config Server. So let's say you have 3 microservices: job microservice, company, and review. And you have a cloud config server which you have set up, and this is a separate server which is responsible for managing all the configurations in your microservices architecture. So what happens is Spring Cloud Config Server uses Git in the background for storing and managing the configuration files. Now, all these microservices can interact with the Spring Cloud Config Server, and it is going to store all the configurations and manage them in a centralized place, which is what we see here, which is Git. So config server is essentially like a middleman, as you can see. So when a microservice starts, it asks the config server for its configuration. And config server, what it's going to do is, from where it will provide the microservices about the configurations. So it will reach out to Git and it will give the relevant configuration to that particular microservice. And then the microservice starts. Also, if you have to refresh the configuration changes, the config server can notify the microservices, or the microservices can ask the config server for fresh configuration. And in that case, config server will fetch the configurations again from the Git. So Git is being used behind the scenes by Spring Cloud Config Server to store and manage the configurations. Now there are some benefits when we talk about the Cloud Config Server. The number one benefit is storing configurations. So it does a job of storing the configurations and providing them. So it also serves the configuration. So it provides the configurations to the microservices whenever requested. Refreshing the configuration. So refreshing is also one of the features. So if there are any changes in some of the configurations, you can hit refresh, and you can do this refreshing with the help of Spring Boot actuator. So not all configurations can be refreshed. So some configurations can be refreshed, and for some configurations, you might need to do a restart, like a microservices restart. For example, if you're changing some configuration like the database host URL, okay? So in that case, you might need to restart your microservice, because like it's a major change. You are simply like changing the database that microservice is pointing to. So you might need to do a restart, but for other configurations, you can simply manage with refresh. Like for example, if you're changing the application name, so you can hit refresh, and there is an endpoint in actuator from where you can refresh and the configurations are refreshed. Easy integration with Spring Boot. So since it's a part of Spring Cloud project, the integration with Spring Boot is fairly simple and easy. It also supports different environments, and it provides encryption and decryption facilities. So these are the benefits and how Spring Cloud Config Server works. So in summary, Spring Cloud Config Server provides a centralized, version controlled and secure way of managing configurations across your microservices architecture. All right. So that's about Spring Cloud Config Server. Welcome back. So let us begin setting up our config server. So to begin with, we are going to need a new Spring Boot project, wherein we will be adding everything that we need for that project to act as a config server for our microservices network or microservices architecture. So what I can do is I'll head over to our favorite website, which is Spring Initializer. And here, let us select Maven. And here I'm going to say com.embarkx. Here in the place of artifact, I'll say config server, like so. Okay. So artifact is set, and I'll add a description, which is optional. You can add, like I'll say config server, and I'll have packaging is jar, Java version 17 selected, and I'll come to dependencies over here. So here in place of dependencies, I'll say config. So you will see config client. So this is to specify the client that connects to Spring Cloud Config Server to fetch the configuration. So we are not going to add a client. We are going to add a server, because this is a server that we are creating. So central management for configuration via GET SVN. Okay. So I'll select this. Also, we will be registering this particular server with Eureka. So I'll say Eureka discovery client as well over here. Okay. So this is what we are going to add, and yeah, let us download all of this. You can explore this if you wish to. So you can take a look at the dependencies that are created, but I'll just go ahead and download. So this is downloaded here. You can see the zip file. And now I'm going to extract it over here. So we have the extracted version here. Now what we can do is let us head over to IntelliJ. Now here in IntelliJ, I'm going to go to this Maven tab here. So we need to add this newly created project into this project view here. So I'll go to Maven. I'll say add Maven projects and I'll select config server over here. So this is a project. I'll say okay. And we'll wait. So there'll be some processing that you see and you will see the project appear over here. So it is resolving the dependency right now. So let it do that and I'll collapse this. Okay. Now I'll open the config server here and I'll head over to pom.xml. So we have all the dependencies specified. Now what we need to do is we need to add some properties here in order to get it registered with our Eureka server. So the properties that I'm going to add is, let me copy this from some other microservice. So I'll go to the review microservice and under resources, I'll copy these couple of, so I'll copy this. Okay. So I'll go over here and I'll paste this over here and I'll also copy the application name here. So here now I'll update the application name. I'll call this as config server like so. And we are all set, I believe. So what we can do now is I will just start this application. So I'll go to config server application and I'll say, okay, so one thing we missed or it is pending. So we need to add an annotation over here. So I need to say @enable. So you can see this annotation here, which is enable config server. Okay. So this is coming in from this particular package here, which is Spring Framework Cloud Config Server. And this tells Spring Boot to treat this particular application as a config server. So with this annotation, we have now enabled the config server and we have configured everything for this application to work as a config server. There is one more thing pending, which is we need to configure the GET repository for this particular application or the server. So that is something we will do soon. So that's about this class and I shall see you all soon. So we have the config server application created and now is a good time to start setting up our GET repository because we'll be needing a GET repository using which our config server will fetch all the configurations in the hindsight. So let's head over to our browser. Now here I am on github.com. So this is something that we will be using to set up a GET repository. And if you have a GET account, you can say sign in, or if you don't have, you can hit sign up and you can sign up with GitHub. Okay. So I have logged in to GitHub. Now, depending on whether you have signed up or signed in, the journey would be different for both and you will land up on this home page. And you should see this icon at the top left to create a new GET repository. Or you can even create a repository from here, like from the top right. So you can use either of the buttons and we will need a GET repository to start working with. So I'm going to call this GET repository as application config, like so. Just make sure that the name is available. You can add an optional description. You can keep the repo as public so that our application can access, and you can hit create repository. So the repository will be created. Now what we need to do is we need to create a properties file which will be read by the config server. And this file will be used by config server to provide us with the configurations. So I'm going to say, so on this page, I'm going to click on create a new file. Okay, and you will see this editor open up. and you can enter the file name as application.properties like so. Okay, and here I'll add a simple configuration. So I'll switch over to any of my microservices and you can open any configuration file. So I'll open this application.properties and let us copy a configuration, this configuration here, which is the name, and I'll paste it over here. Okay, and I'll hit commit. So when we say commit, so application, so when we say commit, the file will be created and you can see this file here, and here is what the content of the file is. So we are done setting up the GET repository, and we have even created a configuration file which will be then used by our server to provide configurations. So we now have the GET repository set up with the application.properties file created. Now let's start using this application.properties file into our config server. So here in IntelliJ, I will have to make the config server to point to the particular GET URL and make the server aware that this is the URL from where you are supposed to fetch the configurations. And for that, I have a property which I am supposed to add in the config server application.properties. Okay, so here you have to say Spring. So I'll say spring.cloud.config.server.get.url. So this is the property that we are going to use. And now here, so instead of URL, I'll use URI. So URI is the property. And now here you need to paste in the URI. So I'll copy this and I'll paste the entire URI over here. So just make sure you are just copying the repository URL. So this is my account and then this is my repository. Okay. So we need to add this, and let me also show you what happens if you don't add this. So if I comment this out, so this is commented now, and if I run this server, so let me run the server. So if you run the server, okay, so here you will see an error. Okay, so the config server won't start and it will say if you are using a Git profile, you need to add the URI. Okay, so Git URI needs to be configured, and that is what we are configuring over here. So what it means is config server is looking for the URI from where it is supposed to fetch the configurations. So we have set this. All right. Now we need to go over here and we need to restart the server. Okay. So we need to uncomment and restart. And with this, let us head over to our browser and let us refresh the Eureka server. So you will see config server appear in the list. Now, what we can do is we can start accessing the URL here. So I'll click on this and you will see this head over to actuator. Okay, so we don't want to go to actuator, but we need to go to localhost :8080. And now here we can access the configurations. Now, how do we access this? So we can say localhost 8080 and you can see applications here and /default. So what this is going to do is this is going to return the default configurations of the config server. So here you can see profile is default, and here you are seeing the property sources that are being fetched. So this is the name of the repository. This is what you had given in the application.properties file, and it is fetching this. Okay. And this is the property that is coming in from the GitHub URL. Now, if you make any changes over here, so for example, I'm seeing job service over here. If I change this to job service temp or job service demo, let's say, and if I commit the changes, now if I refresh, you will see the new property being reflected. Okay. So this is how the
configurations have been externalized. All right. And you can see how we are able to fetch this. So now here we are making use of the default profile. So you will ask one thing over here, why have we specified application in the URL? It's because application is the file name. Okay. Application is the file name and properties is the extension. So we have said config server URL / file name / the profile. So default is the profile right now, and you can see the profile appear over here. Now, if you want, you can add multiple profiles. Okay. And these files can serve different profiles. How would you do that? So you can go over here. And what I'm going to do is I'm going to add a new file here. So I can go to my repository. I can say add a file, create a new file, and I can specify the file name. So I can say application. Now I want this to be development environment file. So I'll say dev application-dev.properties. Okay. This is a file I am creating, and I can say commit here. You can even add the configuration if you wish to. Okay, so I'll go to application.properties and I'll add the name here. Okay, so here in the repository, I'll go to application dev. I'll say edit and I'll add this particular configuration here that I have copied. Now instead of demo, I'll say dev over here and I'll commit the changes. So we have this property being added, which is job service dev. Now what will happen is if we go to this URL, if I refresh, you will see job service demo. This is because we are accessing the default. Now if I say dev over here, and if I refresh, you will see profile is dev now, and you are seeing this dev profile also being fetched here. Okay. So you can see the name come in over here. Now here, when you access this URL, you are also seeing another tag over here or one more JSON, which is of default. So default will also come in, but you are getting prod as well. Sorry, not prod, dev as well. Now what we can do is we can replicate the same process for, let's say, prod as well. So I can go to application config. I can say create a new file. And I can say application-prod.properties like so. And I can enter, instead of dev, I can say prod. I'll commit the changes. And now here, if you access prod, so let me say prod here, you will see prod also coming in. Okay, so this is right now being fetched from the prod file that we have just created over here. Okay, so this way you can manage your configurations. And right now what is happening is config server is accessing the GitHub URL, and depending on what profile you are asking it to load, based on that, it's loading the relevant profile. And the relevant profile meaning it has all the configurations that that particular environment would need to serve well. So this is about how you can map your config server to the GitHub repository. Hey there, welcome to this class. So let us start moving forward with the Spring Cloud config server. So right now we have the Spring Cloud config server, which is able to fetch the configurations from the Git repository. Now, of course, it is able to fetch the configurations, but now we need to make use of this configuration from the config server into our microservices. So how are we going to do that? So for that, we need to do some configuration and we need to add a new dependency to our microservices. So we'll head over to Spring Initializer project and I'll just delete all of this, all the dependencies, and I'll say add a new dependency and I'll say config. So here you will see config client, and this is a client that connects to a Spring Cloud config server to fetch the application's configuration. So it's pretty clear from this description here as to what it does. So after adding the dependency, just make sure you have Maven selected and the latest version of Spring Boot. Although the Spring Boot version won't matter because we'll be just copying the dependency. So you can scroll down here and here you are going to see this dependency, which is of Spring Cloud Starter config. So what we need to do is we need to copy this and we need to head over to our IDE. And here, what I will do is I'll close all the tabs and I'll go to, let's say, job microservices. And here within the job microservices, I'll add that dependency. And now I'll hit refresh. So after making changes to Maven, we have reloaded the Maven changes and this should resolve all the dependencies without any issues. So this is done. So all the dependencies are added now. Now what we need to do is we need to do a little bit of configuration. So we need to inform our microservices as to from where it is supposed to pick up the configurations. And for that, we need to add a small property over here. So I'll say config server, like so. And I'll say spring config dot import is equal to config server, and I'll add the URL of our config server. So the URL in our case is localhost 8080. So I'm just going to copy this and I'll come over here and I'll paste this over here. So I'll just remove the / from here. We don't need them, like so. So we are saying spring config import. So import the configuration from config server. And what is the config server? So this is the config server. All right. And what do we have in this config server? We have the name field. So what I can do is I can simply disable the name field here, like so. Okay. And now what we are going to do is we are going to test by getting our application name changed. So it is job service demo over here. So I can make it default. So this is the default configuration file or default application.properties, I should say. So in dev, you have ending with dev, and in prod, you have the one ending with prod, which is fine. So now what we can do is we have commented this. Now we can restart the microservice. So I'll say job microservice. Let me rerun this. Okay, so we got an error because of the URL here. So we need to add / over here, and let us try running this after adding the same. And now you will see our application is up and running. So removing these / was a mistake. You should keep it over here. Okay, we have it here as well. So that was a mistake from my end. But here we have the application up and running. Now you can head over to Eureka and we can say refresh. And now you will see over here, the application name is job service default. And this is coming in, of course, from our Git repository where we have specified default here. Okay. Now you can head over to logs and you can say Control F here and you can say fetching config. So you can see this log trace over here. So here what happened is when the application was started, it started fetching the configuration from the server at localhost :8080. And this is a URL that we have specified in the application.properties. So it fetched the configuration and it applied the configuration. Also, you can see the profile that was applied was default here. Okay. If you want, you can add a different profile if you wish to. So here, I can add one more property. I can say spring.profiles.active and I can say dev. Okay. You can add any profile for which you have configuration created. And if I restart the application, you will see this time
the profile that will be applicable will be dev and not default. So we will wait for that stack trace to come in. So if you scroll up here, okay, you can see here the configuration was fetched, and you can see over here dev is the profile, okay. And if we head over to Eureka, if I refresh, you will see job service dev appear over here. And you can even try this with prod. Okay, here you can even change this to prod and you can restart. So this is how you can fetch different profiles and you can work with different profiles. So essentially, if you have different environments, so let's say you have different environments like prod, dev, QA, and you have different database URLs and different username passwords for these environments. So what you can do is you can have different URLs and different settings created on Git, and you can fetch them from there. Okay, so it will work this way. So this is about how you can change the profiles. Now I wanted to talk about one more thing over here, which is optional. So there is one more property that you can add to this particular setting over here. So you can specify if you want to make this import of the configuration from the config server as optional. Okay. Now how do you specify this as optional? So let me give you an example. Let me shut down our config server. So what happens if our config server is unavailable? So if I shut down my config server and if I restart our job application, let us see what happens. So you will see we got an error here. And if you scroll up here, you will see IO error, which is of course there is no, like, this is not accessible now, right? Because our config server is down. And if you scroll up here, you will see this message. So could not locate property source and resource is optional. Resource is not optional. So here it says that you have not specified this particular resource, which is this particular resource, which is not available right now. And since it's not optional, so I'm not starting the job service. So you can mark this particular thing as optional. So you can say optional : and now if you try to run this, also let's say before running, we will have this name thing uncommented. So because we had commented this, so I'll start the application. And now if you go at the top here, you will see the application is starting. Here you will see fetching the config from this particular server, but this server is not available. Okay, so it will try a couple of times here. You can see it tried 3 times and then it will went ahead. Okay, so it tried quite a few times. You can see not even 3 times. So after this, it just went ahead with starting the service. Now the service is up and running, and if you see the name, it is simply known as job service because the configuration is not being fetched right now and we are using the local application.properties. So this is one scenario that you might want to handle in your microservices architecture, that what happens if config server is not available. So this helps you handle such scenarios. All right. Now, if config server is available, so if I make this service available again, and if I restart the job service, so you will see things working as normal without any issues as such. Okay, so job service is also starting now. And if you head over to Eureka service, you will see the name is now being fetched from the GitHub repository. So if I refresh, I have config server up and running. If I refresh again, you have job service dev up and running. And this is coming in from the Git repo and not from this local file here. So this is the significance of optional parameter here, is what I wanted to highlight. And this is very important. Like if you want to, so what will happen typically is if you have multiple microservices and a single centralized config server, and if that fails, everything goes down. So this is not right. Well, you need to have optional parameter as long as you can, and That is one benefit of getting your microservices loosely coupled. So this is about how you can connect or set up Spring Cloud Client with your microservices. Hey there, welcome to this class. So let us start moving forward with the Spring Cloud Config Server. So right now we have the Spring Cloud Config Server, which is able to fetch the configurations from the Git repository. Now, of course, it is able to fetch the configurations, but now we need to make use of this configuration from the config server into our microservices. So how are we going to do that? So for that, we need to do some configuration and we need to add a new dependency to our microservices. So we'll head over to Spring Initializer project and I'll just delete all of this, all the dependencies, and I'll say add a new dependency and I'll say config. So here you will see config client, and this is a client that connects to a Spring Cloud Config Server to fetch the application's configuration. So it's pretty clear from this description here as to what it does. So after adding the dependency, just make sure you have Maven selected and the latest version of Spring Boot. Although the Spring Boot version won't matter because we'll be just copying the dependency. So you can scroll down here and here you are going to see this dependency, which is of Spring Cloud Starter Config. So what we need to do is we need to copy this and we need to head over to our IDE. And here, what I will do is I'll close all the tabs and I'll go to, let's say, job microservices. And here within the job microservices, I'll add that dependency. And now I'll hit refresh. So after making changes to Maven, we have reloaded the Maven changes and this should resolve all the dependencies without any issues. So this is done. So all the dependencies are added now. Now what we need to do is we need to do a little bit of configuration. So we need to inform our microservices as to from where it is supposed to pick up the configurations. And for that, we need to add a small property over here. So I'll say config server, like so. And I'll say Spring config dot import is equal to config server, and I'll add the URL of our config server. So the URL in our case is localhost 8080. So I'm just going to copy this and I'll come over here and I'll paste this over here. So I'll just remove the / from here. We don't need them, like so. So we are saying Spring config import. So import the configuration from config server. And what is the config server? So this is the config server. All right. And what do we have in this config server? We have the name field. So what I can do is I can simply disable the name field here, like so. Okay. And now what we are going to do is we are going to test by getting our application name changed. So it is job service demo over here. So I can make it default. So this is the default configuration file or default application.properties, I should say. So in dev, you have ending with dev, and in prod, you have the one ending with prod, which is fine. So now what we can do is we have commented this. Now we can restart the microservice. So I'll say job microservice. Let me rerun this. Okay, so we got an error because of the URL here. So we need to add / over here, and let us try running this after adding the same. And now you will see our application is up and running. So removing these / was a mistake. You should keep it over here. Okay, we have it here as well. So that was a mistake from my end. But here we have the application up and running. Now you can head over to Eureka and we can say refresh. And now you will see over here, the application name is job service default. And this is coming in, of course, from our Git repository where we have specified default here. Okay. Now you can head over to logs and you can say Control F here and you can say fetching config. So you can see this log trace over here. So here what happened is when the application was started, it started fetching the configuration from the server at localhost :8080. And this is a URL that we have specified in the application.properties. So it fetched the configuration and it applied the configuration. Also, you can see the profile that was applied was default here. Okay. If you want, you can add a different profile if you wish to. So here, I can add one more property. I can say spring.profiles.active and I can say def. Okay. You can add any profile for which you have configuration created. And if I restart the application, you will see this time the profile that will be applicable will be dev and not default. So we will wait for that stack trace to come in. So if you scroll up here, okay, you can see here the configuration was fetched and you can see over here dev is the profile. Okay. And if we head over to Eureka, if I refresh, you will see job service dev appear over here. And you can even try this with prod. Okay, here you can even change this to prod and you can restart. So this is how you can fetch different profiles and you can work with different profiles. So essentially, if you have different environments, so let's say you have different environments like prod, dev, QA, and you have different database URLs and different username passwords for these environments. So what you can do is you can have different URLs and different settings created on Git and you can fetch them from there. Okay, so it will work this way. So this is about how you can change the profiles. Now I wanted to talk about one more thing over here, which is optional. So there is one more property that you can add to this particular setting over here. So you can specify if you want to make this import of the configuration from the config server as optional. Okay. Now, how do you specify this as optional? So let me give you an example. Let me shut down our config server. So what happens if our config server is unavailable? So if I shut down my config server and if I restart our job application, let us see what happens. So you will see we got an error here. And if you scroll up here, you will see IO error, which is of course there is no, like, this is not accessible now, right? Because our config server is down. And if you scroll up here, you will see this message. So could not locate property source and resource is optional. Resource is not optional. So here it says that you have not specified this particular resource, which is this particular resource, which is not available right now. And since it's not optional, so I'm not starting the job service. So you can mark this particular thing as optional. So you can say optional : and now if you try to run this, also let's say before running, we will have this name thing uncommented. So because we had commented this, so I'll start the application. And now if you go at the top here, you will see the application is starting. Here you will see fetching the config from this particular server, but this server is not available. Okay. So it will try a couple of times here. You can see it tried 3 times and then it will went ahead. Okay. So it tried quite a few times. You can see not even 3 times. So after this, it just went ahead with starting the service. Now the service is up and running. And if you see the name, it is simply known as job service because the configuration is not being fetched right now. And we are using the local application.properties. So this is one scenario that you might want to handle in your microservices architecture, that what happens if config server is not available. So this helps you handle such scenarios. All right. Now, if config server is available, so if I make this service available again, and if I restart the job service, so you will see things working as normal without any issues as such. Okay, so job service is also starting now. And if you head over to Eureka service, you will see the name is now being fetched from the GitHub repository. So if I refresh, I have config server up and running. If I refresh again, you have job service dev up and running. And this is coming in from the Git repo and not from this local file here. So this is the significance of optional parameter here, is what I wanted to highlight. And this is very important. Like if you want to, so what will happen typically is if you have multiple microservices and a single centralized config server, and if that fails, everything goes down. So this is not right. Well, you need to have optional parameter as long as you can. And that is one benefit of getting your microservices loosely coupled. So this is about how you can connect or set up Spring Cloud Client with your microservices.
Hello and welcome. So let us start talking about what is an API gateway. So before we talk about API gateway, let us do a recap of the basic premise of microservices. So in microservices architecture, the monolithic application is broken down into small, loosely coupled services. And each service corresponds to a specific business functionality and can be developed, deployed, and scaled independently. So here you have 3 microservices, okay, and they all serve a specific business purpose and they are independent. Now, as you can imagine, when we have numerous services interacting with one another and client applications, the complexity of managing these interactions increases significantly. And this is where the API gateway comes into play. So now, since we have multiple microservices, we have a problem. So what is the entry point for our application and how should we interact with it? So each and every microservice will have different service URLs from where they serve their specific functionality. But for a user does not care about your underlying structure. So for user, your application is a single entity as a whole and it has to function as a whole. Behind the scenes, you can have multiple services serving each functionality. That is fine. But for a user, the application is a single unit and not multiple microservices tied together. So the question for a user or from a user perspective is, what is the entry point for me into your application? Because everybody has their own host URLs. So I need a single entry point, and that is where API gateway comes into picture. So you can think of API gateway as a special type of reverse proxy or something that routes the requests from the client applications to the appropriate microservices. And it acts as a single entry point for the external client request. Now this simplifies the client-side experience and it also hides or masks the internal complexity to the external world. So API gateway serves this particular purpose and they are very useful when it comes to microservices architecture. So let us talk about some of the advantages that we have with API gateways. So the number one advantage is the encapsulation. So API gateways encapsulate the entire system architecture and provides a level of abstraction between the client applications and your backend microservices. This means that changes made to the microservices, such as adding new microservices, modifying existing services, and even changing the service locations, can be done without impacting the client. So imagine like you have a microservices architecture and you change something and somebody was accessing that URL from outside the architecture, like for example, a client or an external application or something.
So that application will break provided it's dependent on that service. So you need to mask these changes, and for the outside world, it should be like nothing has changed in your system. So how do you handle that? An API gateway can help you with that. So with this advantage, API gateway encapsulates the entire internal system architecture. The next advantage would be to handle cross-cutting concerns like security, load balancing, rate limiting, and analytics. Now, these things are important when it comes to microservices or building any application. So essentially, you can have API gateway handle all of this, and basically the microservices can be free from such things. Okay, so you delegate all of that responsibility to API gateway. The next advantage would be authentication of incoming requests. So this is also part of security, which we spoke about. So API gateway can also authenticate incoming requests, and after authentication, the valid requests are only given to the service. Okay, so this allows to have a authentication on the entire microservices network. It can even aggregate responses from different microservices. So let us say client needs something and you need to collaborate with multiple microservices in the hindsight for getting that response. So API gateway, what it can do is it can communicate to multiple microservices, collate the response, and give it to the external client. So this can be done by API gateway, and it can help you reduce the number of trips or round trips between client and server. And this can greatly improve the performance and the user experience, particularly in mobile applications where network latency can be a significant issue. So this way, API gateways play a crucial role, and the role of API gateway is really crucial in simplifying the client side of interactions and managing different concerns. So this is the importance of API gateway as to why it's needed in microservices. Let us start talking about the functions of API gateway. So there are a few core capabilities that API gateway brings to your microservices architecture. The number one is request routing. So the primary function of API gateway is to route requests to appropriate microservices, and it acts as a single point of entry and routes each incoming request to the right service. This not only simplifies the client side, but also abstracts the complexity and the details of the underlying services for the client. Load balancing. Now this is another feature or the ability of API gateway, where an API gateway often incorporates load balancing to distribute traffic across multiple instances of a particular service. Now this helps improve responsiveness and availability of applications. So if a service is scaled up by adding more instances, the API gateway can distribute requests evenly across all instances. The next one would be authentication and authorization. So security can be one of the major concerns when it comes to microservices or any application, in fact. So API gateway can authenticate the client credentials and then forward the request to the right service. Rate limiting. So this is one more ability that API gateway can help you with. So API gateway helps you protect your services with the help of rate limiting. So essentially what rate limiting means is limiting the number of requests a client can make to any given service in a given amount of time. That is what rate limiting is. And this is done to prevent overuse, abuse, or prevent any attacks on your services. Then you have request and response transformation. So if you need to transform your request or response, so API gateway can act as a middleman, and once it gets the request, it can transform the request and send it to the respective site. Aggregation of data from multiple services. So API gateway can aggregate the data from the multiple services or microservices that exist, and it can unify the response and send it to the client. So this is about the capabilities of API gateways, and you can see it performs a variety of functions that can make it easier to manage a microservices architecture. It provides a central place essentially where majority of the functions are handled and they can be common across different services. So this is about API Gateway. Now, what are we going to do and how are we going to implement API Gateway? So here is how we are going to implement API Gateway into our microservices project. So we have the microservices network or the microservices here. So these are 3 microservices. One is the review microservice, then we have job, and then we have company. These microservices have their own database, okay? And they all communicate with the config server, Eureka server, and the ZIPKIN server. Now, we are going to add another layer of API Gateway, which will be responsible for routing the external requests. So whenever you request anything in your application, whether it's a mobile app or it's from a client which is on a desktop. So these requests are given to API Gateway and they are handled by API Gateway. And then API Gateway will route those requests to the appropriate microservices depending on what the client is asking for. So this is a function that we are going to implement, and this is what our architecture is going to look like. So excited? So let's jump into the details. Welcome to this class. So let us start talking about how are we going to actually implement an API Gateway into our microservices architecture. So we are going to take help of Spring Cloud Gateway. So if you search for Spring Cloud Gateway on Google, you're going to land on this URL, which is the first URL here. And it is the official website of spring.io. So this is the official page of Spring Cloud Gateway. All right. And it's a part of Spring Cloud project, as you can see here. So we will be using this, and you can take a look at different features as well that it has to offer us. So you can see it offers a circuit breaker integration. It is built on Spring Framework 5, and it is able to match routes on any request attribute, and it offers predicates and filters as well. So we are going to work on this, and we are going to integrate this into our application. Okay. And how are we going to implement? So this is what the architecture will look like. So you will have this microservices here. We will have 3 microservices is what we have right now, along with their own copies of database, along with a config server, Eureka server, and ZIPKIN server with which they communicate. And then we are going to have a Spring Cloud Gateway setup like this, which is going to take care of all the requests. So without a further ado, let's get started. So now let us start setting up the application gateway for our microservices architecture. And we are going to make use of Spring Cloud Gateway. So let us head over to Spring Initializer. And here I'll change the artifact and name over here. So I'll say artifact as gateway, and name is automatically changed. So description is, this is gateway. So I'll just have description as gateway. You can have any description you want. That's perfectly fine. You have package name automatically generated, packaging jar, and Java 17. Just make sure you have selected Maven here and a valid or relevant Spring Boot version. Now I'll remove this from here. So I need to start adding the dependencies. So what are the dependencies that we would need for our gateway project? So the first dependency I'm going to have is Eureka. So I'm going to register this particular service with Eureka. I'm even going to have the ZIPKIN dependency. So ZIPKIN is another dependency that I wish to have over here. Okay. And then I'm going to say gateway. So you can see here Spring Cloud Routing, which is gateway, and this is a simple and effective way to route APIs. So this is what I have added. Now if you go to explore here, you're going to see the pom.xml being generated.
And this is the dependency that we are adding for this project to act as a gateway. So this is a dependency that will do the magic. So this is added. Now what we can do is we can download the entire source over here. So I've downloaded the file, and here you are going to see gateway.zip. So I'm going to unzip this file here, extract here. You will have the unzipped version. And now let's import this into IntelliJ. So here in IntelliJ, I'm going to go to Maven, and I'm going to add this project to this particular view. So I'm going to select gateway here, and this project gets imported. So now we have a project here in this particular view. All right. Now what I will do is I will go to the application.properties. So we have all the dependencies set. I'll hide this sidebar. So we have all the dependencies set. We need to head over to application.properties to do the relevant configurations. And I'll get some configuration from job service here. Okay. So I'll copy all of this and I'll paste the configuration here. Okay. We will remove everything that is irrelevant. For example, this is irrelevant, the database part. We don't need this. Even PostgreSQL part is irrelevant here. Okay. Now here, I'm going to call this as gateway, like so. And this is going to run on port 8084. So this is going to run like any other Spring Boot application, but it is going to do the job of routing the request to the relevant service whenever a request is coming in from the external client. So now here we have some settings related to Eureka, which we are going to keep as it is. We have ZIPKIN sampling rate as well, which is fine. We have config server, so we don't need config server here in this particular application.properties file. So basic configurations are done. Now we need to set some routing logic. So I have the routing logic written in a notepad file over here. Okay. So we need to add this to our application.properties. So I'll copy this and I'll paste it over here. So I'll say gateway, like so. So this is a logic related to the gateway routing. Now what does this mean over here? So here we are setting routes, which means this is a logic as to how the request from a gateway is routed. So for example, we have this first route set over here, and this has three parts. One is ID, URI, and the predicates. So you can see this is the first route, and you can see this with the help of index. Now the ID over here is company service. The URI is this. And here we have added the path. Okay. So ID is nothing but the unique identifier that is given to the route. Okay. And this field can be anything as long as it's unique amongst all your routes. Okay. So here we have everything unique. So company service is unique, job service is also unique. Then we have the URI part, wherein this is the address of the backend service that this route will forward request to. For instance, this particular service, company service, so any request to this service will go to this route. Then you have predicates. So this is a list of conditions that an incoming request must meet to match this route. And each predicate will have such pattern over here, which is used for matching. And if the match is true, then the request is forwarded to this particular microservice. And then you have more routes that we have defined over here. Okay. So essentially here in terms of predicates, we are specifying in this format. Okay. And this is like an inbuilt predicate sort of thing. So here you can see here we are using 2 stars for pattern matching. And this is a wildcard that matches any sequence of characters. So for example, company /1/2, anything will be matched to this particular route as long as it has company in it. Okay. So that is what this means. Same goes for job and same goes for review. So if you take a look at our jobs, review, and company microservices. So if we go to the controller here. So in controller, the entire controller is mapped to /jobs. Okay. And then the rest of the part keeps on changing. Okay. So what we have done is we have said /jobs here. Okay. So if you scroll up, here we have /jobs and here we have /jobs. So that is how it matches. But I noticed a small mistake over here. So here we are saying jobs. So here also we should have jobs. So it's plural. And let me check the same for review as well. So I'll head over to review. Here also I'll go. In review controller, you will see it's reviews. So essentially it's plural over here. So we need to change it to plural and not keep singular. So I'll go to company as well and we'll just verify. So here also it's companies. So we'll keep this plural. Okay. So yeah, this should work now. And I have specified the port as well. So this is the setup done for Spring Cloud API Gateway. Okay. So we have the project setup and we have the necessary configurations done that we need our gateway to function properly. So that's about this class. I shall see you all soon. Thank you. So our gateway server is set up and configured. Now what we can do is we can add some configurations to our application.properties of gateway to enable some behind the scenes. So what I would be doing is I would be switching over to Notepad here and I have some properties written here. So I'll copy these properties and I'll paste it over here like so. Now what do these properties mean? So these properties are used to set the logging level of various components of our application. So this first part, logging level root is equal to info. This sets the default logging level for all the loggers in our application to info. And this means that any logging statement by default with the level of info, warn or error will be output in your application's log. Okay. And then we have the next statement over here, which says like logging level Spring Framework Cloud Gateway Route Definition Locator is set to info. Now what does this mean? So this particular line sets the logging level specifically for Route Definition Locator class in the Spring Cloud Gateway to info. Okay. Now we have the third line as well, which sets the logging level for Spring Cloud Gateway to that of trace. So within this org.springframework.cloud.gateway, all the classes will have the logging level of trace. And this is very detailed level of logging that includes debug set statements as well. So this is what we are setting in. Okay, this is going to help us understand what is happening under the hood. So we have the configuration done for gateway and our gateway is ready. So what I'm going to do is I'm going to head over to our main application and I'm going to run gateway. So we are going to have gateway added over here as a service. And now if we head over to our browser and if you head over to Eureka server and if I refresh, we will see gateway being added as one of the services that exist in our microservices architecture now. So now, since we have the gateway up and running, it's now time to test this. So I'll switch over to Postman here. And what I'm going to do is I'm going to create a new collection over here. And I'm going to call it as gateway. Now, what will this collection have? This collection is going to have the URLs that will point to the API gateway. What URLs should I take over here? So I'm going to expand the company microservice over here. So this company microservice collection, and I'll duplicate the collection or duplicate the API to create a new company. I'll duplicate the API to get a new company and I'll move them both over here. Okay. So we'll use this duplicate method because this will save some time. Like we just have to change the port number. So this will help us save some time so that we can move faster
And here I'll take 2. So I'm taking only 2 requests into gateway. So we'll be testing gateway with only 2 requests. So we'll do a post request and then we'll do a get request. So that will give us enough idea as to how gateway is working. So I've moved them both and these both are copies. So review is done. Now we can do for job. So for job microservice, I'll duplicate this one. And here I'll duplicate the get one. So this one and then the get one here. Right, so now I'll collapse everything. I'll close this. Now let us change the port and everything for all the requests. So we'll start with the companies. Okay, so I'll say 8084/companies and I'm going to copy this URL and add it over here. Okay, so this is modified and I can hit save. Now I can even trigger this particular API and get the company created. So let us even do that. So I'll say send and you will notice that we have sent the request from 8084 and you will see that the company is created over here. Now the moment we triggered this API request, if you head over to IntelliJ and if you select gateway application over here and if you scroll up, you will see a lot of logs that we have enabled over here. Okay, so one log that so here you can see the match happening. So 8081/8084/companies. Okay, and if you scroll up here, so you can see this line over here. So pattern/companies ** matches against this value /companies. And this is how the forwarding works. So essentially, whenever a request comes into gateway, the pattern is matched against the configuration that you have specified, and then it is forwarded to the relevant URL. Okay, so you can see and learn from these logs here. So we will get back to Postman. Now here in Postman, I'll start modifying my other APIs also. So I'll just copy, or let us copy this entire port number and I'll update this here. And also I'll copy the entire URL and paste it over here. Now if I try to get companies, this API is also going to work. Okay, so I had one company already added and I added one more. Now here, if you go to reviews, we need to do the same thing. In fact, we need to do the same for all the requests over here. Okay, so I'll just do this for everything. Now this is a GET request and we have one review existing over here. Okay, but you can also play around with the post request if you want to. So I'll just trigger a post request as well. So here I'll say send and you'll see review being added successfully from the gateway port. And let us do the same for jobs as well. So I'll say 8084 here. Okay, so I'll have to type in, it seems. And I'll copy this URL and I'll paste it over here like so. And for this URL also, I'll change this to 84 and I'll copy this and I'll paste it over here. So we are done with the changes. Now let me post a job. So I'll post a job and you can see job has been added successfully and I can get the job. So you can see we're getting like job, company, reviews and everything. And there are a couple of jobs that have been added here. Okay. So indeed it is working perfectly fine. There are no issues as such. All right. What you can do is you can right click over here and say close all tabs and say save changes to all the pop-ups that come in. So it will save all the requests for you in Postman. All right. Now I wish to show you one more thing over here. So if you go to, so here we have Eureka server running. Now I wish to show you ZIPKIN as well. So you can say ZIPKIN here and you can go to this dashboard. All right. And you can say run query. Now you will see few requests that we have triggered just now. And this was the request that we triggered last. And this is from the job API, I believe. Right. So if you say show over here, you can see how the request flowed. So the request first went to the API gateway, and then from there it went to jobs, company service, review service, company service, review service, and then we got the final result. So all the requests are now being routed via gateway, and you can take a look at different requests over here. If you take a look at company request, so this is the API request to create a company, and we went through API gateway here. So you can see services it touched is 2, total spans that exist were 3, and this was the trace ID. All right. So you can go over here and you can just play around and see. So every request is now going through gateway. If you say expand all, you will notice this. Okay. So gateway is indeed in action. And now the benefit over here is you have this single URL, localhost colon 8084. And you can give this URL to anyone. Okay. And this URL / jobs is for jobs microservice / company is for company microservice / reviews is for review microservice. But this detail that there are different microservices for different functions is only for you. Like you don't need to expose this to the entire world, right? So there is one single URL over here. And if you deploy this onto a server or something, you can have a domain name mapped over here. And then it will work seamlessly. So external users won't know actually what is happening behind the scenes, because there is only one URL that is taking care of everything. So this is API gateway in action for you. I would request you all to play a bit around with this one and go hands-on a little bit and understand as to how this is working. So that's about this class. Thank you, and I shall see you all soon. Hey there, welcome to this class. So we have our Spring Cloud Gateway server ready, and we have already done some configuration that we need for gateway to function properly. Now here, I wanted to talk a little bit about HTTP versus LB. So HTTP is the standard HTTP protocol wherein you use this as a part of the request, and all the requests that you trigger go through the HTTP protocol. Okay. And the services using HTTP are located directly using the URL, and you specify the host and port there. So this is something that we are aware. Now what does LB mean? So LB stands for load balanced, and this is specific to Spring Cloud, and it indicates that the service should be located via a load balancer. So let me give you an example. Here we have a job service and we are using HTTP over here. So let me remove this HTTP and I can have LB over here. Now LB means load balanced is what I mentioned. Now when you use load balanced in a URI, it means that gateway would use the Spring Cloud's service discovery mechanism to locate an instance of the service. Okay. And usually when you use LB, you cannot use the host and the port number, but instead you have to use the service name over here or the service ID. So here, if we go to Eureka, this is the service name that we have. So I'll copy this and I'll come over here and I'll paste it over here. Now, why would you do this over HTTP? So I'll tell you one reason. So here, HTTP is good if you have a single instance of microservices running. But when you have multiple instances, for example, let's say you have 10 instances of one microservice running, then in that case, you need to load balance the request. Now, what I mean by load balanced, you need to make sure that the requests that are coming to that particular microservices are distributed evenly across all the instances that are active right now. So for example, for job service, if you have 10 instances up and running, so let's say this service is getting a lot of traffic and we have added multiple instances. And in that case, which instance should get the traffic? So that is something that is decided by load balancer. But to configure it, you need to give this over here. So you need to have LB colon the service ID. So in that case, the discovery will happen with the help of service ID. Now under that service ID, there can be 10 instances running and the request will be distributed evenly. So here with HTTP, you are specifying a specific instance over here. So I want my request to go to this instance. But here you are just saying, I want my request to go to this service. Now it does not matter how many instances for this particular services are running. Because in this case, there will be one more instance, or there might be one more instance of company service running. But there is a possibility that that instance is running on a different port. So that won't be utilized, or that won't be called. So when you use service ID, that is the benefit that you get. Now let us test this. So we have load balanced this particular thing. Okay. And what I will do is I will run one more instance of job microservice over here. But the question is, how do you run one more instance? So you can't just right click and rerun. You don't have any option here. So instead, you need to go here at the top. You need to say edit configurations. You need to select the configuration for job microservice. So here, these are all the run configurations for our services. So I need to duplicate this. So I'll say copy the configuration. A duplicate is created. And now I'll specify a distinct name for this particular configuration here. So let's say our job microservice is running at 8082. So I can run this at 9082. Like so. Now, how do we run this? So in order to run this, we will have to pass some extra parameter. Okay. And why do we have to pass this? So I'll just say apply and I'll say okay. So here, if you come to the job service properties, you will notice that we have specified the port number over here. All right. But the instance that we are running now, we want a custom port. So we don't want to go with 8082 port. So we need to override this during the runtime. How do we do that? So in order to do that, you need to click on modify options. You need to say add VM options. And here you need to say -t server dot port is equal to 9082. So this is an extra parameter that you are passing during runtime, and that will be taken care by IntelliJ. Okay. Now I need to hit apply here. Just make sure that you hit apply and you say okay. Now you have one run configuration over here. So you need to select that and you need to say run. Now the moment you do that, you will see a new run configuration or a new service appear over here. And hopefully there should not be any errors. Okay, so you can see the registration is successful, 204, and the application is up and running. Okay, so we have now 2 instances of job microservice running. So I'll switch over to Eureka now and let us refresh and see what happens. So here for now, without refresh, you are seeing one service ID and one instance over here, which is running on this port. So if I say refresh, can you see there are 2 instances now that are up and running. Okay. Now, if we go to Postman, I can actually call any of the instance. So I can hardcode the instance port number and the host over here, and I can call. So if I do a call to 8082, it will go to the first instance of jobs. If I change this to 9082, it will go to the second instance of job. But we don't want to handle this, okay, round robin. So what we will do is we'll send the request through gateway. So now here, if I say get job, the job is empty, of course. So I'll create a job and I'll try getting it. So here now you will see from the user standpoint, I'm interacting with the gateway URL. And for us, I don't know, we don't know in backend how many instances are running. Okay. So I just need to interact with the gateway, and the request is load balanced, which means that depending on the load, gateway is going to distribute the requests that are coming to different instances depending on the traffic. All right. I hope this is making sense. So the job of making sure that the load is distributed evenly is taken care by Spring Cloud Gateway over here. And you can go to your browser, open ZIPKIN, and you can say run query, and you will see over here. So you can go over here, you can select this, and you can see this particular request is, so if you select the jobs URL here, so here we are not seeing the port yet, but ideally if you see the port over here, you would have got the idea as to how it's working. But what I want to show you is, for us from the user standpoint, it's working perfectly fine and we are not aware of what is happening. So here you can see the port number, see 8084, and if you send a lot of requests, you will see some requests going there as well. So it is distributed depending on the load. Okay, so we don't need to worry about this, but we have ZIPKIN and all the tools to get an idea of what's happening. So in general, if you use HTTP, you know the exact host and port of the target service and you know it won't change. But when would you use LB or load balanced? If you want to use the service discovery and load balancing mechanism of Spring Cloud, which is more flexible and robust in microservices architecture. So now I'll come back to our project and we will update this for everybody. So we can like change this LB colon, or I'll just copy LB here and we'll make everything load balanced. And now I need review service. I'll copy the review service here like so, and I'll paste it over here. I can go for the company service as well, and I can paste it over here. So I'll paste it over here. Done. Now I can restart all my services and test the changes. So it should work perfectly fine, but now we have moved from HTTP to load balancing for our microservices. So that's about HTTP and LB. Thank you. So we now have all the requests being routed via our API gateway, and we are making use of Spring Cloud Gateway for this. Now there is one thing still left. So if you head over to our browser here, if I head over to Eureka URLs is still some other port number and it is not yet going through gateway. So what you can do is you can even route Eureka server from the API gateway that we have configured. Now how would you do this? So to do this, I'll head over to our configuration file over here, which we have created for API gateway. So right now I'll switch to gateway application.properties and I have it open here. So here we need to add a few more routes to configure the Eureka server. So I have those routes written over here. So I'll simply copy them. So I'll copy this first 3 lines and let us add these first 3 lines. So what have we added? So we have added Eureka server here. We have pointed it to this URL. So this is a URL where our actual server is running. And then we have specified the path where we want to access. So if I copy this path and if I head over to the browser and if I say localhost 8084, so I'll say 8084, and if I go to Eureka/main, I'm going to get an error. And this would give an error because the request is redirected to Eureka/main on 8761 port. So it's being redirected to /main over here like so. We don't want to do that. Okay. Now how do we tell the route to transfer the request to the root URL over here? So if you look at the configurations over here, what we have done is if the request is coming on 8084/jobs, it is simply being routed to 8082/jobs. So this path is not changing over here for any of the microservices that we have. But for Eureka server, there is a need for us to change the path over here. Now, how do we do that? So we can do that with the help of filters over here. So we need to take this filter thing over here and I need to paste this over here. So this tells that whenever the request is being routed, it does not need to be routed to /Eureka/main, but instead it is supposed to go to /root URL when you are calling 8761 or when you are routing the request to 8761. That is what it means. Okay. Now let us try running this and let us see what the output looks like. So I'm going to restart my gateway application and let us wait for this to turn up. Meanwhile, we'll head over to Eureka server and I'll hit refresh. So it's not there yet. And it's there now. So gateway is up now. Now what I can do is I can refresh this URL. So localhost :8084 Eureka/main. So you can see here, we are seeing the Eureka server as well over here. Okay. So it is working perfectly fine. Okay. In case if you don't see the CSS and HTML being loaded, so I have one more piece of code also written over here. So you can simply add this to load all the static files. Okay. So what you can do is here at the bottom, you can add this as well if the static files are not being loaded. Now what I mean by static files is files like JavaScript, CSS, and some basic things or basic elements that beautify a particular web page. So if that is not being shown to you, you can add this as well. So essentially your file would look something like this. Okay, so you would be adding these two things into your file. All right, and I've added this. Even if I restart, it would work perfectly fine for me. But for me, I'm seeing the CSS already being loaded. So that is not a problem here now. But if I refresh, the connection is refused because the service is not yet started. So gateway is down. So if I refresh from here now, you can see we are seeing the Eureka server being loaded from the gateway URL. And this is amazing because now you have a single URL for everything. So if someone is doing some administration related work and if he needs to access Eureka server, he does not need to go to the actual Eureka URL, but instead you as an application developer can configure the gateway to show Eureka server as well. So there is only one URL now that is being exposed to the outside world. Isn't that amazing? Yes, it is. So that's the power of Spring Cloud Gateway. That's all from my side. Thanks a lot.
Hey there. Welcome to this class. So let us start talking about fault tolerance and understand what it is and why is it important when it comes to microservices. So in distributed microservices, there will be scenarios where something or the other fails. And it's really important to manage these failures. And this is where fault tolerance comes into picture. So what is fault tolerance? So fault tolerance can be defined as the ability of a network or a system to continue operating without any interruption. So this is what fault tolerance means. Now, the question is, why does this matter much to microservices? So in microservices world, we have different systems. So it's a distributed system where each service is running on its own and there is a possibility that one service might fail. So there are three microservices as you can see over here and it's part of an architecture. And to outside world, it is one single application. It is not three different systems. It's just single system that exists. Now what happens is usually these microservices will be communicating with each other. And in such scenarios, there can be possibilities that one service fails. So let's say microservice 2 fails. Now because of that, all the calls that would go to microservice 2 would fail. And this would result in entire system collapse, which is not good. So this means that our network is not fault tolerant. So if something goes wrong, our network or our application should actually continue operating. So how do you make your architecture or application fault tolerant? So this is where the need of this concept comes into play. And let us talk about some needs. So if we have to highlight some of the needs, number one thing would be fault isolation. So failure in one microservice should not lead to complete failure of entire application. So if one microservice fails, the failure should be restricted only to that microservice. And that is where this fault isolation comes into play. And this is one of the reasons why we need fault tolerance. Then network latency. So microservices communicate over a network, and there can be possibilities where there can be network failures, and there will be several issues wherein the network call might just not happen. And in that particular case, we need to take care of the network latency, and this could lead to failure. There could be deployment issues. So since microservices are deployed separately, so if you have 3 microservices, those 3 will be deployed separately as separate application. Now, because of deployment, there is a likelihood that there are some issues that I've encountered during the update of a microservice. And because of this, that particular microservice might be down for a little while. Now, this is where the problem comes in. So how do you handle such scenarios? So this is where fault tolerance also matters. Increased complexity. If there are several microservices in your architecture or your application, it could lead to increased complexity, and it could also lead to unforeseen failures which you cannot gauge as a developer. And this is where fault tolerance again is important. Lastly, we have elasticity, and then we have tolerating external failures. So elasticity talks about how well can microservices often scale independently based on demand. Okay. So if you make your microservices resilient enough, your microservices can scale easily without causing any disruptions. And then tolerating external failures. So in this particular case, microservices might interact with external services or APIs or databases. Like for example, I might be using Twitter API, or I might be using some API which allows me to convert a text to PDF or something like that. So it could be any external system that I am interacting with. And if that system goes down, then that microservice which is using that particular system will be impacted. And in this particular case, like, you need to handle these things gracefully. So these are the needs as to why fault tolerance becomes important when you're building a distributed system. It becomes really evident, like, you need a concept like this when you are building something as complex as microservices. So this is about fault tolerance and why something like fault tolerance matters when you're building something as complex as microservices. Welcome back. So let us start talking about Resilience 4J, and we will also discuss Resilience 4J modules, features, and we will even cover some techniques when it comes to adding resilience to your network. So before I talk about Resilience 4J, I wanted to spend some time talking about what you mean by this word resilience. So what is resilience? Resilience is ability or capacity of something to recover quickly from difficulties. So when we talk about microservices, fault tolerance in our network is really important. So fault tolerance in our architecture makes sure that we are resilient enough to failures. And this is where the concept of resilience comes in. So resilience exists to add fault tolerance in our microservices architecture. And there are a few techniques, patterns that helps us deal with failures that happen in our system, because we need to ensure that our system can handle these failures gracefully. Of course, when you're building microservices, you cannot avoid failures. So not only microservices, when you're building any kind of systems, like, failures can just happen. It just comes with it. But the best part is you should be able to handle them gracefully. And this is where these techniques come in. So let us talk about some techniques there. So the number one technique is retries. So whenever you have a request to a microservice that fails due to some temporary issue, like, and the issue can be like
network timeout or resources unavailable or something, what you can do is the client who is making the request can automatically retry the request a certain number of times. Okay, so if I make a request to microservice B, okay, and I am microservice A. So if B is down or there is some issue with B, now I made a call to microservice B and the call didn't went through. So I can decide to retry the request for a certain number of times. And these retries can help improve the chances of a successful request, especially when the failure rate is due to some temporary issues like network latency or something like that. So there is a possibility that if I do a second or a third retry, the microservice is up and running and my request is successful. So this is about retry, and this is one of the techniques that exist. So this way we have avoided the fault that would have happened in our network or our architecture, and we have made our system resilient. So this is one of the technique. Another technique I want to talk about is rate limiting. So what is rate limiting? So rate limiting controls the number of requests that a microservice can handle within a specific time frame. So it prevents the overload on the service and ensures that there is a fair usage of the resources within that microservice. So every microservice or every system that you have has a capacity, and rate limiting makes sure that the requests that are going to that particular microservice in a particular time frame matches the capacity and it does not overshoot the capacity. So rate limiting is useful for protecting against some excessive traffic or potential attacks like denial of service. Okay, so this is about rate limiting. You have bulkheads. So bulkhead is a pattern. It's about isolating different parts of the system to prevent a failure in one component from affecting others. And in microservices, this means dedicating a separate resource for different services. And if one service experiences high load or fails, it won't impact others. So this is bulkheads. Then you have a technique called circuit breakers. Now what is circuit breaker? So circuit breakers monitor the health of the microservices and they prevent the cascading failures. So if there are two microservices, let's say microservice A and microservice B, and if B fails, so because of the failure of B, it won't impact A. So if there is a request that is going to B, circuit breaker will make sure that it handles gracefully. Now how this is handled is when a service repeatedly fails or experiences high latency or something, the circuit breaker trips and the subsequent requests to that particular service are redirected to any fallback that you must have declared or the error response. Okay, and this avoids overloading a struggling service or provides a degraded but functional experience, and it makes sure that the application does not breaks. So this is about circuit breakers. Then you have fallbacks. Now what are fallbacks? So fallbacks are alternative actions or responses that are provided when a microservice is unavailable or it fails to just respond. Now fallbacks can be predefined. Okay, so you can have default values or like default responses from cache or some secondary data sources. And this way you can create fallbacks for your service. So fallbacks ensure that users receive some response even when the primary service is unavailable. And this helps prevent failures which would have occurred if fallbacks were not present. So this is one way of handling, or one technique of handling failures. Then you have timeouts. Now what are timeouts? So timeout is the amount of time a client who is making a request will wait for a response from a microservice. Okay, that is what timeout is. So if the service does not respond within the specific time period, the client can take the desired action, like which is defined, such as retrying the request or using any fallback. So alternative path can be anything depending on the microservice, but yeah, you can retry essentially, or you could have fallback or anything like that. So this is what timeout is. Then you have graceful degradation. Now what is this technique? So graceful degradation refers to the ability of a microservice to continue functioning with reduced functionality when facing issues or high load. So non-essential or resource-intensive features can be disabled or simplified to maintain essential services only. Okay, so this is what graceful degradation is, and this helps prevent failures and ultimately makes sure that our architecture is able to tolerate faults and ultimately makes our architecture resilient enough. Now, how do you implement all of this? So this is where we can talk about Resilience 4J. So Resilience 4J is a lightweight, easy to use fault tolerance library. Okay, because managing these patterns that we just spoke about can be a challenging task, and that is where Resilience 4J comes in. So Resilience 4J is a simple library which you can add to your project. It is very lightweight and has minimal dependencies and is specifically designed to be used with Spring Boot applications. So this is the best part. So Resilience 4J also has key modules such as retry, circuit breaking, rate limiter, and so on. Okay. Now we discussed why it's a good choice. So it has easy integration with Spring Boot. So it has a starter library which you can add to your project and you are ready to go. Then it is built for functional programming paradigm. And this is a programming paradigm that is introduced in Java 8. And this makes this library great fit for modern applications. All right. So this is why it's a good choice. Now let us talk about some of the Resilience 4J modules that I would like to introduce you all to. So the number one is the retry module. We have rate limiter, then we have bulkhead and circuit breaker. Let us talk about retry module. So it is not uncommon for a network call or a method invocation to fail temporarily, and this failure could be because of network glitches or any other issue. So rather than failing immediately, we might want to retry the operation a few times before giving up. And this is where retry module from Resilience 4J comes into picture. So retry module enables to easily implement retry logic in our application. So you just need to do some configuration and add an annotation and you are good to go. Then we have rate limiter. So when we have a service that can handle only a certain number of requests per time period, so we need to ensure that we do not exceed that limit. Otherwise, the service will be overloaded and it will go down. And this is where rate limiter comes into picture, where rate limiter allows you to enforce these restrictions and protect our services from too many requests. Then you have bulkhead module. This module is based on bulkhead pattern and it isolates failures and prevents them from cascading through the system. Okay. So the idea here is to limit the amount of parallel executions or concurrent calls to prevent system resources from being exhausted. Then you have circuit breaker module. Now this module is used to prevent a network or a service failure from cascading to other services. So this way you can add resilience to your network. So if a circuit breaker trips or opens, then this particular module prevents the further call to that particular service. And ultimately it makes your architecture fault tolerant. So this is about Resilience 4J, their modules, and some of the techniques that we have learned in this lecture. Hey, welcome back. So let us start talking about what is circuit breaking. So what I'm going to do is I'm going to head over to google.com in my browser and I'm going to search for Resilience 4J. So Resilience 4J. And the moment you Google this, I'll zoom in a bit. So you are going to see this first link, which is resilience4j.readme.io docs. So just hit this link and I'll visit this URL and you will see this documentation open up. Okay. So this is the official website of this particular library here. And you can read more about this particular library. Like it's a lightweight fault tolerance library, designed for functional programming. Okay, so you have a lot of information here. You can just go through if you wish to. Okay, it talks about the core modules that this library has. And on the left hand side, you have a sidebar where you can see core modules like circuit breaker, bulkhead, rate limiter, retry, and so on. Okay, so you can just explore this website, but what we are going to talk about now is circuit breaker. So I'll just head over to the circuit breaker and you will see this link open up over here. Now you can see a diagram over here. So now what is circuit breaking? So circuit breaking is a mechanism that is used in microservices architecture to avoid cascading failures across multiple services because of that one service. Now, why is it called circuit breaker? Because it implements the mechanism that is similar to that of electrical systems. So in electrical system, you have a circuit that can be closed. So if it's closed, the electricity flows, and if it's open, the electricity stops flowing. Okay, and that is how this particular thing works. So here you can see there are different states. So you have closed state, open state, and half open state. So closed state meaning the system is healthy and there is nothing that has failed. Now what happens if anything fails? So if anything fails, there is a failure rate that is associated. So you can see failure rate happens, and then there is a threshold that is configured with this system. So if the failure rate goes above a particular threshold, the circuit moves from closed to open. So this means, like, this transition from closed to open means that something is wrong in the system, and the subsequent calls to that particular microservice won't be done because there is an issue. So what I mean over here is, let's say you have microservices A and microservice B. And if A is making call to B, and let's say if B is down, and if there are like multiple failures which are above the threshold, then all the calls to the microservice B won't happen because the circuit would move to open state. Okay, and that is what circuit breaker is. So now it's moved to open. Now how does it move back to closed, and how are we permitting calls then? So if it's in open, there is a wait duration. So you can see over here after wait duration. So there is this wait duration for which it stays in the open state. And after wait duration is done, the circuit breaker then moves to half open. Now what does half open mean? So in half open state, a certain number of calls are allowed. So a limited number of calls are allowed to pass through the circuit. So what this means is, if I was making call from microservice A to B and the circuit moved to open state, now after certain wait time, it moved to like half open, and in half open state, if my system is configured to permit 3 requests in half open state, so only 3 requests will be permitted to that of microservice B. And because these 3 requests are permitted, system gets a chance to understand if this particular microservice B is back up again. And if it's back again, what happens is the circuit breaker state then moves from half open to closed state. So here you can see failure rate below threshold. So if it's back up again, the failure rate drops to a value below threshold, and then the circuit changes back to closed. So essentially how this works is, if there is a failure in a microservice, there is a circuit breaker that exists which makes sure that the call is not sent to the microservice which has failed. So it controls essentially the failure, and it makes sure that failure is contained to that particular microservice only and not a system as a whole. So that is what circuit breaker is, and this is how the circuit breaker works. So this diagram is really important, and it demonstrates how the states transition depending on what happens in the system. Okay, so this is about circuit breaker. Hey there, welcome back. So let us start talking about how can you integrate Resilience 4J with Spring Boot. So
To do that, I'll head over to our favorite website, which is Spring Initializer, and I'll select Maven here, and I'll click on Add Dependencies, and I'll say Resilience 4J over here. So you can see this dependency come up, and you can hit Explore. So you will see this particular dependency has been added. So this is a dependency to implement circuit breaker into your application, as you can see. So I'll copy this and we will head over to our project. So now in this project, what I'm going to do is I'm going to add this particular configuration that I have copied to pom.xml of jobs. So I'll go to the dependency tab and I'll paste the thing that I have copied. Now here, I'll add one more dependency. So I'll say dependency and I'll say group ID is org.springframework.boot. So I'll select this and here, okay, so it got populated. So Maven plugin got auto populated. So I'll just remove this and I'll say Spring Boot Starter and I'll get AOP. So I'm adding this dependency to add a support for aspect oriented programming. Okay, so I've added this and yeah, everything looks okay. Now I'll hit reload Maven changes and this should resolve all the dependencies and your application should be up. So what we have done is we have configured Resilience 4J to work with job microservice. And in the subsequent lectures, we will start implementing its working. Hey there, welcome back. So let us start configuring the circuit breaker into our application. So what are we going to build actually is we have multiple microservices. So we have job microservice communicate to company microservice and it does so via the controller. So here, if you go over here, so not in controller actually, we should go in the implementation class here. And here you can see we are calling the company service here. Okay. So here, if you go to map company with TTO, we are mapping the company objects and we are calling the company as well as reviews, in fact, using this method call over here. And this is with the help of company client. So job microservice is interacting with company microservice. So we are going to implement a circuit breaker with job and company for this particular communication. All right. Now, what are we going to begin with is we are going to begin starting our microservices. So just make sure your microservices are all up and running. You should also see the status of all the instances over here. Now, let us try accessing the actuator. So I would want you all to go to the job microservice, select pom.xml and make sure that the dependency for actuator is added here. And this is because we will be using it to monitor the health. So if you go to job microservice here, we will go to localhost, we will say 8082 and I'll say actuator. Now here, if you go, you will see the health endpoint that has been enabled. So I'll just open this health endpoint. Now you are not seeing much of the information about health. So we need to enable the detailed health information, which will enable us to get different application metrics. So let us head over to our IntelliJ IDEA project and I'll switch over to application.properties here for job microservice. And I'll scroll down here and I'll add a comment here. I'll say actuator. Okay. And I'm going to add some actuator configuration. So I'm going to say management.health. Sorry, not health. I'll say management.endpoints.web.exposure.include is equal to health.
Okay, and then I'm going to copy the same thing here, and instead of web exposure, I'm going to just say health dot show details, and I'm going to add always over here. So what these two property does is this is exposing the health endpoint in the actuator, and this is adding a lot more details to this particular endpoint. And the reason for this is we want to show much more information about our application health, like how many number of requests are happening, how many are failings, and so on. Okay, so we will be using these metrics to monitor as to what is happening with our microservice. Okay, and we will be understanding whether circuit breaker is actually working. Okay, so I'll head over here. So without those configurations, we had only up. Okay, we have not restarted the microservice. So what I need to do is I need to select job, and I need to say rerun over here. So okay, so the microservice is restarting. So we'll wait until it restarts, and we'll check the status here in Eureka. So the job service is up and running. Now let us head over to actuator/health and let us see if detailed information has come up. So I'll hit refresh. Okay, so we are not getting the detailed information. It still says status up. Let us see what mistake we are making here. Okay, so I should remove S from here. So it is management.endpoint.health.show-details. So this was a mistake. There was a S over here, which I removed, and I'll rerun this application. So just make sure if you're adding this, you don't have any typos. Okay, because if you have any typos, it won't work as expected. So just be sure of that. Now I'll head over to my browser and let us hit refresh. Okay, so the refresh is done, and you can see the detailed information about your application now. All right. Now what we need to do is we have the actuator health endpoint enabled, and this health endpoint will enable us to see the circuit breaker details as well. All right. And that is the reason why we have enabled this. So now we need to start configuring our circuit breaker. So in order to configure the circuit breaker, what I'm going to do is I'm going to add few configurations into my application.properties. And I actually have these configurations added here in this notepad, which I'm just going to copy. So I'll copy all of this for Resilience 4J. Okay, and I'll get it pasted over here. All right. And I'm also going to copy this part. Okay, so this is the actuator configuration. So these 2 points we have already added. Okay, and this is the third one, and we'll go through what each thing means. But for now, I'll just copy this in the end. Okay, and I'm going to go to right here, and I'll say here. Now I'll remove these two which we had added previously. All right. Now let us understand what this means. Okay, so there is a meaning in everything, and every property means something on the other. So here what we are doing is we are specifying some configuration to create a circuit breaker. So this property says register health indicator. All right, but first of all, we are creating a circuit breaker with the name company breaker here. Okay, this is the name. So when we say company breaker dot register health indicator is equal to true, so this property registers a health indicator for company breaker circuit breaker. Okay, so company breaker is the circuit breaker instance that we are creating here. So you can see circuit breaker dot instances dot company breaker. So this is the instance that is being created, and it is being registered in the health indicator. And this can be accessed via the health endpoint, which we have enabled over here. All right. So this is the reason why we enabled health endpoint. Now the next property says sliding window size. So sliding window size defines the number of calls stored in the sliding window of the circuit breaker. And this is used generally to calculate the percentage or failure rate. All right. So we have kept it to 10.
Then we have minimum number of calls. So we are saying minimum number of calls as 5, and this defines the number of calls that can be recorded before the circuit breaker can calculate the failure rate. Okay, so to calculate a failure rate, we need some calls, right? We cannot calculate failure rate on 0 calls. So that is what this number defines. So we can customize this as per our requirement. So this is one. Then we have permitted number of calls in half open state, and we have set that to 3. So the circuit breaker can go in open, closed and half open state. Now half open state is a state where you can permit some number of calls before circuit breaker can decide to transition back to open or closed state. Alright. So half open is a state in between, and essentially you are configuring the number of calls that can be permitted in that particular state. So we have mentioned 3 over here. You can customize this as per your requirements, but for learning purpose, we have set it to 3. Then we have wait duration in open state. So this property determines or controls how long the circuit breaker should stay in open state. Okay. So in open state, the calls that are being sent to the microservice are rejected. Okay. And we have specified this to 10 seconds. Then we have failure rate threshold. So this defines the threshold when exceeded, the circuit breaker will transition to open. Okay. So here we are saying 50, which tells that if the failure rate is more than 50%, the circuit breaker will transition to the open state. All right. Then we have register health indicator is equal to true. So this property is similar to the first property that we have set. Okay, so it will register the health indicator into the actuator or the health endpoint. Then we have automatic sliding transition from open to half open enabled. So this property enables circuit breaker to automatically transition from open to half open state. Okay, and then we have the sliding window type. Okay, so this determines the type of sliding window, and we are saying that we want count based, which means that the last n calls are recorded and they are used to calculate the failure rate, where n is the size of the sliding window. Okay, so this is just the window type that we have determined. So these are some properties that we have added, and you can also add this one more property here, which we have added to the actuator configuration, which says circuit breakers enabled true in health. Now what this means is this will enable the health check for circuit breakers in the actuator. All right. So these are the configurations. Now if you head over to browser and if you go to the Resilience 4J documentation, if you click on circuit breaker here on the right hand side, you're going to see create and configure the circuit breaker. And if you click on this, you will see this table here, and this is all the table that has all the configuration that you can define. So you can see over here failure rate threshold. It has the default value as well and the description as to what this does. So if you want to customize anything, you can customize over here. So you can see here sliding window type is count based. You can even set it as time based. Okay, and you have different number of properties. So you can go through this if you wish to. So this is for additional exploration. But now what we have done is we have configured the application.properties. Now let us create the circuit breaker. So what I'm going to do is I'm going to head over to the controller here. Not controller. So we will need to implement this in the service implementation class. So what we are going to do is we are going to go to get all jobs. So this is the method which helps us get all the jobs from the database. All right. And this is the one that maps it to DTOs. So what I'm going to do is I'm going to add an annotation over here to this method, and I'm going to say circuit breaker here. Okay. And here I'm going to say name, and the name will be company breaker, like so. So this is the same name that we have added in the applications.properties. Okay, so not this one.
but this one, which is for jobs. So this is the name that we are adding over here. Okay. So yeah. So what we are saying is circuit breaker is to be enabled on this particular method here. And this is a method that enables us to get the list of all the jobs. Okay. And if you scroll up here, you can see from where this annotation is coming in. So this is coming in from resilience4j circuit breaker.annotation. And this we are getting because we have added the dependency. So this is about the configuration and creation of circuit breaker in our job application. Welcome back. So let us see the changes we have done in action. So we have added a circuit breaker into our application for getting all jobs method here. And we have also done a lot of configuration in our application.properties. So if you have not restarted your application, I would request you to go to Services tab and rerun your job application so that you can get these changes to effect. Now let us go to our browser and let us see all these changes. So here in browser, I will access the actuator/health and I will hit refresh over here. Now the moment you hit refresh, you are going to see under components, you're going to see this tag here, which says circuit breakers. You'll see status up and you'll see company breaker, which we have just created in our application. Along with this, you are going to see some details of this. So here you have different properties like failure rate. Now what is failure rate? Failure rate is the percentage of recent calls that have failed. And if you have this negative value like -1 or something like I am seeing, this indicates that there have not been enough calls yet to calculate a meaningful value. And this is because we have just restarted the service. Then we have failure rate threshold. So this is the percentage of failures at which circuit breaker will switch from closed to open state. And in this case, if the value is more than 50%, it will fail or it will open. Then you have slow call rate, which says the percentage of recent calls that were slower than the configured threshold. Now again, negative means there has not been enough data to calculate yet. Slow call rate threshold. So this is 100%. And this is the percentage of slow calls at which circuit breaker will switch from closed to open. Then we have buffered calls, and this dictates the total number of calls that the circuit breaker has recorded in its ring buffer. And this includes the total number of calls like the successful as well as failed. Then you have slow calls, which keeps a track of slow calls that have happened. Failed calls. So these are slow failed calls. So these are calls that have been slow as well as they have failed. So slow as in they have been slower than the configured threshold. Then we have failed calls and not permitted calls. So failed calls are the total number of calls that have failed. And then we have not permitted calls. So if the circuit breaker is open, then the calls won't go through, right? Because circuit breaker will reject. So this is that number. So total number of calls that have not been permitted. And then finally, you have the state of the circuit breaker. So this can be closed, open, or half open, depending on the time you are accessing it. So this is our circuit breaker details that we have, and we will be using the actuator health endpoint to monitor this. Now we have all our services up and running here. So if you head over to Postman, and if I go to job microservice, so we have to go to 8082 port and let us try getting all the jobs. So if I send this request, I get an empty call. So let me create a few jobs. And before that, I'll create a company. I'll create a review here against that company so that we have some data to work with. And then I'll create a job as well. Now, if I try to fetch jobs, I'll see like the details of the job along with company and review. Now, if I come back here and if I access health endpoint, you will see there have been 2 calls that have happened. Okay. And you can see there are 0 calls that have not been permitted. And that is because the state of the circuit is closed. All right. Now let us make our company service go down. Okay. So the circuit breaker is between the job microservice and the company microservice. So if the company microservice goes down and if our failure rate happens to be higher than that of threshold, the state should change to open. So let us try that. So I'll head over here to IntelliJ and I'll turn down the company microservice. Okay. So the microservice is down and it's removed from Eureka registry. Okay. Now let me do a API call. So I did one call. So of course this is failing. And if I refresh our endpoint, you will see buffered calls 3 and failed calls 1. Okay. Now let us send this request again for some time. Okay. So I have done like 5-6 calls now. And if I refresh, you will see failure rate is 60, state is open, and failure rate threshold is 50%, which we had set. Okay. So circuit state is open. Now if I refresh, it goes to half open state after 10 seconds because that is what we have configured in our application. Okay. So this is now half open, and let me do a call now. So if I do a call, it won't go through. If I do one more, it won't go through. Let us also check the logs here. Okay. So if I refresh this, it's still in half open. And if I check logs here, so job microservice. So here for job microservice, if you scroll up here, you will see an exception here. So here in the logs of job microservice, you can search for call not permitted exception. Okay, so if you can say Control F if you're on Windows and Command F if you're on Mac, and you can enter this call not. So if you just enter call not, you will find this call not permitted exception. So what happens is whenever the call is not going through or the circuit is open, then you get this exception over here because call is not permitted because the circuit is open, and you can see the reason also over here. Okay. Now what we will do is we will turn back our company microservice up again. So let's say company microservice was down for a while. There were some issues with the microservice and developers worked hard to fix this and bring this service up. Now you will see if I refresh, this is still half open, which means there will be certain number of calls that will go through the circuit. So if I send this request again, it gives me error. If I send this again, okay, it will give me error because there is no company there now. So I'll create a company and I'll try getting the response. So I'll say get, and this works now. So if I come back here and if I refresh, you will see failed calls have become 0 now, like in recent duration. Buffered calls 1 and state is still half open. So this will go to close state after some time, after we have some X number of successful calls. So I did one successful call. I'll make a couple of them and I'll come back and I'll hit refresh over here. So you will see there have been now certain number of successful calls, and that is the reason the state is now changed to close, because the circuit breaker now assumes that the service is back up since the calls have been successful, and that is why it's allowing now all the calls. So this is how the entire process of circuit breaker works. Okay, so you can see how different parameters were working when a particular service was down, and how our configuration also gave us a better control to configure different options here. So you have multiple options here. You can change anything. Like you can even change the wait duration if you want wait duration to be higher or lower. Okay, you can have minimum number of calls configured and so on. So you can play around with these settings a bit, and depending on the use case, you can get this applied
to your production applications. So this is about circuit breaker in action. All right. I hope you all enjoyed this class and found it valuable. I shall see you all soon. Thank you. Welcome back. So let us start talking about the fallback mechanism. So here, whenever a microservice is down, like when our company microservice was down, and if we tried sending a request, we got an error over here. Okay, and circuit was set to open. But it's not a good thing to show an error to the user. So let me simulate this scenario again for you. So I'll stop the company microservice and I'll try sending in this request. So you can see we are getting an internal server error for jobs. Okay. And here the circuit will be open. All right. So this over here is not a good thing. So you're showing errors to your users. So you can easily prevent this or control this by using something called as a fallback mechanism. Now, what is a fallback mechanism? So fallback mechanism is an alternate path that you have to show to the user whenever there is a failure of an microservice. And you can implement this with the help of circuit breaker. So let us head over to IntelliJ and let us implement the same for this scenario here. So here in IntelliJ, I'm going to head over to circuit breaker over here. Now here we have passed one parameter, which is name. I can pass one more and I can call that parameter as fallback method. Now here I can define a fallback method. So I can say company breaker fallback. So I can have this definition created over here. Now what I can do is I will have to define this particular method. Okay, so I'll copy this method name. I'll go over here and here I'm going to say public. And let's say I just want to return a simple list of string values and the method name is this. Okay. Now I'll have, let's say I'll have some code defined over here. So I'm just returning the list of a simple string as a fallback over here. So I'll say list string and here I'll say L list is equal to new array list. And now I'm going to say L dot add. I'll add just some dummy information. So I'll call it dummy and I'll return L or I'll return list. So this is the implementation here. All right. Now this will also have a parameter exception E, okay, which we have added. So this is the fallback method that we have created. Now one thing to keep in mind is to keep this names similar. Okay, so just make sure that this name that you have specified here in with the annotation as the parameter matches the name of the actual method. All right, this is where a lot of people go wrong and then it does not work. So I'll restart my job microservice and let us see what the output looks like. So our job microservice is up and running. State is closed. Now let me hit the URL over here. So just for your information, the company microservice is still down. So I'll say send. So we don't have any jobs. So we need to create a job in order for a request to go to the company ID. So I'll say send. And now here, since the company microservice is down, we are saying dummy over here. Okay. And this is a message that we have given in the list. So this is the list that we are getting over here. Okay. So here we are clearly not getting any error. And if you send this like 4 or 5 times, and if you head over to this particular endpoint, you will see failed calls 4, not permitted calls 2, and the state is open. So not permitted calls is 2 because 2 calls were not permitted because the circuit state changed to open after repeated failures. But the best part is this over here, you're not seeing any errors. So if there is a failure and if you want to handle failure gracefully in front of the users, you can have some dummy response created, or you can have some alternative database or something from where you fetch in some information and give it to the user so that at least the request loop is closed and user does not see any error messages. All right. So this is the benefit of adding fallback. And if you go back to IntelliJ, you will also see we are not getting any errors here. Okay. So this is about the fallback method and how you can get this implemented into your microservices along with circuit breaking. Welcome back. So let us implement the retry mechanism with the help of Resilience4j. So we have already seen how circuit breaking works, and Resilience4j also provides one more way or one more technique called retry with the help of its retry module. So we will be implementing that, and retries are simple yet effective way to add resiliency into our system. So what is retry? If any network call fails, we will be retrying that network call to see if we can succeed. And we can do all the configuration as to how many times we want to retry and what should be the duration and so on. So to begin with, what I'm going to do is I'm going to just comment this out here. Okay, so I'll select this and I'll comment this out. Now I'm going to add a new annotation over here and I'm going to say retry here like so. And if you scroll up here, you will see this is also coming in from Resilience4j library that we have configured. Now we need to add the details. So here I can say name is equal to, so I'll say company breaker. So we'll add these similar details here. Okay. I'll just paste it over here. Okay. And this should work. So let me remove this comment from here. So yeah, retry is configured for this particular method here. Now I want to demonstrate how retry works. So what I'm going to do is I'm going to create a temporary variable over here. I'll say integer attempt and I'll initialize this to 0. Now I'm keeping this variable over here, or I'm creating this variable to keep a track of all the retries that are happening. All right. So what I'm going to do is I'm going to say over here system.out.println and I'm going to say attempt and I'm going to say attempt. Okay. And I'm going to increase the value of attempt. So for every method call here we do, the attempt value will increase and it will print the same onto the system. So we have implemented the retry functionality. Now let us head over to our application.properties and let us do some configuration over here. All right. So here I'm going to say, so since this is the configuration for Resilience4j, I'm going to come here and I'm going to copy this entire thing. Okay. And I'm going to say instances.companybreaker.max attempts. All right. And I'll delete all of this. And I'll remove all of this, the rest of the part. And I'll say max attempts can be 5. So here I'm configuring the maximum number of attempts that we will be doing if the network calls fails. So I'm mentioning this to 5. Now I'll copy this and I'll paste it over here. And I'll add one more thing over here, which is the wait duration. So I'll say wait duration like so. And I can say wait duration as 2 seconds. So wait duration specifies the duration for which we will wait before making the next call. And max attempt is the number of attempts that we will do. So now I'll restart this service here. Okay. Now let me restart the job microservice. So after starting the job microservice, just check whether the service is up in Eureka. Also, I have the company server down. Now what I'm going to do is I'm going to head over to Postman. I'll create a job and I'll do a request to fetch the job. Okay, so something happened here. The request is not loading. So I'll just close everything and I'll just select this. Now I'll try getting the job. So when we trigger the request now, we got a dummy response. All right. Now let us head over to IntelliJ and see what the output looks like. So here in IntelliJ, I'm checking the logs for job application. And now here, if I say attempts, so you can see attempt 1, attempt 2. So you can see attempts happening for the request over here. And the application is trying to fetch the data from the company microservice. All right. So retry module is indeed working now. And we are seeing our changes based on this particular configuration. All right. So this is about the retry module and how you can get this implemented into your project. Hey there, welcome back. So let us start talking about rate limiting. What is it and why is it needed in modern web applications? So what is rate limiting? So rate limiting is a technique for limiting any network's traffic. So it sets a limit on how many requests a client can make to a server in a specified amount of time. So in other words, it's a way of controlling the rate at which an application or a system uses resources. Okay. So this is what rate limiting is. Now, if I have to give you an example would be an API might have a limit of 1000 requests per hour. And if you exceed this rate, the server would return a response, which is like something like 429. And this response with status code of 429 stands for too many requests. So a website might have a rate limit for account creation to prevent some spam accounts being created. And you can only create one account every 10 minutes from a single IP address. So if this rate is being exceeded, it's likely that there are fake accounts or some spam accounts being created. So these are some of the examples as to where rate limiting can be used. Now, what is the importance of rate limiting? So rate limiting can be crucial for several reasons. So the number one reason could be preventing abuse. So without rate limiting, a malicious user can overload a server with requests, causing it to slow down or crash. So this is one of the reasons as to why rate limiting is important. Resource allocation. So by limiting the number of requests, you can ensure that resources are distributed fairly amongst all users. Cost management. So if your server or API is hosted in cloud and you pay for the amount of traffic it handles, rate limiting can help you keep costs under control. These are few points as to why rate limiting would be important in today's applications. Now, what are the use cases of rate limiting? So the number one use case is of APIs. So in API world, to prevent a single user from making too many requests, APIs often use rate limiting. So this protects the server from unwanted load and ensures fair usage. Web scraping. So there is a possibility that people might be doing web scraping onto your website. So sites might use rate limiting to prevent web scrapers from overloading their servers. Login attempts. So to prevent brute force attack, websites often limit the number of login attempts from a single IP address. So you must have seen this message that maximum number of login attempts exceeded and retry after like 5 minutes. So that is rate limiting in action. So if there are maximum number of failed login attempts from a single IP, then a website might block requests from that IP for a certain period of time. And this is to secure the website and your account. So these are some of the use cases of rate limiting. Now, there have been some real world incidents of DOS. So what I mean by DOS is denial of service. And DDoS stands for distributed denial of service attacks. So distributed denial of service attacks are where multiple systems flood the bandwidth of a particular system and they try to take it down. Okay, so you will have one server that you are targeting and you will target that one server from multiple places. So there is no single IP from where the request is coming. It is coming from multiple servers. And one of the most notorious attacks that has been of this type has been with GitHub in 2018. So they have even written a blog post on this. So here in browser, if you search for like GitHub DDoS, so you will land on this link here, and you can see this happened on February 28th, and they have acknowledged that this is something that happened, okay, due to distributed denial of service attack. And they have also given as to what happened exactly and why this incident occurred. So you can see the server load went suddenly up. You can see over here, and they have posted everything. So yeah, so this is about a real world example, okay, and GitHub was hit with a massive attack, and this attack took GitHub down for some time. All right, so GitHub was not working, so they have mentioned it over here. GitHub was unavailable for this much of time. Okay, so this is about the real world incidents of denial of service attacks. So now the question is, how can we build resilience into our applications to prevent these kind of things? So you can do this with rate limiting feature of Resilience4j. So Resilience4j is a lightweight library, and you can use the rate limiter module as to control to how many times a method or a client can call your service in a given period of time. And this is really useful in microservices architecture, where you need to control the number of calls to prevent your service from being overwhelmed. So this is about rate limiting, and I hope you have a fair understanding of this concept now. Welcome back. So let us start implementing the rate limiter module. So since we have Resilience4j configured into our project, Resilience4j has a module called rate limiter, as you can see over here on the left hand side. So you can click on this and you can read more about rate limiter and how rate limiter works. Now if you scroll down here, you will see this table here under create and configure rate limiter. So this table gives you the configuration that you can add in your application.properties or within your application to get rate limiter configured. So you can see timeout duration, and the default value is 5 seconds. And this is a default wait time a thread waits for a permission. You have limit refresh and then limit for period. So this is the 50. So limit for period means the number of permissions or number of calls that are allowed during one limit refresh period. So there are 50 calls that are allowed for now. Okay. So let us head over to our application and let us start configuring this. So here in IntelliJ, I'm going to paste some values here, okay, for rate limiter, which I have already written. So these are the values. So I'm saying Resilience4j dot rate limiter, and I'm saying instances, company breaker, timeout duration, I'm specifying as 0. Okay. So this is the default wait time a thread will wait to acquire permission to run when the limit is reached. So I'm setting it to 0. Then I have limit refresh period. So limit refresh period is the period after which the limit is refreshed, and you have the limit for period set to 2. So what this means is the rate limiter will allow 2 calls every 4 seconds for us. Now if more calls are made within that period, they will be immediately rejected without waiting. Now why without waiting? Because the timeout duration we have specified is set to 0. So if we specify the timeout 0 to 5 seconds or 2 seconds, it means that the more calls, if they are made within this period, they won't be immediately rejected, but they will be made to wait for that particular duration. All right. So this is our configuration. And what I will do over here is I'll now head over to services, and I'll now restart my job application. So our application is started now. Now we'll head over to our browser, and now we need to simulate this scenario. So we need to have a way to simulate these many requests to our server. And for that, we are going to make use of a tool called JMeter. I'm just going to search for JMeter. Okay. So JMeter is nothing but a load testing tool for analyzing and measuring the performance of variety of services. So with the help of JMeter, you can simulate a lot of requests on your application or on any endpoints. So you can go to Apache JMeter and you can say download, and you can download the zip file from here. So I have downloaded the Apache JMeter here. And now what I can do is I can head over to the unzipped version. So after downloading the zip, you can unzip it. And here in bin folder, you will see this file apache jmeter.jar, which you need to launch. So it will take some time to launch for the first time, but then it will open a window like this. Okay. So here now we can right click on this test plan on the left hand side, and we can say add a thread group. Okay. Now we can specify a number of 5 over here in the number of threads, and we will save this. So I'll just minimize this. So thread group is created. Now I'll say right click on thread group and I'll say sampler HTTP request. Okay. Now here is where we will be simulating this request. So what I'm going to do is I'm going to head over here and I'm going to copy 8082. So here I'm going to enter the details. So I'm going to say HTTP. Server name is localhost. Port number is 8082. And then we will have to enter the path. So I'm going to go to Postman and I'm going to copy /jobs here. And I'll say jobs here. And I'll make sure that the request type is GET here. Okay. So this is done. Now I'll say add. Now once you have created this, you will see this start button over here at the top. So just click on this green button and it will say you should save this particular thing. So just save this by clicking on yes. So you can save it with any name. Now after you have saved, you can click on this request. You can say add and you can go to listener. Now here you can see view results tree. So now here we can run this and we'll see all the results. So you can see all the requests are being sent right now. Okay. And nothing seems to be failing. So all the requests worked properly and none of the requests were blocked. So here you're seeing green requests, meaning all worked properly. So we are missing something. So we'll head over to our source code and here we have configured properties. But if you go to the service implementation, we also need to add an annotation over here. So what I will do is I'll disable this annotation and I'll say @rate limiter. So this is something that we missed. Okay. And I'm going to copy this same information here. Okay. So we have rate limiter named company breaker, and that is what the name that we have specified over here, company breaker. And I have added a fallback method as well. Now let us redeploy our application. So what I'm going to do is I'm going to rerun the job application. So the application is running successfully. Now if we can head over to the Apache JMeter and I can right click on this view results tree and say clear. So this will clear everything and then I can run this again. So now if I run, I'm still not getting the desired result. So if I change the number of threads to 10 and if I run this. Okay, so if you select the request here, okay, you will see sampler result over here. And if you select the request tab, you will see the request that is being sent. And here you will see the response that is being sent. That is being received, I'm sorry. So you can select 2 of the requests and you will see this response. But if you select the third, you will see dummy over here. Okay. Which means that after second request, the request is not being entertained and the fallback method is being shown. All right. Now if I remove the fallback, so if I go over here and if I go to implementation here and if I remove the fallback, let's say, for example, okay. And if I save this and I'll restart the service. So let us see what happens if you remove the fallback. So in this particular case, the request was working. It was not showing it over here. So everything was green, but it was shown in the response data. All right. So I believe the service is up and running. So we'll create a company and we'll create a job and let us see if it's working. So it's working fine. Now we'll go to rate limiter and I'll clear the results and I'll run the rate limiter again. Okay. So now this time let us see what happens. So again, you're getting dummy despite removing the fallback. So here, what you can do is you can select any request here. You'll see the sampler results. You can go to request and then response data. So here you will see the response that you're getting from the request. So you can select 1, 2, and if you select third one, you will get dummy as the response, which means this is not working and it is being returned. All right. So this is rate limiter in action. Hey there, welcome to this class. So let us start talking about this concept of message queues. So what are message queues and why are they needed? So let us talk about the need and let us understand a scenario wherein message queues would be important. So let us say we have this two service. One is the job service and then we have a review service. Now these two services are communicating by exchanging a message, right? So they have a request that is being sent from a job service to review service and the request has some message that is being consumed by the review service. Now let's say if a review service is down, then in that case, job service won't be able to communicate with review service and it will start getting the error. Now here, for job service to talk to review service has to be up. So the communication between the two is synchronous. Okay. So because of this synchronous communication, there is a dependency that is being added into the architecture. Now, how do you decouple these services and how do you decouple this communication? So the answer is by implementing something that allows you to do asynchronous communication. And how is that possible? So that is possible by adding a message queue like this. So message queues play a crucial role in microservices architecture to facilitate communication and data exchange between different microservices. So you can see in the diagram over here, we have job service that wishes to communicate to the review service and we have a message queue here in between. So a message from the job service will be left into the message queue and then review service will consume this particular message. So that is how this entire process works. Now, if review service is down, that is completely fine because if the message is sent by job service, that message will be stored in the message queue for a while. And then when review service is ready, it can consume the message once it is ready to consume. Until then, the message will be there in the message queue. So that is what message queue is. Now, why is there a need of message queues? So the number one reason is decoupling. So message queues enable decoupling between microservices, meaning that each service can now operate independently without needing to know the specific details of other services. And services can communicate through messages sent via the message queue, making them more independent and loosely coupled. The next need would be to facilitate asynchronous communication. So like I said, message queues support asynchronous communication patterns where services can send messages and continue processing without waiting for an immediate response. So in our case, if job service does not need an immediate response and if it just wants to send some data to review service, it can just send the data in the message queue and just forget it. So it does not have to wait for an immediate response or an acknowledgement. And this is especially important in scenarios where certain operations might take some time and are not that critical for immediate response. Scalability. As microservices can be deployed and scaled independently, message queues will help manage the communication between the services without overwhelming them with direct requests. So you can think of them as a buffer, allowing services to process messages at their own pace and scale independently. Fault tolerance. So message queues provide an additional layer of fault tolerance. So if a microservice is temporarily down or unreachable, the messages are stored in the queue, ensuring that they will be processed once the service is back up. Then the next need could be event-driven architecture. So with the help of message queues, you can enable event-driven architecture into your microservices. Now this is a way where services can publish events to the queue and other services can subscribe to these events and react accordingly. And this makes it easier to implement event-driven patterns and respond to changes in the system. Time decoupling. So message queues allow services to process data at their own pace, and this is particularly useful when dealing with peak loads or when services have varying processing speed. So in such scenarios, there is time decoupling and microservices don't have to wait since the other microservice is taking some time. Now let us define message queues. So what is a message queue? So a message queue is a form of asynchronous service-to-service communication that is used in serverless and microservices architecture. Now messages are stored on the queue until they are processed and deleted. And each message is processed only once by a single consumer. Now when it comes to message queues, there are a couple of terms that you should be aware of. So here in this diagram, I have job service, which is sending a message to this particular message queue, to which both the services are subscribed. So job service is subscribed to this message queue, and then review service is subscribed also to this message queue. And job service publishes a message and review service consumes the message. So in this case, job service is known as a producer and review service is known as a consumer. So what is a producer then? So producer is a service that creates messages and adds them to the queue. So they are just responsible for producing or publishing the data. So anyone who produces anything into the message queue is known as a producer. So this is one of the terms that you are supposed to be aware of. And likewise, what is consumer? So services that process these messages or consume them are known as consumers, and they read or consume the data and usually delete the message from the queue once the processing is done, because that message need not stay there in the queue. Now, when it comes to message queues, there are quite a few message queues that are available in the market which you can use for your next project. So I'll discuss a few of them. So the number one and the most popular out there is RABBITMQ. So here I'm on the official website of RABBITMQ, and RABBITMQ is widely used open source message broker software. Now, what is a message broker? So message broker is nothing but a piece of software that enables asynchronous communications. So RABBITMQ supports wide array or broad array of developer platforms and languages, making it quite versatile, and it's a good choice for complex applications that require high reliability and flexibility in message routing. So you can go through the features that RABBITMQ has. Okay, you can see there are quite a few features, and you can just browse through the website if you wish to know more about RABBITMQ. Then you have Apache Kafka. So Apache Kafka is another one, okay, which is quite popularly used, and you can just browse through the website to learn more about Kafka. And you can see this is the website. Then you have Amazon SQS. So this is a queuing service that is managed by Amazon. Okay, so you don't have to install it, but this is in the cloud and you can use it. So this provides serverless options for applications. Okay, and you can go through its feature. So you can check out this website, and if you just Google Amazon SQS, you will land on this page. Then you also have ActiveMQ, which is also like a popular
Java-based message broker. So there are quite a few in the market. Now the question is, how do you choose which one to use? So there are various factors that influence this decision of choosing the message broker of your choice. The number one is scalability. So if you need to handle large amount of messages per second, you can consider using some service that is in cloud like SQS, or Google has a queuing service as well. So you can consider using that. The next point would be reliability. And if your use case requires highly reliable delivery, then you can consider using RABBITMQ or Apache ActiveMQ. Now both of them have strong message durability and delivery guarantees. Okay. Then the next factor that you can use for considering and evaluating is simplicity. So if you need something that is really straightforward, easy to use solution, then you can go for cloud-based services like Amazon, SQS, and so on. So they have simple interfaces and managed infrastructure. You don't have to take care of or manage them essentially. So the Amazon will manage it for you. Then the next factor would be cost. So RABBITMQ, like I said, is open source. Okay, and you can run on your own server for free, while cloud-based services like Amazon SQS are usage-based costs. So if cost is a constraint, you can choose something that is open source for your project. So every message queue software has its strengths and trade-off, and the best choice depends on your specific needs and what kind of application you are building and whether you are willing to spend. And if you're not willing to spend, then are you willing to manage everything? So that's the choice that you need to make. So that is about message queues. I hope you found this valuable, and I shall see you all soon. Thank you. Hey there, welcome back. So let us talk about a scenario wherein we can understand more about message queues. So we have already created job, review, and company microservice. So what are we doing is, now we are creating a job using the job endpoint. But while fetching, we are fetching the job, company, as well as the review. So what if we want to create the company and review as well from the jobs post request? So that is completely possible. What you need to do is you need to add some extra parameter and some extra JSON over here that will represent the company and review, and the job controller or job service will do the job of routing the objects to the respective microservices. And then once the communication is done, the company and the review are both created. Okay, so this is completely possible and you can implement this. But if you are implementing this without message queues, so the issue is if company or review are down or they are slow, then job will have to wait for a response, right? So if we create a job over here, we are getting 201 created. So if company and review are part of this request, then this request is not complete unless and until company and review have been created as well. So in that case, jobs API or job microservice will wait for an update whether the request has been successful or not from the company and reviews microservices. But if they both are slow, then this will also go slow, and this will probably end up waiting for a long time and possibly timeout. So in that particular scenario, so what you can do is you can have a message queue that can save the message here until the company service is back in action, and then it can consume the message from here. So that is completely possible, and you can implement this with the help of message queues. Now the question here is, why aren't we using fallback methods? So we have a way using which you can implement fallback methods, and if there is any issue with the microservice, then fallback methods can come into action. So why do we need message queues then? Fallback methods can act as a replacement of message queues, right? No. So fallback method is a different concept, and it can work together with message queue, but it's not a replacement there. So fallback methods provide a alternative path for execution if something has happened to the service. Okay. But with message queues facilitate asynchronous processing. So if there is some issue with the service, the message stays there and it can be consumed by the service once it's up. So it can solve the problems like service is down or service is slow. So client does not need to wait until and unless it gets the response. It can just publish the message to the queue and forget it. This is one benefit of message queue. Then we have things like decoupling and reliable message delivery. So fallback methods are different when we compare them with message queues. They are not the same. So this is one of the frequent questions that students ask me, that we can use fallback methods instead. But to clarify, they are not the same. So that's about the importance of message queues and fallback methods. Hey there, welcome back. So let us start talking about what are we going to build with the help of message queues. So we have a review service and we have a company service. Company stores the company related information, and then we have review related information being stored in the review service. Now reviews are managed by review service, and these reviews belong to companies. But what happens if a new review is added? So a new review is being stored in the reviews database itself, but there is no review information that is associated with company yet. So what I mean by this is, within company, we are not storing the aggregate review information, like aggregate rating information is what I mean. So for example, I would want to know whether a company is rated 4-star, 5-star, 7-star or whatever. So the average rating of the company should be stored in the company service is what I want. And the detailed information like what review was posted, when it was posted, by whom it was posted, all of that can remain in the review service. Now this is something that I'm willing to build. So for this, what I need to do is I need to have a field in the company service wherein I'll store the overall rating of the company. Okay, and this needs to be updated whenever a new review is posted. Okay, so now how do I do this communication? So this communication can go from review service to that of company service. Okay, and rating information can be passed in that. All right, and based on that, company service will update the review of the respective company. But the thing is, this is synchronous communication. Now, synchronous communication, like we said, it's not the best. Okay, there is a possibility like company service is busy, or it's down, or it's too slow to respond. Then in that case, there is a possibility that the rating information might get lost. So what are we going to do is, we are going to have a message queue in between, and these two services will communicate with each other with the help of message queues. So review service will be the producer, and it will produce the rating information and it will publish it to the message queue. So whenever a new review is posted by any user, the review information goes into the message queue. So company service will fetch the review from the message queue, and it will verify the company ID, and it will update the average rating of the company against whom the review was posted. And this way, company service will maintain the average rating of different companies, whereas the details of the review will be there in the review service. So company service will be our consumers in this particular scenario. So this is what we are going to implement. So I hope the problem statement is clear as to what we are building and why we are building. So without a further ado, let's get started. Hey there, welcome back. So let us start with the setup for RABBITMQ. So here I am on the official website of RABBITMQ, which is rabbitmq.com. And you can click on Get Started over here. And here you can click on Download plus Installations. So here on the left hand side, you can see different ways of installing and setting up RABBITMQ. You can also see this Docker command, okay, from where you can set up the RABBITMQ. So we will be using Docker, of course, for getting RabbitMQ up and running onto our system. So we won't be installing anything onto our machine, but since we have Docker up and running, let's use Docker. So here I have some Docker commands ready. So with Docker, there are two ways. One is you run this command and get RabbitMQ up and running onto your system, or you can add this to your Docker Compose file. Okay, so let me explain both the ways. So here you are saying Docker run -d, which is you are running this in the detached mode. You are giving this container a name, which is RabbitMQ. And this is the image that you're specifying. So RabbitMQ :3-management. So this is the image that will get downloaded. Now here you have specified, or you are mapping ports twice. So this is the first port that you are mapping, and you are mapping the container port to that of the host. So 5672 and 15672, these are the two ports. Now what is 5672? So 5672 is the default port for RabbitMQ, whereas 15672 is the default port for RabbitMQ management. So RabbitMQ management is an interface that you can access through the browser to interact and work with RabbitMQ. So that is what this command does. You can happily use this command as well. Alternatively, you can copy paste this into your Docker Compose file. So I'll choose the Docker Compose way. So I'll copy this and I'll go to dockercompose.yaml, and here I'll say enter, and here I'll press paste. Okay. So what we are doing here is we are getting this image. This is the container name. These are the ports. So I'm mapping 5672 of the container to that of host, and 15672 of container is being mapped to that of host. And I'm making sure that I'm creating or adding RabbitMQ to this network here. So this is the Docker Compose version of this command here that we were supposed to run on command line. So we are done adding this into Docker Compose. Now what we can do is we can switch over to our console or terminal. So you can switch to any inbuilt terminal of your operating system. Okay, make sure you have Docker up and running, and you need to navigate to the folder where the Docker Compose file is created. And there you need to say Docker Compose up-d, and I'll press enter. So you will see the processing happening for RabbitMQ. So RabbitMQ does not exist yet on my system, and it is being downloaded for the first time. And you can see the download progress that is happening. Okay, so you can see it's happening and this container is started. And these two containers, or these three containers like ZIPKIN, pgadmin and Postgres container, were already up and running. Okay, so this is running now. Now what we need to do is we can access the RabbitMQ management interface from our browser. So let's switch over to our browser. So here in the browser, I'm going to say localhost :15672. Okay, so this is the link that I'm going to go to. Now when you access this URL, you are going to be presented with this login page and you will be asked to log in. So the default login credentials are guest and guest. So you can enter that. So we have now logged into management console, and this console gives you a bird eye view of RabbitMQ environment. You have overview tab, which gives you the general information about RabbitMQ server, including the messages, connections, channels, exchanges, consumers, and so on. So you can take a look at a lot of different stuffs here. Then you have the connections tab that will display all the active connections to your RabbitMQ instance. Okay, so if you click on all connections here, you will see all the connections coming up over here. The channels tab will show you all the active channels. Now, what is a channel? So when publishing or consuming message from a queue, that process is entirely done over a channel. Okay, so that is what you are going to see over here. Then you have something called as exchanges, and this particular tab displays the list of all the exchanges onto the RabbitMQ server. Okay, and you can see the different types of exchanges like direct, fan out, headers, match, and so on. Now exchanges are message routing agents. Okay, and exchange is responsible for routing the messages to different queues. Okay, so it will accept the message from the producer and it will route them to the appropriate queue. All right, and you are seeing like different exchange types over here. Then you have queues over here. So queues in RabbitMQ are buffers that will store the messages. So a message will be stored in a message queue, and each message is processed by consumer who will then consume the message. So that information you are going to see over here. So this is about RabbitMQ and how you can log into RabbitMQ console and you can view different information over here. Now also you will see this message here, Erlang and some version. So this you are seeing because RabbitMQ is written in Erlang programming language. Okay, so this is just for your information. So yeah, that's about RabbitMQ and how you can access the console. Welcome back. Now let us understand how we can integrate RabbitMQ into our Spring Boot project. So what we are going to do is we are going to head over to Spring Initializer because we are going to need some dependency to add. So I'm going to say add dependency and I'm going to say RabbitMQ. Now here you will see Spring for RabbitMQ. So I'm going to select this. I'll make sure I select Maven here and I'll hit Explore. So there are 3 dependencies that I need to take. So I'll take all these 3. Okay, so that we don't miss anything, and I'll head over to my project here. So now in our project, I'm going to head over to company microservice first. Okay, and here in the end, I'm just going to paste the dependency. Okay, so I think I can just get rid of, okay, so I got the dependencies tag as well. Copied, let me check. Yep, I copied the dependency tag as well. So I need to get rid of this. And I believe we don't need Rabbit test and Spring Boot starter test. So I'll remove this. So if I scroll up, we have already added Spring Boot starter test earlier. So I'm just adding Spring Boot starter AMQP. Okay. And I'll copy this and I'll even paste this into review microservice. Because these are the 2 microservices that will interact with message queues. So I'll paste it over here and I'll go to Maven tab and I'll reload all the Maven changes. Now everything is resolved and all the error go away. Now what we are going to do is we are going to do a little bit of configuration and we are going to make our Spring Boot projects aware as to how they can interact with RabbitMQ. So first we'll start with company. So I'll go to src main and I'll select the application.properties. Now over here, I'm going to add RabbitMQ like so. Now here, I'm going to add some properties like I'm going to specify the host, port, username and password for RabbitMQ. So I can say spring.rabbitmq.port. Or we'll start with host. Host is local host right now. So I'll say local host. And then we'll need to specify the port. So I'll say spring.rabbitmq. I'll say port is equal to 5672. So that is the default port where our RabbitMQ instance is running. Then I'll add username. So I'll add username here, guest, and password. So password is also guest over here. So we have this settings or these configurations that we need for our Spring Boot project to be aware of RabbitMQ. And this way Spring Boot will know how it can access and interact with RabbitMQ. Then I'll copy this and I'll head over to review microservice and I'll add the same in application.properties in the end. Right? So these are the changes that you need to do in order to integrate RabbitMQ into your Spring Boot projects. Hey there, welcome back. So let us get started with the building. So what are we going to build first? We are going to build a way to publish messages to RabbitMQ, and who will be the publisher in our case? So in our case, publisher will be the review microservice. So I'm going to head over to review microservice. I'm going to close all the tab. Now here, this particular microservice will be responsible for publishing the message into the RabbitMQ. Okay, so there will be a queue wherein the message will be published and this message will be then consumed by the company microservice. Now, when are we triggering this message? So we are triggering this message whenever a new review is being posted. So when a user posts a new review, a message is being triggered to the queue. Company microservice then knows that, hey, a new review is now available, and then it fetches the average rating for that particular company against whom the review was posted. So against that company, it fetches the new average rating from the review microservice. So let us make that happen. So I'll head over to the review package over here and let us create a new package here. So I'm going to create a new package and I'll call this as messaging. Okay. So we are going to have all the files related to RabbitMQ written over here. Now I'm going to create a new class over here and I'm going to call this RabbitMQ configuration. So I'm going to call it RabbitMQ configuration like so. All right. Now what does this class do? So this is the configuration class for setting up RabbitMQ in the Spring application. Now, this particular class will be allowing us to define the beans, and it will also be used to configure and control the behavior of RabbitMQ messaging. So we are going to have three method definitions here. One method is going to create a queue. Another method is going to do the message conversion. So it will convert the message into the JSON format. So we'll be serializing and deserializing the message. And then we will have a method which will give us an instance of Rabbit template. Now what is Rabbit template? Rabbit template is a helper class. So let us start doing that. So here in RabbitMQ configuration, I'm going to say public queue. Now I'll need a queue. So I'll say queue. Now when you are selecting queue over here, just make sure you select queue from com.rabbitmq.client.eqmp. Okay. So there are quite a few queue objects that you will see over here. Okay. Just make sure you select the right one. That is important. Otherwise you will end up landing errors. So it's Spring Framework.amqp.core. Okay. So I select that. And what I'm going to do is I'm going to name this method. So I'm going to say company rating queue. Okay. And here I'm going to return a new queue object. All right. And as a parameter, I'll pass in the queue name. So I'll pass in this name here like so. Okay. And then I'm going to have public message converter. So I'll say message converter. So we'll add the message converter from amqp.support package. All right. And I'll call this method JSON message converter like so. And here I'll return. So I'll say return new Jackson. So you can see this particular suggestion, Jackson to JSON message converter. So that is what we are going to use over here. And we are returning the instance of the same. All right. And then again, I'll have public Rabbit template. Okay. So I'll say Rabbit template here and I'll say Rabbit template like so. And this particular class will accept final connection factory like so, and it will say connection factory here. And then I'll create an instance of Rabbit template. So I'll say Rabbit template. And then here we need to pass the connection factory as well. Okay. And then I'll say Rabbit template dot set message converter. So we will have to set the message converter. And here I'll have to pass the instance of JSON message converter like so. Okay. And then I'll return the Rabbit template like so. Okay, so we are getting an error over here. Okay, so the error we are getting is because we are providing an incorrect argument. Okay, so I'll have to change the import type over here. So we have imported a wrong connection factory here. Okay, so let me remove this and let me scroll down here. Okay, final connection factory. So just make sure you have right imports. Okay, so these are the import statements. So you need to have right import statements because otherwise you will land in error. So you notice over here, everything is from the AMQP package over here. All right, so we have set up the configuration class, and this class is responsible and it will help us like do the configuration for our queue. Now we need to define this as configuration over here. So I'll say configuration and I'll define everything as bean over here. So I'll say bean and I'll copy this and I'll paste it everywhere. Okay, like so. So yeah, so what we are doing here is we are creating a queue over here. All right. Then we are creating a new Jackson to message converter bean, and this converter will be used to serialize and deserialize messages. Okay. Now, in this case, the converter uses Jackson, and Jackson is a popular library for handling JSON in Java to convert messages to and from JSON format. And then you have Rabbit template over here. So this is a helper class, like I mentioned, and it handles the creation and release of resources when sending messages to or receiving messages from RABBITMQ. Okay, so we are creating an instance of Rabbit template bean over here. So now we are done with this. Now what we need to do is we need to set the message format that we can have over the network. All right. So for that, what we are going to do is we are going to create a DTO. So I'm going to head over to my project. I'm going to create a new DTO here. So I'm going to say DTO. So I'm going to have it in DTO package and I'm going to say review message. So this is the format in which the message will be broadcasted, and I'm going to have a few parameters over here. So I'm going to say long ID. I'm going to say private string title. So we will be passing all of this to the message queue, and this will be ultimately used by like the company microservice. Okay, so I'll say description. We can have rating as well go, and then I'll have the company ID. So I'll say long company ID like so. And then we can have getters and setters for everything. Okay, so I'll select all. We generate getters and setters. All right. So we're done with the DTO object creation as well. Now what we need to do is we need to create a producer to send the message. All right. And for that, I'm going to create a producer in the messaging package. So I'm going to call this as review message producer like so. Okay. And this particular class is going to have all the logic. So I'm going to say private. So I'll need an object of Rabbit template. So I'll say Rabbit template, and I'll add a constructor so that Spring can essentially inject this. So I'll say okay. We are done here. Now I'll create a method. So I'll say public void send message like so. And here I'm going to have review. So I'll say review and review. So I'll have the review object come in over here, and then I'll create a review message object. So I'll say review message is equal to new review message, like so. Now I'm going to set everything over here. So review message dot set ID, and I'm going to say review dot get ID, then review message dot set title. So I'm going to set all the parameters this way. All right, so I'm done adding the send message function over here. Okay, so this is the review message producer, which will do the job of sending the message to RABBITMQ. Okay, so this will publish the message and it will convert it into like the appropriate format and send it to this particular queue here. So that is what this class does. So we are done setting up review, like to publish the message into our RABBITMQ instance, okay, or RABBITMQ queue. So now here, once the review is added, we are not triggering this. So we'll be triggering this soon. But for now, this is done, and review microservice is configured to interact with the RABBITMQ instance. So now it's time to work with the company microservice and give it the ability to receive the message. So with company microservice, I'm going to head over to the microservice. I'll expand. So here we'll again need two classes, which will be the configuration class and the DTO class. And we can have the same class over there as well. So what I will do is I'll just copy these two packages. Okay, and I'll paste it over here like so. Okay, so within company I have DTO now, which is the review message over here. Okay, which is cool. And then I have the messaging. So here I have RABBITMQ configuration. Okay, which is what we need in company as well. Okay, and then I have the producer over here. So I don't need a producer. So I'm just going to delete the producer. But instead of a producer, I need a consumer over here. So I'm going to right click. I'm going to say create a consumer, and I'm going to say review message consumer, like so. And here I'm going to start defining the consumer. So here first I'll create an object. So I'll say private, and I'll say final. So we are going to need company service over here. Now, why do we need company service here? Because we are receiving the rating information. Okay. Now, once we receive the rating information, we need to update it against a particular company. Now, in order to do that, I'm going to create an instance of company service. I'm going to have a constructor created over here. Okay. And since okay, so there is some problem here. Identifier expected. Okay, so I didn't define the object name here. And now I need to define a constructor like so. Okay, so this is done. Now what I need to do is I need to define the consume message method. So I'll say public void consume message. And here I'm going to say review message, like so. And I'll have an instance of review message being passed on to the method. And I'll say company service dot update company, and I'll say message over here, like review message. Okay, so this is done. Now what I need to do is here I need to define Rabbit listener. So I'll say Rabbit listener, since we are listening to the particular queue, and I'll pass in queues over here. And I'll specify the queue name. So company rating queue, like so. So now we don't have a method in company service that accepts this particular review message as the parameter. So we need to define that. So I'm going to head over to company service. So in fact, I'll go to company service over here. Now here I'll create a method. Okay. So I'll create the method as public void, and let us call it update
company rating and not update company, because we already have a method called update company. So I'll say review message here, and it will take review message as an instance, and here I'll update this to update company rating here, like so. Now we need to head over to the implementation class here, and I'll have to override that particular method here. So I'll say implement, and I have overridden. Okay, so this is done. Now we won't have any logic over here defined yet. Okay, this is something that we will do soon. But for now, we have the company microservice also ready to start listening to the messages. Okay, so we have RABBITMQ configuration, which does the configuration. Then we have review message, which is the DTO in which we accept the response. So this is a format. And then we have review message consume, which is the consumer, and it listens to the queue over here. So yeah, we are done with company microservice. So now we have configured our microservices like review and company to interact with RABBITMQ. Now it's time that we can test our changes. So what I have done is I have started all the microservices except the company microservice. So what I'll be doing is I'll be using review to create a review and publish the changes to the host or to the exchange. All right. So let us head over to the controller here. Okay. So in review service, what we are going to do is whenever a new review is being added, so whenever this is being done, we will be creating a message and sending it to the RABBITMQ. And how will we do it? With the help of RABBITMQ message producer. So I have created a message producer here. All right. So here we have review message producer. So what I will do is, since it's a bean, I'll say private review message producer. Okay. And I'll get this automatically injected over here. Here, like so. And I'll say this dot review message producer dot like so. Now I'll go to this class and we'll check if we have defined it as a configuration. So we have not defined it here. So we have not added any annotation. So this is not yet being managed by Spring Framework. So what we need to do is we need to define this as service and not configuration, because this is not a configuration. This is service. Okay. So once we add this definition, okay, we'll see this import statement, and this is now being managed by Spring. Now back over here. Okay. Here we are getting an error. So we are getting an error in review controller, and we are getting error somewhere over here. So I've not added a semicolon, which is fine. I'll close this. Now I'll use this message producer to produce a message. So I'll go over here, and once the review is added, okay, so if the review is added successfully, I'll say, like, before just returning, I'll say review message producer dot send message, and I'll pass in the review object. All right. So we can do that, and okay, else without an F. So since we are now having multiple statements, I need to add the curly braces like so. Okay. So we are done with this. Now what we can do is we can restart the review microservice. So the service is up and running. So now here in Postman, I'm going to head over to review microservice, and I'll select this particular thing here, and I'll add a review against the company ID 1. So the review is added successfully. Now let us head over to RABBITMQ and see what we see over there. So here in RABBITMQ, I'll head over to exchanges, queue. I'll switch over to queue, and you can see the queue being created over here. So you can see company rating queue, and this is a queue that we have created ourselves. You can see some stats here, ready 1, total 1, which means one message is ready to be consumed. Now if I click on this particular option here, like the queue,
And if I go inside, you will see some stats over here. Okay. And here, if you go down, there is a get message option here. So you can click on get message and you will be able to see the payload of the message. So this is the message that we are sending. Okay. And this is what is there in the queue right now. All right. And this is of type the review message, which is something that we have defined. All right. Now, one thing, if you observe over here, ID is coming in as null and we need to check why is that happening. So I'll head over here and I'll switch over to review message reducer. Now here, if you see, we are setting the ID, but we are setting it with review message. So I need to say review.getID. So this should be fine now and this should fix that issue. All right. And one thing to remember over here, the message is now residing in the queue and company microservice is down. All right. So now what we can do is we can head over to company service implementation. So here is where you need to head over. So I'll just collapse this in company. I'll switch over to company service implementation. Okay. Now, one thing that I would like to change over here. So just keep this file open. We'll come back to this. But here you are seeing that we have defined the package outside. Okay. So I'll just move this inside company. Okay. We'll refactor this. So in company service implementation, this is the method that is being called once the message is consumed. So if you see message consumed, okay, here consume message and you are updating the company rating. Okay. So here what I will do is I'll add a simple statement. We'll say review message dot get description. So I'll just do this to see if we are able to read the message properly. So once we get the message details over here, it means the message is being read successfully. Okay. Also, since we just copied the configuration and the message, like the DTO package from company, we need to add the annotation here as well. Okay. So in review message consume, I'll add the service annotation. Okay. This is something we missed earlier. And now I'll start the service. So I'll head over to company microservice and I'll say start. Now, the moment it starts, what it will do is it will check the messages in the queue and it will read whatever is pending. All right. That is the first thing it will do. So you can see over here, description 2. And this is the description of the message that existed over here. Now, if I say get message, you'll get this message that queue is empty here. Okay. And if you hit refresh over here, so you can see ready 0, unacknowledged 0 and total 0. Okay. So there are no messages right now in the queue and the message we had in the queue is being read by company service. Now, if I send this once again, so if I say description as 1 and everything 1, and if I send, you can see description is 1 now. So we are indeed reading the message over here. Now, the next thing we need to do over here is we need to update the company rating. Now, how do we update the company rating? So to update the company rating, once the message is received by the implementation over here. Okay, so once we have the message over here, we are going to make a call to the review service. And from the review service, we will pass in the company ID in the API. And we will fetch the updated company rating for that particular company. So that is something that we need to do. Because here we don't have all the reviews stored. All the reviews are there with the review microservice. So there is no way we can calculate the average rating. So we need to trigger this query and get the results from there. So this is something that we'll do. So that's about how RABBITMQ is up and running, and we shall continue this in the upcoming lectures. Hey there, welcome back. So far, we have integrated a message queue, which is a RABBITMQ message queue, and we have integrated this to work with our microservices. So how the flow is working is we have a review microservice that publishes the message to message queue. And then we have company service that consumes the message. And review
Microservice publishes a message only when a new review is added. Now, what we need to do as next step is we need to update the ratings against the particular company. So we need to update the average rating against a particular company within the company microservice. So the first step would be to add the average rating field in the company service. Then if there is a new message, what does that mean? So it means that a new review is published in company review service, or sorry, not company review service, review service. So it means new message is published in review service. So what company service will do is whenever there is a new review, it will fetch or it will call a new endpoint of review service, which will return the average rating of that particular company against which the review was published. Now, how does company service know against which company the review was published? Simple. So it will get that information from the message over here. Okay. And then once it gets the average rating from the review service, it will update that within its database against that particular company. So that's the flow. So let's head over to IntelliJ and let's begin some action. So here in IntelliJ, I'm going to head over to review microservice. Now here I'll switch over to the review controller. So we will have a new endpoint defined over here. Okay. So I'm going to say get mapping and I'm going to say /average rating here. Okay. And I'm going to say public, and this is going to return a double. I'll say get average rating or get average review. So you can call it whatever you want. This does not matter. But here, what I need to do is I would be accepting the company ID. So I need to know again for which company I need to return the average rating, right? So I'll accept this and I'll accept it in the form of request parameter. So I'll say @request parameter here, like so. Now here I'm going to say review service, okay, dot get all reviews, and I'll get the reviews for company ID, like so. Now I have all the reviews. Now I'm going to store it in a list. So I'm going to say list review, and I'll say review list is equal to, like so. All right. So we have this information now. Now what I'm going to do is I'll just collapse this, and here I'm going to make use of streams to get the average review. So I'll say reviews, review list dot, I'll say stream, I'll convert this into stream dot map to double, and I'll say review here colon get rating or get average review. Okay, so we are not getting get rating over here. So yeah, this is the method. So after 2 colons, we'll get rating, and I'm saying dot average. So I'm calculating the average and I'm saying dot or else. Okay. So if I don't get an average, I'll say or else 0.0. Okay. So this is what I'm doing here. So what I'm doing is I'm saying convert this review list into stream and then map everything to double. Okay. And then for every review, I'm getting the rating over here. And then I'm calculating that into or converting that into an average. Okay. Now, if the average does not exist, we are returning 0.0. So this is what the function does, or this particular mapping will do. Okay. So now we have added this over here. Now what we need to do is we need to call this from the company microservice. So I'll head over to company microservice over here. Now to call this particular API, what we need to do is we need to add OPENFEIGN over here. Okay, because we are making an API call. So I'll go to job microservice because we have already added OPENFEIGN integration over there. Okay, so I should see that dependency somewhere over here. So you can see this dependency, cloud starter OPENFEIGN. So what I'm going to do is I'm going to copy this.
I'm going to close this and I'll head over to company microservice and I'll get this added. All right. So this is added. I'll hit refresh over here. Now, the first thing we can do over here is, so we will head over to the company entity here, and we need to start storing the rating that we are getting for every company. So this will represent the average rating of that particular company. Okay. So I can say private double and I'll say rating like so. And I can generate getters and setters for the same. Okay. So I'll say right click and I'll say generate getter and setter. Okay. So they're done. Now, after this step, we need to define the client. Okay. So we need to start making use of OPENFEIGN over here to make the API calls. And to do that, the first thing we need to do is we'll head over to the application class and I'll say enable Feign clients like so. Okay. Then I'll close this. Then we need to head over to, or we don't need to head over anywhere. We need to just create a new class over here. Okay. Which will be the Feign client. So I'll say clients dot review client. So we will create a review client in the clients package. Okay. And now here we will start defining the API call. So this will be the client that will be used for making the API calls. And I'm going to say Feign client here, and I'll say review service like so. So essentially what I'll do over here is we'll need a method here. So I'll say get mapping like so. And here I'll say the get mapping is /reviews/ so I'll just check the mapping. So average rating is the mapping name. So I'll say average rating here. All right. And here I'll define the method. So I'll say double and I'll say get average rating for company like so. And here I'll say request param and I'll pass in the company ID like so. Okay. And I'll say company ID over here. So let me hit enter so that we get a better visibility. So I'll say company ID and we need to define the type of company ID. So it's long. Okay. So yeah, we have defined the method. So I'm getting some red marks. Okay. So missing method body. So a small mistake we did here is we defined this as a class. So it's not a class, it's an interface, and the error goes away. So we have a review client which is ready to interact with the review service, and it has this mapping defined. Now, what we need to do is we need to head over to the implementation class of company service. And here is where we receive the review message once the rating is updated. So now what we need to do is we need to make use of the client to fetch the newly updated ratings, like the average rating, and we need to save it against the company. All right. So what I will do is I will scroll up here and I'll say private and I'll say review client. So review client, and I'll get the review client added over here in the constructor so that it's provided at the runtime. Okay. And here I'll say this dot review client is equal to review client like so. So we have an instance of review client now. Now what I will do is here I'm going to say company. So there is a series of steps that we need to do over here. So first we need to get the company from the database. Okay. And we also need to get the average rating against that company from the review service. And then we need to update this company review and we need to save it. All right. So I'll say company is equal to company repository dot find by ID. Okay. And here I'm going to say message dot get company ID. All right. And here I'll say dot else throw. So I'll throw an exception, probably we can, or we can just quit this. Okay, you can throw an exception if you wish to. Okay, so we're getting an error because it's optional. Okay, so we need to add else throw. Okay, so I'll say dot else throw, and you can have an exception inside. Okay, so I can say like this. I'll have an exception created like this, and I'll say company not found, and I'll pass in the ID here. So I'll say review message dot get company ID. Okay, so this is something that we are doing. So let me explain this here, what happened. So here we are throwing an exception. Okay, so if we are finding the company by this ID, it's good, or else we need to throw this exception. That is what this line simply means. All right, now here I'm going to say, so we need the average rating as well. Okay, so we have the company. Now I'll say double, and I'll say average rating. So this average rating we are getting from the review microservice with the help of review client. So I'll do this, and I'll say message dot get company ID, like so. All right, and now what I need to do is I need to update the average rating against the company. So I can say set rating, and I'll say average rating, and here I'll say company repository dot save company. So we have successfully updated essentially the rating that was posted against a particular company. All right, now let us test our changes. Okay, so what I will do is I will restart the company microservice, and we also need to restart the review microservice. Okay, and we'll wait until they both are up and running. So they both are up. Now we will head over to Postman here, and what we can do is we'll first create a company with the ID 1. So I've added a review first. We'll create a company 2 with the ID 1 over here. So we'll call it 1 as well. Okay, so company is created. Now if I get the list of all the companies, you'll get the rating as well, and rating for this is 5. Okay, so you can see the rating here. Now what we can do is we can go over here, and I'll get the rating for company 1. So you can see there is one rating that has been defined for this particular company, which is rating is 5.0. Okay, so now what I will do is I'll post one more rating here. Okay, and the rating can be, let's say 3, or I'll post a 3-star against the company 1. Okay, and I'll say description 2, description, or review 2, description 2, and I'll send this. Okay, now if you check the console for company, you should see this message being received. Now what we will do is we will try getting the companies. So now if you get the company, you will see the rating has reduced to 4, which indicates that the rating was updated. If I post one more rating over here, let's say rating 3, and I'll keep this as 1 star. And if I try to get the rating now, you will see rating has reduced now to 3. And you can see this from the logs as well. Okay, you can see all the queries, update company. So company is being updated as well. So these are all the queries that we are getting from Hibernate. All right, so this is indeed working perfectly fine and as expected. Okay, you can see here also with review microservice, we are seeing the rating query coming in action. So it's working fine. All right, and it is working as expected. So this is how you can make use of RABBITMQ for asynchronous communication between microservices, and this way it can be really helpful because synchronous communication might not always be possible and it might not be the best option. So RABBITMQ for the rescue.
Hello everyone, welcome back. So let us start talking about microservices packaging. So we all know microservices is a style of architecture wherein we have a collection of small loosely coupled services. And each of these microservices is deployed on a separate server. It is developed separately, deployed and scaled independently as well. But how do we get these services from our development environment to a state where they can be easily deployed, executed in a variety of environments like testing, staging, and production? And this is where packaging comes into picture. So let us first talk about how does a typical Spring Boot application executes or runs without any packaging. So what are the steps involved? So the number one step is the code compilation. So the first step is to ensure that your source code is compiled into bytecode, and this bytecode is .class file which is being used by the JVM, and the source files are compiled by Java compiler. Then the next step would be running the main class, and in Spring Boot application there is a main class which is annotated with @Spring Boot application annotation, and this serves as the entry point to the application. Then we talk about class paths and dependencies. So when you run the application without a jar, the class path must be set up correctly to include the compiled classes and any required dependencies. So the class path specifies the location where the Java runtime can find the necessary classes and resources. Embedded server. So if your Spring Boot application is a web application, the application typically includes an embedded web server, and when you run the main class, the embedded server starts and the application becomes accessible via HTTP endpoints. Source code changes. So since you are running the application from the source code, any changes you make to the code will take effect immediately upon rerunning the main class. So there is no need to rebuild the jar and restart the application. Then development mode. So running without jar packaging is convenient during development as it allows for rapid integration and testing of code changes. But for production environment, it's recommended to create a jar file. So these are the different steps that typically an application goes through when you are running it without packaging. Now what is packaging? So packaging is a process of preparing your microservice for deployment. It involves compiling your source code into bytecode, bundling it with any dependent libraries, and creating a single executable artifact that can be easily distributed and run. Now this artifact is what is called a package. Okay, so you can think of it something like this. So within the package, you have bytecode, dependent libraries, and the configuration. And packaging ensures that all the necessary components to run the service is gathered in one place in a format that's easy to distribute and execute. Now, what is jar? So when working with Java-based microservices, one of the most common forms of packaging is a jar file. So jar stands for Java Archive, and it's a file format that is used to bundle the components of the Java application together. And jar file allows us to package our compiled code, related libraries, resources, metadata, and the single file can be picked up by Java runtime environment and it can be executed. Now packaging our microservices into a jar file can provide us with number of benefits. So the number one benefit is simplified deployment. So instead of dealing with numerous dependent files and classes, we have a single file that we can move around easily. Second, it ensures that all the dependencies are satisfied by including everything we need in our package. So this way we avoid the risk of missing libraries or other dependencies. And lastly, jar files can be executed directly by Java runtime, which simplifies the execution process. So to summarize, packaging, and specifically packaging into jar files, is a critical step in preparing our microservices for deployment. So it
simplifies the process of transferring our applications between environments and ensures that we have everything we need to run our service. Now there are also other packaging options that exist, which is WAR. So this is like converting your application into a WAR file. And then we have EAR format as well. And then we have Docker image. So these are different packaging options also available. So that's all you need to know about packaging. Hey there, welcome back. So I wanted to talk a little bit about packaging basics. So in the world of Java, there are two primary build automation tools that dominate the entire landscape. And one is Maven and the other one is Gradle. And both these tools provide a comprehensive framework for managing the entire lifecycle of a Java project. And this includes packaging. So Maven is one of the earliest tools. It's one of the older tools that exists, and it uses this XML format that you can see, and it's a configuration file called pom.xml, and this is used to manage project builds. Now POM stands for Project Object Model. Now this outlines the unit of work in Maven, and it outlines the details about the project, what all the project needs, the configurations, and so on. Also, you can have defined packaging over here. So you can specify whether you want this application to be packaged as jar, war, or EAR file. And it takes care of the details without you having to worry about it. On the other hand, we have Gradle as well. So if you head over to the browser, and if I open up Spring Initializer with Gradle, and if you say explore, you have this build.gradle file. Now this is equivalent to the pom.xml file that we have in Maven. And this file takes care of having all the dependencies, the project definition, and so on if you are making use of Gradle as the build tool. Now when it comes to packaging, the build file, so build.gradle is the build file in case of Gradle, and pom.xml is the build file when it comes to Maven. So when it comes to packaging, the build file specifies the format of the package and it becomes the entry point for the application. And with packaging, it also has any additional resources or definition that might be included in the package. So I wanted to just stress on the importance of having build tools when it comes to packaging. So here you have everything about the project now. So you have all the dependencies and what all your project needs on the runtime along with versions is specified over here. So that's the importance of build tools in packaging. Hey there, welcome back. So we need to start packaging our microservices. So what I'm going to do is I'm going to head over to Google and I'm going to search for Maven. Now here you can head over to the official Maven website and you can click on download here. So there are two ways of using Maven. So in order to package our microservices into a jar file, we will need to run few Maven commands. So you can either download Maven from here and get it installed on your system, but this is not what I'm going to do. So I'm going to use something called as a Maven wrapper. Now, what is a Maven wrapper? So Maven wrapper is something that we get with Spring Boot application. Okay. And we can use Maven commands without installing Maven then. So Maven wrapper is a shell script and a small binary that automatically downloads the correct version of Maven for your project and uses it to execute Maven commands. So with that step, we don't need to install Maven manually onto our system. Of course, if you want to, you're welcome to do so. But what I'm talking about is this wrapper over here. So you will see this .mvn file or .mvn folder, which has the Maven wrapper in it. So we are going to make use of this. Now, before we start packaging, we need to understand a few Maven commands. So the number one command is mvn clean. So the clean command in Maven is used to remove all the files that are generated by the previous build. So if you are generating multiple builds and you might want to clean the files that are generated from the last build, you can use Maven clean. And this is because with every build, you will have some set of files that are being generated by Maven. So this is just for cleaning purpose. So running Maven clean will clean the target directory of your project, and which is where the Maven places all its build files. So if you see the project structure, you will have a target directory wherein all the files are being generated. So by files, I mean class files and jar files. The next command we should be aware of is Maven package. So package command compiles your source code and packages it in its distributable format. And the distributable format can be jar, var, or anything. So running Maven package will compile your code, run any tests if you have defined them, and then package your code into a jar file. And the resulting jar will be placed in the target directory of your project. Then we have Maven clean package. So this command combines the above two commands. So it will first remove all the files that are being generated by the previous build, and then it will compile your code and package it into distributable format. So these are some of the commands that you are supposed to be aware of. Now, here we are using MVN, but if you are using Maven wrapper, you don't need to use MVN. So there is a different way of executing commands using Maven wrapper, which we'll take a look at it shortly. But if you have installed Maven, you can use MVN, and the rest of the command remains same. So let us head over to IntelliJ. Now let us start talking about how can you start creating a package or a jar file. So what we are going to do is we are going to create a jar file for, let's say, company microservice. Okay. So what I will do is I will open up the terminal from here. This is the inbuilt terminal that I have within IntelliJ. Now here, I don't need to do any changes in pom.xml because I'm creating a jar file. Now, if you wish to create a file in some other format or some other packaging, you can have a packaging tag defined over here, and you can specify whatever you want to. So you can specify EAR, var, or you can even specify jar. But if you don't specify this, jar is the default. So I'll just remove this, and we have everything set up. We have the target folder created as well. Okay, now target folder does not have the jar file. So let us open the command prompt and let us make sure that we switch over to the company microservice directory. So I'll check where I am. So I'll go to the company microservice directory. So I'll say company microservice. And here I'll start executing the command. So I'll say // because we are using Maven wrapper. I'll say mvnw. So this is Maven wrapper, and we'll say package. Now this will start the process over here, and you can see like there is a lot of activity that is happening over here, and there will be a lot of console logs that will be generated. Okay. So when you are running this particular command, just make sure that all the dependencies that your application needs are there. So for example, things like ZIPKIN server, RABBITMQ, or whatever it needs, like PostgreSQL database, everything is up and running. Okay. So here you can see the logs. So if I scroll up, you will see everything was scanned, and then pom.xml was taken into consideration. Okay. And here, if you go, it started generating the files. You can see it started compiling, and then your application tests were run. Now your application was also started. Okay. So if you scroll down here, your application was running. Okay. And that is why we need all the dependencies. So your application might start, and then you saw quite a few logs. Okay. And your application was started. And then if you scroll down a bit here, you will see like everything was successful. And if you scroll down, you will see that the jar was generated over here in the target folder, and build was successful. So now if you go to the target folder here, you're going to see this jar file appear over here. Okay. So yeah, we have created our jar file. Now you can even validate the jar file after it's created. Okay. So I can run a simple command. I can say jar -tf. I can say target, and I can say company ms snapshot.jar, and I can say enter. Okay. So I'm not able to run this command jar. So I'm getting this error because I'm not able to run, or jar command is not recognized. And this is because I believe Java environmental variable path is not set for my system. So if you get this similar error, so what you can do is you can go to my computer, right click on my computer icon and go to advanced setting, and over there you will find environmental variable option. So if I go over here, if I search for environmental variable here, so you can also go here from the search. So since I'm on Windows 11, I can search directly over here and I can search for environment variables and I get this pop-up here. Okay. So I can simply open this, or if you are not on Windows 11, you can go to my computers, right click, and you can choose properties. So on my computer icon, if you right click, you will see properties and you can click on advanced system settings. And there you will see environmental variables over there. Okay. So on Windows, you can select environmental variables, and here you need to go to the path variable. You need to say edit, and here you need to add the path to JDK. Okay. So after adding, you might need to restart. Okay. So I'm not doing that. And if you ask me what is the path that I need to set, you need to set the path of Java installation or the JDK path. So you need to go to program files. So here, if I go to program files, I have it installed. So Java is installed in Java folder within program files. And there you have JDK 20. Now within JDK 20, you will have this folder bin. Now here you will have this file jar.exe. So this is what we are using here. Okay. So you need to copy this path and add to this path variable over here. Okay. This path variable. So I'm not doing that, but as an alternative, what I'll do is I will run it using another way. So I have the command created. So this is the path of the jar file. Okay. So what I'm doing is in PowerShell, I'm passing in the entire path of jar.exe along with the AND variable, because this is because I'm using PowerShell, and you can pass the rest of the command as it is. Okay. But if jar command works for you, you can just specify jar. And if you are not using PowerShell, you can also use something like this. So you can simply say something like this. So in PowerShell, you will need AND operator, but if you're not using PowerShell, this should work for you. Okay. So I'm going to copy this first command and I'll go over here and I'll paste it. Okay. And now once you paste this, you can see like everything within your jar. Okay. So if you scroll up and you will see all the contents of your jar file. Okay. And if you see over here, you will see everything that your jar file has. Okay. So this is to confirm that everything is working as expected. Okay. And you're just checking if everything exists in your jar file. Now, what you can also do is you can run your jar file. Okay. Right from the command line. Okay. You can run this project. Now, how would you run your project from here? So the answer is with the help of jar file. So it is an executable jar, right? So we'll say Java. Okay, something went wrong. So I'll just clear my screen here. I'll say Java and I'll say over here -jar. So since we are running a jar file, we need to specify -jar. And now we'll specify the path of the jar over here and we'll say run. So you can see the application is running now. Okay. And I believe it won't run. So it will shut down. And the reason is because our port is already engaged. And who is engaging this port? So I have the company microservice already running from IntelliJ. But if you stop this and if you start from here, okay, the port 8081 will be freed up and it will be in use by this particular service. So this way you can get your jar to execute, and this is the process that we went through. So I hope you found this entire process easy to set up and easy to follow. So that's about jar files with microservices. So let us test the functionality of our application that has been packaged into the jar file. So what I'm going to do is I'm going to go to services and I'm going to turn down the company microservice application. Okay. So this application is down. Now I'll try running the application right from the terminal. So I'll type in the command. I'll say java -jar and I'll say target /company snapshot.jar and I'll press enter. So now you see the application is running. We'll wait for a while and we hope we don't get any errors. So the application is running. Also make sure before you run the application, you have all the dependencies up and running, like the PostgreSQL, ZIPKIN server, RABBITMQ. So whatever this application needs. Now let us head over to browser, and here I'll go to Eureka. Okay. And we'll see that company service is now registered with the Eureka server. And you can even send some requests. So I can like get companies. I can post a company. Okay. And it will give me the list of companies. So it is working perfectly fine without any issues. You can see here, we created a new company and we are also able to get that particular company here. Okay. So rating is coming in as null. So I need to update the rating here like so. So I'll say 5.0. Okay. And I'll add a comma here. So I'll create this company. And now if I try to get, you'll see company with rating. So this is indeed working perfectly fine as if you are executing the project directly. Welcome back. So now let's talk about containerizing our Spring Boot microservices. So what are we going to build? So we are going to containerize each and every microservice that we have, and we are going to take everything to Docker. So this is what our architecture is going to look like. So we have 3 microservices: job, company, and review. All 3 will be running on Docker. They have their own individual databases, which is again running on Docker. Then you have the gateway, which is doing the job of routing requests, and it is serving as an interface for the external clients. So that will also be on Docker. And we have RabbitMQ, config server, Eureka server, and ZIPKIN, which will also be running on Docker. So this entire thing will be running on Docker, and we will be managing everything from a single file, which is Docker Compose. So we don't have to go to our IDE and turn on every single service, but Docker is going to manage everything for us. So this is what we are going to build. So without a further ado, let's get started. Welcome back. So let us start talking about Spring Boot profiles. But before we talk about profiles, I want to present a problem to you. So let us say I'm here in job microservice and I have my configurations or all the application properties defined over here. All right. Now, if you see these configurations, these are the configurations that are for my current system. Now, what happens if I Dockerize this application, or what happens if all my applications and microservices start running in Docker? So in that particular case, you can no longer use local host over here. That is because you have the microservices running now in different individual containers and not on your local machine. So instead, you will have to replace this with the container name. And that is where the concept of Spring Boot profiles come into picture. So here we are able to make use of PostgreSQL with the help of localhost, but config server, if it's running on container, we would want to include container name over here. And there will be few properties that we might want to change based on the environment in which the application is running. And this is where the concept of profiles come into picture. So what are Spring Boot profiles? So Spring Boot profiles provide a way to segregate the parts of your application configuration and make it available only in certain environments. Now what I mean over here is if your microservice is running in multiple environments like testing, staging, production, there is a possibility that you might need different configurations for different environments. So you might have a different database or a different URL of database for testing. You might have a different URL or different instance of database for staging. And depending on where your application is running, you might want your application to use that particular instance of database depending on where it's running. So this is where Spring Boot profiles come into picture. So you can have different profiles of your properties, and based on where your application is running, the corresponding property file is being picked up and it is being utilized. The other property files are not being used. So this is what profiles are in simple terms. So profiles enable Spring Boot application to work in different environments and to run seamlessly with the help of different configurations for each environment. And Spring Boot does the job of managing this during runtime. You just have to configure them. So that's Spring Boot profiles for you. So let us now begin preparing our projects for Docker. So what we will need to do is we need to modify all the configurations and create different profiles for application to work in Docker as well as to work on our local system. And also you need to make sure that you have this particular plugin, Spring Boot Maven plugin, added in all your microservices. Because of this plugin, you will be able to Dockerize your application without creating a Docker file. So this is something you need to check for. Now let us head over to application.properties. And what we need to do is we need to create a duplicate of this file. So I'll copy this file over here and I'll paste it at the same location. But this time I'll say -docker over here. So we are creating a separate application.properties file for Docker environment. Okay. And we are creating a separate profile, as you can see. So we are making use of this concept of Spring Boot profiles. All right. Now let us modify the application Docker. So here in data source, I'll need to specify the database URL over here. So I need to specify the container name here. So I'll say Postgres, and rest of the thing I'll keep same. Now in case of Eureka server, I will specify the container name over here as well. So I'll say Service Registry, REG. So you need to make sure you create containers with this name only. So I can add config server over here. So I can say config-server like so. Okay. And if you scroll down, so we need to add for ZIPKIN as well. So I have not defined the URL for ZIPKIN. Okay. So we need to define the tracing endpoint. Okay. So I need to say management.ZIPKIN.tracing.endpoint. So this is something you need to define explicitly because by default, the localhost URL is taken. So I'll say, so I'll copy this URL structure over here. Okay. And I'll paste it over here and I'll say HTTP ZIPKIN. And so that will be my container name. And here I'll say 9411. And here I'll have to add API-v2-spans like so. Okay. So we are done changing the URLs.
Now what you can do is you need to head over in your job app and you can see this clients folder which you have created. So here you are making use of service names over here. Okay. But this might change when you are working with the containers. So for that purpose, we will make use of variables defined in properties. So what I will do is I'll create 3 properties over here. Okay. I'll say job-service.url is equal to http://job:8082. Okay. So this is for my job microservice, and I'll replicate this and I'll say this is for my company service, and I can again paste it and I can say this is for my review service, and I'll change the URLs and port. So I'll say company and I'll say review, and I can say 8081 is company and 8083 is review. All right. Now what we can do is we need to head over to application. So not application.properties, but company client. And over here, we need to make use of another field. So I'll say URL. Okay. And I'll say $, and I'll specify the company service URL. Okay. So I'll say company. So wait a minute. Let me take this on a new line. Okay. And I'll say company-service.url over here. So with this, what we are doing is we are actually specifying the URL, and the URL is supposed to be picked up from the configuration because of this syntax. And where have we defined configuration? So we have defined it over here. Okay. So we have specified this for client, like company client, only one of the clients. We need to also specify this for review. Okay. So I need to head over to review here, and I'll copy this same thing and I'll paste it over here like so. And here I'll say review service.url. Okay. So now the URL is being picked up from application.properties file. Now what I need to do is I need to copy this, and I also need to add it to the default one. Okay, so the default application.properties, there also we need to add this. So there I'll say localhost. Okay, and localhost. So if there is no profile that is being used, and if we are making use of default application.properties, then it will point to localhost. Otherwise, it is pointing to containers. Or we are done doing configurations for the job service. Now what I will do is I will close the other tabs. Okay, and I'll just keep company client open. Okay, because we might want to replicate the syntax in review or company. Now I'll head over to company microservice here, and I'll open up the application.properties. Now over here, I'll just duplicate this. So I'll say application-docker.properties. Okay, and here, let me see if I'm defining any clients. So I'm defining a review client. Okay. So what I can do is I can copy these URLs and I can have them added over here. Okay. Like so. Okay. So there is some problem with the paste. So I'll just press enter and then add it. Okay. So now it works perfectly fine. And I'll also get these added in the local file, like the file which we have without any profile. Okay, and here as usual I'll specify localhost. Okay, and I'll get this copied across. Okay, so we have this defined, and I'll close this over here. So now in the company microservices, I'll make all the necessary changes. Okay, and I can keep this as a reference. So I'll say Postgres, and I'll paste Postgres over here. I'll scroll down. For Eureka server, I need to say Service Registry here. So I'll paste that over here. And I need to add the ZIPKIN URL. Okay, so you see I have one spelling mistake over here. So typo. So management.zipkin.tracing.endpoint. That is what it is.
So I'll copy this endpoint as well. And what I will do is I'll paste it over here for ZIPKIN, like so. And I believe rest of the things are fine. Okay. So rest of the things are okay and there are no issues as such. Now what I can do is I can go to the clients that I have created over here. So I have only one client, which is review client, and I can copy the syntax that I have defined here. And here I'll say, so instead of company service, I'll say review service. Okay. And it seems I'm getting an error. Okay. So I need to specify name over here if I'm specifying URL, which makes sense. So here we have company service URL, and let me check. So I'll go to src main Java, and here in clients, I'll go to review client. So yeah, I've made the change over here. So we have review service.url here, and we have made the changes, similar changes over here as well. Okay, so this is now making use of hard-coded URLs. All right. And we have replicated the same in the default application.properties. So I'll collapse this. And if you go to application.properties, we have replicated the same. So far, so good. So this is also done. This is company microservice. Now let us do this for review as well. Okay. So I'll go to application.properties. Here I'll say PostgreSQL. So first let me copy this. So I'll just copy these and I'll paste it over here at the top. Okay. So this is done. Now I can replicate the application.properties into Docker profile. I have a new profile now. I can collapse this. So now I'll scroll up and I'll use the company microservice Docker file as a reference. So I'll copy these three tags and I'll get them pasted in review Docker file. Okay. And if I scroll down now, so here I need to add the database container name, which I add, and I need to add the service registry. So I'll add that over here. And then I need to add the ZIPKIN URL, which I'll add over here. Right. So rest everything looks fine and there are no issues as such. Okay. So I have everything set up now. And one last thing, I believe we need to check for clients. So we don't have any clients defined in review. But despite that, I have created the URLs here just in case in future, if we want to use, we can make use of these. Okay. So this is about configuring all three microservices and getting them ready with Spring Boot profiles, along with container names that we are going to use for other parts of the application or architecture. So now we are ready to run these applications or Spring Boot applications with Docker. Hey there, welcome back. So we have prepared our project to be Dockerized and we have everything ready. Now let us begin building the Docker images. So to do so, we have to make sure that we have Docker up and running. All right. So I have started my Docker desktop here, as you can see, and I have my terminal open. Now what we are going to do is we are going to start building the Docker image, and let us start building the Docker image for our service registry project. All right. So let us head over to the terminal. So you can either use the inbuilt terminal or command prompt on your operating system, or alternatively, you can use the one that you get with IntelliJ. So you can click on the terminal tab over here and you can make use of this. And you can even add new tabs over here if you wish to. Okay. So I would be using PowerShell since I'm on Windows. Okay, you can choose the equivalent one for your operating system. And what we are going to do is we are going to navigate to the service registry directory. Okay, so I'll check where I am right now. So I am in company microservice. So I'll go one step above and I'll say service registry. Okay, and now I'm in this particular project. So I'm going to clear everything. Now we need to write in the command and we will be making use of Maven wrapper over here. Okay. So here is the command that you can see over here. So this is the format. So what we are going to do is we are going to make use of Maven wrapper over here. As you can see, I'm going to say Spring Boot :build image -d Spring Boot .build image name is equal to. So this is what I'm going to then specify. So my Docker Hub username and my image name. So the image name that I want it to be. So if you're not aware, or if you don't have a account on Docker Hub, I would request you all to head over to hub.docker.com. So I am on Docker Hub and I have already created an account over here. Okay. So I would request you all to create an account. Okay. And you will need the username that you set over here. Okay. And what we are going to do is, after creating the Docker image, we are going to push this image to the Docker registry, which is hub.docker.com. All right. So I have this command created over here. So my username is decode007 and service reg is the name of the image. So I'm going to just copy this command. I'm going to head over to my terminal, and here I'm going to paste this, and I'll say enter. Now, the moment you say enter, you're going to see some processing happening over here. Okay. So you'll see like the image building process is happening. There are quite a few tests that are running. Okay. And you can see this prompt over here, like it's building the image and it's also pulling in Paketo build packs. Okay. So we'll wait for a while. So it will download everything, it will pull everything, and then it will create your own image. Okay. So here it is pulling in Paketo build packs because it's using the concept of cloud native build packs to create Docker image. Now build packs are modular and language focused and know how to build application based on different languages and frameworks. For example, there are build packs for Java application, Node.js application, Python application, and so on. Okay. So Paketo build packs is a specific implementation of cloud native build packs that Spring Boot uses. It is using this since we have a Spring Boot project, and each percentage update is indicating the progress of pulling the base builder image from the Docker registry. And in this particular case, it's Docker Hub over here. Okay. Now, once this image is pulled, so this image is pulled over here, it will be used to create the Docker image. So you can see over here, after the build packs were pulled in, creator was started and it started creating the image over here. And this is the entire stack trace. And if you scroll down a bit, you will see like there are quite a few layers that have been added. Okay. And the image is now saved. Okay. And you're seeing build success, and it took this much of time. So the time it will take will vary for your project. Okay. It completely depends on the processing speed that your computer has and also your internet connection. Okay. And now if we say Docker images, we are going to see this particular image that exists now. We are also seeing Paketo build packs builder, Paketo build packs run, and so on. Okay. But we are concerned about our service registry over here. Okay. So we are seeing the Docker image. Now the time is to push this image to Docker Hub. Okay. So what I'm going to do is I'm going to say Docker push, and I'm going to write in the name of the image. Okay. So I'll copy this and I'll paste this, and I'll say enter. Now there is a possibility that you might be asked for logging into Docker right from the terminal. So you can enter your username and password and get logged in, but it didn't prompt for me because I had already authenticated. So now it's pushing the entire image to the remote Docker Hub. All right. And we'll wait for a while. So the process is complete. Now let us head over to Docker Hub, and I'll open the Docker Hub website. And if I refresh over here, so after refresh, you will see Service Registry Docker image appear over here. Okay.
So what we have done is we have successfully created the Docker image for Service Registry and we have pushed it to Docker Hub. All right. So this is the entire process that we need to follow for creation of Docker image and getting it live onto Docker Hub. Hey there, welcome back. So it's now time that we should Dockerize all our other microservices and get them pushed to Docker Hub. All right. So we have done this with Service Registry. We need to Dockerize all the other 5 microservices. So I would request you all to take this up as a challenge. You are aware of the process as to what you need to do. So you need to trigger this command in the root directory of the project. And once this command generates the Docker image file, you can push the Docker image file by running Docker image. And after space, you can specify the Docker image name. So this is something that we need to do for the rest of our microservices. And I would want you all to take this up as a challenge. So you can pause this video right now, attempt this as a challenge, and see if you are able to get Docker images for all your projects. All right, so I hope this went well with you. So let us do this for our other projects. So I'm going to start with company microservice. Okay, so I'll head over to our terminal and I'll switch over to company microservice. And here I'll paste that command and I'll say enter. Now with this, the process will begin and you will notice that it does not fetch the Paketo build packs this time because we had already downloaded it when we were creating Docker image for Service Registry. All right, so it won't do that this time. So it will just create the image and this time it will be much more faster. So Docker image creation is complete and you can see over here that this is the Docker image that's created. So the creation is done. Now we can push this particular image. So I can say push and so Docker push and let me paste the image name over here. Okay, invalid reference format. So this should be removed. Or 1 second. So I'll just remove this command. Okay, so you don't need to have a // so it should be review ms like so. Okay, and I'll press enter and you can see that it's now begin the push process. So the push process is complete and if we head over to our browser and if I refresh, you should see review microservice appear over there. All right, and now we can try the same process for job microservice. So I'll head over to the terminal and I'll switch over. Okay, sorry. So I need to add full stop and I'll switch over to job microservice directory and I'll paste the command. And this will begin the process to create the image for job microservice. So we'll wait for a while. So the image creation is successful. Now we need to say Docker push and we need to get the image name. So I'll paste it over here and this will be pushed to like Docker Hub. So hub.docker.io. All right. So we'll wait for a while until the push process is done. So the processing is complete. And if you head over to the browser and if you hit refresh, so we are seeing the job microservice available now over here. Okay. So let us do this for the rest of the 2 microservices. So I'll copy this for gateway microservice. And here I'll switch to gateway microservice project. So I'll say cd gateway and I'll paste this over here. Okay. And it will begin the process to generate a Docker image. So the image creation is done completely. This time it took 38 seconds. So now I'll say Docker push and I'll copy the image name until over here and I'll paste it over here. Now this is going to get this pushed onto Docker Hub. Okay, so we'll wait for a while again. So the process is complete. Now if you head over to the browser and if we hit refresh, you should see the gateway microservice project over here as well. Okay,
Now let us do this for the last remaining microservice, which is the config server. Okay, so what we can do is we can come over here. We can switch over to the config server project. Okay, so I can say config server and I can paste the command here. Now this should begin the process without any issues. Okay, so we'll wait for a while until this finishes. So this process is done and now we need to push it to the Docker hub. So I'll say Docker push and I'll copy the image name from here and it should get this pushed to Docker repository. Okay, so you can see over here it's preparing and it will get it up on the system. So the image is pushed and now if you head over to the browser and if I hit refresh, you should see the config server appear over here. So all our microservices have been pushed to Docker Hub. Okay, and the process is fairly simple. You just need to generate the image locally and you need to get that image pushed onto the server. You might be asked for authentication for Docker Hub, which you can do from the terminal. And once you are authenticated, the process should be fairly simple. All right, so that's about this class, and in the next lecture, we will move forward with this. All right, so we have Dockerized all our microservices, and we have even got them pushed to Docker Hub. Now, what we need to do is we need to start managing all our microservices with the help of Docker Compose file. So I'm going to open the Docker Compose file over here. Okay. Now this Docker Compose file has configuration for RABBITMQ, ZIPKIN, pgadmin, and Postgres. What I will be doing is I will be adding more components to Docker Compose. So you can see I have this notepad file where I have the updated version of Docker Compose. And you can see I have Postgres. If you scroll down, I have config server along with the Docker image name. And I have Service Registry, Company Microservice, Job Microservice, and I have one more instance of Job Microservice over here, which I don't think we will need. So I'll just remove this. Okay. We have Review Microservice. And I have RABBITMQ, okay, and ZIPKIN and Gateway Microservice. There is a lot in this particular file, okay, and what I'm going to do is I'm going to copy this file and I'm going to move this into our project here, okay. So let us go through this file. So you will see I have the configuration for Postgres, which is okay, it does not change. Same for pgadmin. Now there is this new addition of config server here. Okay, I have specified the image name over here, the container name. So this will be the container name which will be created using this particular image. And then I have port and then I have specified the dependency. Okay, so this dependency is something that we need to specify. So what is this depends on tag? So config server is dependent on Service Registry, and Service Registry is this particular container over here. Okay. So what I mean by specifying this is this container or this service should be started after Service Registry. Okay. So that is what we have specified over here. And we have added this to a couple of networks like a microservice network and Postgres network. Okay. And you can see over here, I have also specified which profiles I wish to use for this particular image. So the active profile is of Docker. So by default, if you see this is config server. Okay. So /docker file will be picked up. Okay. So we have defined /docker file for all our microservices. So that is what will be picked up. Okay. Now you can see over here, Service Registry depends on RABBITMQ, ZIPKIN, Postgres, and pgadmin. So first these services will be started and then Service Registry will be started. Okay. And I have added this to a couple of networks again. We have Company Microservice again, which is dependent on Service Registry and also the config server. Then we have Job Microservices And here we have specified a couple of things, like the Docker profile is supposed to be kept active. And we have specified the Eureka client service URL default zone. Okay. And this is the container name that we have specified. Okay. So we have specified similar things for the rest of the microservices. And if you go down, we have a couple of networks that we have created over here. Now what we need to do is we need to start our project with the help of Docker Compose file. And for that, I'm going to head over to our terminal. So here in terminal, I'm going to go to the root directory and I'm going to go to the company microservice directory. Now here you will see docker compose.yaml, which we have just modified. So here I'm going to say docker compose up and I'm going to run this in detached mode. Okay. So you will see like these 4 containers were recreated. Okay. And then you have the rest of the containers created and starting. All right. So our application is now starting in the form of Docker images. Okay. And you can see all the containers have started and you can say Docker PS. So this is going to give you the list of all the containers, okay, which you can check yourself. So you can see these are all the containers that have been started. Okay. Now, if you want to remove all the images, okay, so you need to say docker compose down. Okay. So I will say you can just go over here. Okay. And you can say docker compose down like so. And it will stop all the containers. You can see it is stopping all the containers over here. And if you want to restart or if you want to remove all the images now, okay, so let's say I want to check what all images I have on my system. So let me just zoom in a bit and I can say docker images. So this will give you the list of all the images that exist on your system along with the size. Now, if you want to remove all the images that we have created, so you can say docker system prune -a. So the moment you run this, all the images will be deleted and system will be clean. But I won't be doing this because I need these images. So now I'll say docker compose up and D. So you can see everything has started now and everything is created. So this is how you can move all your microservices to Docker Compose. And you can see now how it's easy to manage all our containers and all our projects. So with the help of one command, you are able to run the entire architecture. Okay, so earlier where you had to go to each and every project and start them individually in IntelliJ, now with the help of Docker Compose, that hassle is removed. Okay, so this is how Docker Compose helps you a lot. And you just specify your configuration at one place and get going. So that's about how you can move your microservices and manage them through Docker Compose. So now that we have all our containers up, you can see the started status. So what we can do is we can head over to our browser and check in Eureka if everything is up and running. So here in browser, I'll enter the address for Eureka. Okay. And if you scroll down and hit refresh, you will see you are seeing only 2 services right now, company service and the review service. So we are not seeing rest of the services. So clearly there is a problem and we need to identify the problem. So here, if you see, I'll say Docker. So let me type in Docker PS. And if you scroll up, you're not able to see the job microservice. So it has failed. Okay. Now what I'll do is I'll say I need to see the logs. So I'll say Docker compose down like so. So I'll stop everything. Okay. So one thing, if you observe, you only saw 2 microservices. You didn't see like these 2 microservices, like the company microservice. So you saw company, but you didn't see config server and the gateway. Okay. And there is a reason for this. So the reason is we have not created the Docker file for this. Okay. So application -docker properties. So let us create that as well. So I'll say -docker like so. Okay. And here, what I will do is I will make some changes over here. So I'll say instead of localhost, I'll say Service Registry over here. Okay. And rest everything I believe will remain the same. Okay. So this is for the gateway microservice where you are able to make these changes. Now, if you scroll down, we also need to add one more thing over here. So we need to add the settings for ZIPKIN, and also we need to update these names over here. Okay. So what I'm going to do is I am going to open up some other microservice here. Okay. So I'll head over to this particular microservice, and here you can see this is the setting for ZIPKIN. So I'll just add that over here. Okay. So this is done. Okay. So this is added somewhere. Okay. So it's added over here. So I'll just replace it over here, and I'll just get rid of it from here. Okay. So this is in gateway. Now I'll scroll up, and here you will see we have everything set up to localhost. So I'll change all of this. So I'll say Service Registry here. Eureka server static. This is also Service Registry like so. Okay. We have ZIPKIN configured. Here we have the review service. So this I can change to a URL. So I'll just copy this, and I'll say review 8083 like so. And I'll copy this as well, and I'll add this for job as well. So I'll say job over here. Okay. And this can be 8082. Okay. And then I'll have this. So this won't be review. Actually, it will be review MS. So let us check the microservice name over here. So if you scroll down, you will have, okay, no, so it's review. So this is what the name will be. So container name is what we are going to use over here. And this will be job 8082. Okay. And this needs to be company service. So here, instead of company service, I'll say company. Okay. And the company will be 8081, I believe. Yep. So this is done. And I don't think we are missing anything over here. Okay. So this looks good. So this is gateway. Now we need to make changes into config server. Okay. So I'll head over to the application.properties over here, and I'll just duplicate this, and I'll say Docker here like so. And I'll have to add the, so I'll have to say instead of localhost over here, I'll say Service Registry like so. Okay. So this is done. I don't think we need to make any other changes over here. Okay. So I'll hit save, and I believe we are good to go. Okay. So config server is changed. Gateway is also changed. All right. Now we need to check for job microservice as to what issue happened over there. Okay. So I'll say Docker compose up, but this time I won't start it in detach mode. I'll just start it without detach mode. So let us see what happens. And this way we will see all the logs and the progress of whatever is happening over here. Okay. So everything is starting, and you're seeing logs for different microservices, as you can see over here. Okay. And you should see the logs for jobs microservice shortly. So company starting. Okay. So here is where job microservice is, and we can see the stack trace. You can see the error over here. Okay. So we found the error, and the error says application failed. Okay. Why did it fail? So it says property Spring profiles active imported from application-docker properties is invalid in a profile specific resource. Interesting. So let us switch over to our coding editor. So it is saying that there is a file, and it is also giving you the line number. Okay. So it's giving you the line number over here is 34. Okay. So application Docker properties within job microservice. So here you can go to application properties, and line number 34 is this. So it's saying that this is invalid. Like you can't have the profiles set from application.properties, because you are running it from Docker Compose, and by the time the application is booted, profile is already set. Okay. So what I will do is I'll get rid of this. So if we want to set the property, we can set it in the Docker Compose file. So we have docker compose.yaml, and if you scroll up here, you can set the profiles from here. Okay. So I'll just get rid of that. Okay. And I'll just close this. So here I have got rid of that. And now there is one more problem over here, which I see. So here we are saying config server :8080. Okay. But if you go over here, it's config server ms. So the service name is incorrect over here clearly. So I need to update the service name as well. And I'll hit save. So we have made changes to the job microservice over here. But in fact, we have made changes to 3 services. One is gateway, job microservice, and the config server. So we need to create image for all 3, and we need to push it to the Docker Hub. Okay. So let us do that. So over here, we have started this in non-detached mode. So I'll say Control C. Okay, since I'm on Windows, I'm saying Control C. If you're on Mac, you can press Control or Command C. Okay, so that would stop all the containers. Okay, now once all the containers have stopped, we will create images one by one, and we will get them pushed to the Docker Hub. Okay, so I'll press the up arrow button, and here you can see this command here, which I had executed previously to create the image of job microservice. So this will create the image for job microservice, and it's running right now. Okay. Okay, so we got few errors. Now what are the errors? The error says, okay, so because we need config server, okay, you can see there are quite a few issues. There is no database up and running. So since we stopped everything, like even PostgreSQL, and there are no containers running, this is the problem. So what we need to do is we need to say docker compose up -d here. So this will be created and all the containers will be running, and we need to start a new PowerShell window over here. Okay. So here we have all the containers running. Or instead of starting a new PowerShell window, you can just do it over here because I just started it in detached mode. Okay. So we have database and everything running. Now I can create an image of job microservice. So the image creation process involves starting the microservice, running all the tests, and so on. So it needs things like database and all to be up and running. Okay. So now we won't get that issue because the database and everything is up and running. Okay. So this will take some time wherein it will get the image ready. Okay. But meanwhile, what I can do is I can switch over to, let's say I can go to desktop, courses, Spring Boot, and here I can switch over to config server. Okay, and we need to create an image for config server as well. All right. So what I will do is I'll scroll up and I'll look for the command that I did use to create the config server image. Okay. So I'll scroll up. So in a new tab, what I have done is I have switched over to config server directory and I'm running this command over here. Okay. And I'll say enter. So this will create the image for config server, and I'll create a new tab again. Okay. And here I'll switch over to gateway. So gateway is the service where we made the change. Okay. So here I'll create the image for gateway service. Okay. And we need, so gateway service name is, so gateway image name is gateway-ms. So I can say gateway-ms and I'll press enter here. Okay. So this image is also being created. And meanwhile, the config server image is done. So I can say docker push and I can just pull in the config server image. Okay. So this is being pushed, and let us switch to the first tab. So this Docker image is pushed. This is of config server. And now let us switch over to the last tab of gateway microservice. And this is also built. So we can push this. So I can say Docker push, and I can take this particular image name. Okay, so it picked in this name. So I can say gateway -ms, and it'll push gateway as well. Okay, and here if you see in the first tab, we have created the image of job microservice. So I'll copy this and I'll say Docker. Sorry, so I'll say Docker push image name. So one thing you need to keep in mind is you need to make sure that you navigate to the directory of the project or microservice and then you create the image. Okay, I'll tell you one problem that I just faced in. So I was in the company microservice directory. Okay, so if I scroll up a bit here, let me scroll up. Okay, so here I created the image. Okay, and here I was in company microservice. So this command I executed, but I was in the company microservice directory. Okay, and I was creating the image for job over here. Okay, but that is not correct, right? So if you are in the company microservice directory and if you're creating an image for the job, so what is happening is the image for company microservice is being created with the name of job ms. So this is the problem over here. So I was in the same directory and I created the image for job over here. So actually I was in company microservice directory. Then what I did is I recreated the image for company over here. Okay, so if you scroll down over here, you will see that I recreate the image. Okay, so there are quite a few logs. So here I recreated the image for company microservice. Okay, and then I switched over to the directory of jobs, and then I created the image over there. So here you can see I had to switch over. Okay, so just make sure that you are in the right directory. So you can see over here, this is the command that I'm talking about. So I realized that this was a mistake. So I recreated the company microservice image and then I switched over to the job microservice directory and then I triggered the request for job microservice. Okay, and you can see the request is successful and the image is created. So now what we need to do is we need to now start pushing the image for job microservice to Docker Hub. So here I'll say Docker. So one second. So Docker push job microservice and it will push all the changes. Okay. So now we have recreated the images for all three microservices. All right. And everything is pushed. Now we need to head over to company microservice directory because that is where our Docker file is. And we need to say Docker compose up. So I won't be running this in detached mode, but I'll run it in directly normal mode. Okay, let us see how this goes. So we are seeing the logs and we'll wait till all the logs have completed. Okay, and I'll keep a watch on the logs as to see if I'm not encountering any errors. So you can see all the services are up. Now let us head over to Eureka server dashboard. Now here I'm going to hit refresh and you will see all the services are up and running. Okay, so this way we have got everything running in a Docker container along with config server and everything. All right, so everything is up and running. You can see company service, job service, review service, and so on. Welcome back. So let us start talking about Kubernetes and let us understand what is Kubernetes. So first, I would want you all to raise your hand if you have ever been scared by the sheer number of containers that you had to manage in Docker. So this is a problem and one of the major problems that developers always have. So if you're working on a real world project, there are n number of containers that you will have to manage with the help of Docker and Docker Compose. Now, to solve this problem, this is where Kubernetes comes into picture. So let us take a step back into history and understand how Kubernetes came into picture, or how Kubernetes came into existence. So the story of Kubernetes begins with Google. Yes, that's right, Google. So imagine the amount of load Google has to manage with billions of searches happening every day. And not to mention, YouTube, Gmail, and all its other services are so popular that they have a lot of load. Now to manage this, Google built a system named Borg. Okay, so the system was internally known as Borg, and it was so useful that they decided to create an open source version of it. And this project initiated around 2014, and this is what now is known as Kubernetes, or it is also sometimes referred as K8s. But what exactly does Kubernetes do? So simply put, it is an open source platform that automates Linux container operations. So it eliminates many manual processes involved in deploying, scaling containerized applications. Okay, and in other words, you can cluster a group of hosts running Linux containers, and Kubernetes can help you manage those clusters easily and effectively. So Kubernetes is essentially a platform designed to completely manage the lifecycle of containerized applications using methods that provide predictability, scalability, and high availability. So consider a scenario wherein you are running multiple containers and you need these services to talk to each other. You also need to restart them automatically if they fail. And you need to have X number of instances always up and running for a particular service. So this can be addressed by Kubernetes. So Kubernetes provides you with a framework that enables you to run distributed systems resiliently. And it takes care of scaling, failover of your applications. It provides you with deployment patterns and more. So you define how your application should run and the ways they should be able to interact with each other or the outside world. And once you define this, Kubernetes will take care of this. Okay. Now, Kubernetes did not become popular overnight. Its success is attributed to the fact that it addresses a critical issue as to how to manage and orchestrate containers at scale. And not just that, Kubernetes also supports multiple container runtime environments, including Docker and so on. So you can run containers on any operating system, on any cloud, and in any region. Okay. So this is why Kubernetes is very popular. So Kubernetes, like I said, is essentially designed to manage the lifecycle of containerized applications. So that's Kubernetes for you. Hey there, welcome back. So let us start talking about the benefits of Kubernetes. So the number one benefit that we have is service discovery and load balancing. So Kubernetes can automatically expose your containerized services to the internet or any other services in the same cluster using a DNS name or an IP address. Now, if there is high traffic, Kubernetes can distribute network traffic to provide load balancing and ensure that your deployment is stable. For example, if you are building a busy e-commerce website during a big sale, and as the traffic increases, Kubernetes has the ability to evenly distribute the load amongst different instances of the site. And this ensures that the site remains responsive and does not crash under heavy load. So this is the number one benefit of Kubernetes. Then you have automated rollbacks and rollouts. So when you describe the desired state of your deployed container, Kubernetes can change the actual state to the desired state at a controlled rate. So if there is a mistake, Kubernetes will roll back the change for you without any downtime. For example, if you're deploying a new version of your application and you discover a critical bug in the update, so Kubernetes can quickly roll back to the previous version, minimizing downtime and the impact that it will have on the users. The next benefit we have is horizontal scaling. So Kubernetes can scale up your application and it can even scale down with a simple command. And you can even do this with the help of a UI or automatically based on CPU usage and other application specific metrics. So in case of an unexpected surge of users in your application, Kubernetes can automatically spawn more instances of your application to handle the increased load. So this is about horizontal scaling. Then we have self-healing. So Kubernetes constantly monitors the health of your nodes and containers. It does not replace the container that fail. So it will restart the container that don't respond to health check and doesn't advertise them to clients until they are ready to serve. So for example, if a container in your application crashes due to an unexpected error, Kubernetes will automatically restart without needing manual intervention. And this will minimize the potential downtime or degradation in the service. Then the next benefit you will have is secret and configuration management. Now Kubernetes lets you store and manage sensitive information like passwords, OAuth token and SSH keys. So you can deploy and update secrets and application configuration without rebuilding your container images and without exposing any sensitive data in your stack configuration. For example, instead of hard-coding sensitive information like database credential into your application, you can provide them securely using Kubernetes secrets, and this will improve the overall security of your application. So these are the benefits as to why Kubernetes should be used and how it makes the life of developers easy. So that's about the benefits of Kubernetes. So let us begin talking about the Kubernetes architecture. So Kubernetes architecture consists of control plane and worker nodes. So what are worker nodes? So worker nodes are machines that run your application. Now each worker node contains a kubelet, as you can see over here, and kube proxy. Now what is a kubelet? So kubelet is an agent for managing the node and the communication with the Kubernetes control plane over here. So all the communication between control plane and the worker node is done by kubelet. Now worker node also has something called as pods. Now what are pods? So pod is nothing but the smallest and simplest unit in Kubernetes object model that you can create and deploy. So pod represents a running process on your cluster. Okay. Now what do you mean by cluster? So cluster is nothing but a set of nodes that can be used to run containerized applications. Okay. And they have pods. Now pods contains of multiple containers, as you can see in the diagram, and there is a container runtime that is provided to them for execution purpose. So this is about worker node and what all it has. Now Kubernetes architecture includes worker node. Now worker node runs containerized applications, and another component is the control plane, which manages the state of the cluster. Now control plane has several components like API server, it has controller manager, scheduler and etcd. Okay. So API server is nothing but the interface between the control plane and the rest of the cluster. So these are all clusters that you have, and API server is the communication medium between the control plane and the rest of the cluster. So API server, you can say, acts as a front end for Kubernetes and its main management point of the entire Kubernetes system. Okay. Now this is about API server. What is etcd? So etcd is a distributed key value store that holds the cluster's persistent state. So there will be scenarios wherein you might want to hold some data that persists. So that is where etcd come into picture, and it stores the configuration information which can be used by each of the nodes in the cluster. Okay, and this is critical part of Kubernetes. It allows Kubernetes to store the state of the cluster. Then you have scheduler. So scheduler places the pods into worker nodes. So here you have pods in the worker nodes, and this is done by scheduler. And this is done based on resource availability. So scheduler is responsible for distributing work or containers across multiple nodes. So it tracks the utilization and the workload of the cluster nodes and makes sure that it allocates them appropriately. And then you have controller manager that runs controllers to manage the state of the cluster. Okay, so this is about the Kubernetes architecture. So you can think of this like you will have multiple worker nodes that will have multiple pods running different containers. Okay, then you also have container runtime, and this is the runtime software that is responsible for running containers. And then you have kubelet, and kubelet, like I mentioned, it's an agent that runs on each node in the cluster, and it ensures that containers are running in the pod, and it acts as an interface with the control plane over here. So this is about the architecture of Kubernetes. Hey there, welcome back. So let us start setting up our environment to work with Kubernetes. So the number one thing that we will need to get started is Minikube. Now what is Minikube? So Minikube is nothing but a tool that makes it easy for us to run Kubernetes locally. And like we know, Kubernetes is a powerful container orchestrator system that manages deployment, scaling, and operation of containers in our system. So we will need to have a way to run Kubernetes onto our system, and Minikube is that way for us. So I'm going to head over to Google and I'm going to search for Minikube Kubernetes. So here you will see the first link, which is of the Kubernetes website. So we won't go there, but instead we will go to Minikube official website here. Okay. And you will be taken to this web page over here. So you can see Minikube is local Kubernetes, which means it enables you to set up Kubernetes onto your local system. Now, here are some reasons why you might need Minikube. So Minikube is used for local development and testing. Okay, so if you are running Kubernetes, or if you want to test your application locally with Kubernetes, then you can make use of Minikube. And Minikube will mimic the real Kubernetes cluster and enable you to work with it. It is also important to use Minikube for learning and experimentation. Okay, since you are not working on production, on development environment, you can use it for learning and production. So this is why you can use Minikube. Now, should you use Minikube in production? Absolutely not. So Minikube is intended for local development and testing purpose. And if you are deploying your application to production, you will have a full-scale Kubernetes cluster provided by the cloud platform or on-premises infrastructure. So what I mean by this is, if you are deploying your application to Amazon, you have the Amazon Kubernetes. Okay, so if you search over here, Amazon Kubernetes. So it's called Managed Kubernetes Service, which is EKS. And then same for Google, you have their Managed Kubernetes Service. So you can use that. You don't need Minikube for that. So let's get ahead with the installation process. So if you scroll down over here, just make a note of all these requirements. Okay, so you need 2 CPUs or more, 2 gigs of free memory, 20 gigs of free space, internet connection, and a virtual machine manager such as Docker or any of these. Okay, so we have Docker installed, and you can choose which operating system you are on. So I'm on Windows stable, and you can choose the installer type. So you can choose exe, Windows Package Manager, or Chocolatey. If you're on Mac, you can choose your architecture. Then you can go for binary download, or you can install using Homebrew. Okay, so you just need to execute this command if you have Homebrew installed. Or if you don't have, you can go for this command, which is binary installation. And similar process we have for Linux. So I have Windows and I'll select this and I'll download the latest release over here. So once you have downloaded the exe, you can double click on this. You can say yes, and you can go through the process of installation. It is a simple process that you can go through. I'll say next and it will install this for me. So the installation is complete. Okay, now what you need to do is we need to start using Minikube. So for that, I'll head over to PowerShell. Okay, and let us write a command over here. So I'll say clear and I'll say Minikube. Let us see if this works. Okay, so Minikube is all right. So this command worked for me. And what I did is I just restarted my terminal. So terminal was open even before installing the Minikube. So after installing Minikube, I have to restart the terminal. So I restarted and I typed in Minikube and I can see that it's being recognized. Now I can say minikube.start or minikube start, and this is going to start the local instance of Minikube. So you can see it is downloading Kubernetes over here. It is starting control pane node. Okay, and it is using Docker desktop driver with root privileges, which is fine. Now when I said Minikube start, I saw some processing and I got this error. So it says that failed to start because virtualization is disabled. Okay, so it says this computer does not have VT-X enabled. Okay, and you need to enable the virtualization support on your computer. And for this, you need to restart your computer, enter the BIOS, and enable virtualization. But let's say I don't want to do that. So let me try running Minikube with a different driver. So I'll say Minikube start, and here you have a suggestion, driver equal to Docker. So I'll just copy this and I'll paste it over here. Okay, so -- driver equal to Docker, and I'll press enter. Okay, so I'm getting an error over here. So it says existing Minikube cluster was created using VirtualBox driver. So you need to delete that first. Okay, so you need to say Minikube delete. Okay, so it will delete this, and now you can start using Docker. So let us see if this also gives us the same issue of virtualization. So since I have Docker already installed and configured, I can leverage that to start Minikube. Now you can see this took some time, like there was some processing is what I saw, and this is complete now, and we did not get any error this time with Docker as a driver. Okay, so we just have to make sure that Docker is up and running. So this is done, and you can see the message kubectl is now configured to use Minikube cluster. So what is kubectl? So kubectl is a way using which you can interact with Minikube. So in order to see the status, you can say kubectl, and I can say cluster-info. So this will give me the information, and it says Kubernetes control plane is running over here and core DNS is running over here. So this tells us that kubectl or Minikube is completely set up on our system and it's up and running. Okay, so this way you can get this setup done. Okay, now there are different options when it comes to starting Minikube. So you can say Minikube start -- driver Docker. You can even use Hyperkit as driver. Okay, so if you wish to use that, you can use that as well. Okay, so this is about Minikube and setting up your environment on your Windows or Mac machine. Hey there, welcome back. So let us start talking about Minikube dashboard. So Minikube offers a dashboard, which is a web-based user interface that you can use to observe the state of your Kubernetes cluster and even manage its resources. So while you can do everything via a command line with the help of kubectl command, you can even make use of dashboard, which gives you a more visual representation and an intuitive way to interact with your cluster. So how can you access the dashboard? So to access the dashboard, you need to say minikube dashboard. The moment you press enter, this will open up the dashboard in the browser. So you can see it is taking a little bit of time. It is saying enabling dashboard, and it says like there is some add-on that is needed, and you will see this open up. So this is nothing but the dashboard. Here, as you can see that we don't have anything deployed yet, and neither there is any namespace. Okay, and you can see different options over here. So this is a visual representation of what you can do with Kubernetes. Okay, and this is inbuilt, like we have not created this. And this enables you to do things like monitoring, managing resources, accessing logs, access control, and it can also be a learning tool essentially. Okay, so yeah, this is about Kubernetes, or minikube dashboard, I should say. Hey there, welcome to this class. So let us start talking about pods. So what is a pod in Kubernetes? So a pod is nothing but a basic building block in Kubernetes, and it represents the smallest deployable unit. You can think of it as a group of one or more containers and their shared resources, such as volumes, IP address, and network ports. Containers within a pod run on the same worker node and share the same life cycle. Now, pods are ephemeral and can be created, scheduled, and destroyed dynamically. So these are some of the characteristics of the pod. Now let us talk about what a pod is not. So pod is not a durable entity. So if a pod fails or is terminated, it cannot be restarted or resumed. Instead, a new pod will be created and it will be replaced. Pods are not designed for horizontal scaling on their own. So scaling is typically achieved by creating multiple identical pods and distributing the workload amongst them using a high-level construct like deployment or a replica set. So you cannot horizontally scale pod by itself. You need to do it with the help of deployment or a replica set. Now there are some key considerations when you're working with pod. Pods should be designed to be stateless. Like any state or data that needs to be preserved should be stored in external volumes or managed by high-level abstractions like stateful sets. Pods communicate with each other within the same cluster using localhost. So containers within the pod can communicate with each other via inter-process communication mechanisms like shared memory. Pods are assigned a unique IP address within the cluster, which means that they can communicate with other pods or external services using that same IP. Let us talk about lifecycle and availability. So lifecycle and availability of pods are managed by Kubernetes. So it monitors the health of the pods and takes action like restarting or rescheduling pods whenever necessary. Now pods can have associated labels and annotations which can be used for grouping, filtering, and selecting pods when we define deployments, services, or other Kubernetes resources. So how can a pod be created? So this is a sample code which is used to create a pod over here. Okay. Now let's break it down. So you can see at the top you have API version. Now this specifies the version of Kubernetes API that you are using to create this object. And pod is nothing but an object in Kubernetes. Then you specify the kind. So this specifies the type of Kubernetes resource that you are creating, and in this case it's a pod. Then you specify the data type that uniquely identifies the pod. Okay. Then you have metadata, which is nothing but the data that is specified to uniquely identify the pod. Then you have things such as spec, Okay. Now, spec describes the desired state of the pod and what applications or services it should run. It includes the details about the containers, volumes, and other data. So if you take a look at this container tag over here, you will see it includes details like name, image, ports, and container port as well. So name is nginx over here, and this is the name of the container that will be running in the pod. And image, this is the image that we are using, and this is a Docker image that we are specifying over here. Then we have ports, where we are specifying the network ports that the container should expose. And container port 80 here in this case specifies that container should expose network traffic on port 80. What you can even do is you can add more containers to the pod. So here, this is the different version of the same file. Okay, you can see here I have one more container specified, and this container is now of Redis. Okay, so here I'm specifying the name and the image that this particular thing would use. All right, so let's get hands-on with this and let us create our first pod. So now to go hands-on, I'm here on my desktop and I have created a new folder called k8s. Okay, and I will be using a different IDE than IntelliJ for this purpose. And I am making use of Visual Studio Code, and I have even opened the folder k8s over here. Now, if you are not familiar with Visual Studio Code, or if you don't have it installed, I would recommend heading over to Google and searching for Visual Studio Code over here. And you can click on this particular link first. So it is an IDE which you can use, and it is free and open source. So you can download it for Windows, Mac, or Linux. So whichever operating system you are on, you can download it and you can open it. Okay. So after installation, what you need to do is you need to go to File, you need to say Open Folder, and you need to select the k8s folder that you have created on your system. And then it will open up something like this. Now here, what we need to do is we need to create a new file, and we will call this file as first-pod, and we'll specify this as YAML. Okay, so I have defined or I have created this particular file. So after creating this file, we need to add the code. So I have the code written over here in this particular notepad. So what I'm going to do is I'm going to simply copy paste this code here. So I have a code for a single container as well as for multi-container. So let us copy this and let us save this over here. Okay, so this is the code that I have added. Now we need to create this pod. Now how do you create the pod? So for that, we will head over to our terminal. Okay, before heading over to terminal, just make sure that you have saved the file. Okay, so if you were seeing a dot over here like this, okay, you can see this round dot. It means that you have not saved the file. So you need to hit Ctrl S and it will change to cross this way. Now, in order to work with, or in order to create the pod, we will head over to Windows PowerShell or any terminal that you have on your system. And you need to navigate to the directory k8s. Okay, so here I'm in this directory k8s. Okay, I'll clear this and I'll run the command. I'll say kubectl apply -f first-pod.yaml. Okay, and I'll hit enter. Now you will see the pod has been created. Now this command is used to create the pod, and -f is followed by the file name or the path to the file that contains the resource configuration. Okay, and we have the resource configuration defined over here. Now when you run kubectl apply f file name, Kubernetes reads the file, interprets the resource definitions, and applies them to the cluster. If resource already exists, it will update them to match the definitions in the file. And if they don't exist, it will create them. Now let us modify this pod that we have created. So here I'm going to open this notepad and I'm going to copy this second definition that I have over here. So I can paste this. Remember to save. And then if you go over here and if you say apply, you will see my pod is invalid. Okay. And pod updates may not add or remove containers. Now this suggests that you cannot modify the given pod. Now why is that so? So in Kubernetes, the specification of pod is immutable, meaning that pod once created, you cannot directly add or remove containers from it. And the reason for this is consistency. So Kubernetes ensures that pods are consistent and predictable as well. Okay. And atomicity is another reason wherein pods are treated as atomic units. Okay. And by allowing modification to pods container could introduce complexity in managing pods life cycle and also pods identity. So every pod has a unique IP address or hostname assigned, and modifying the containers within the pod could affect the pod's network. So now we have this pod created, and if we wish to have a new pod or a pod that has a different configuration, you need to add that as a new pod. Okay. So you have kubectl get pods. So if you run this command, you will get the list of all the pods that exist in your system. So right now we have one pod. Now what we will do is we will modify this pod and we will say this is my new pod and I'll hit save. So what we are doing is we are now, instead of updating the existing pod, we are now creating a new pod. So I'll say over here, kubectl apply -f first pod.yaml. And you will see this message here. And if you get the pods, you will see that the status is container creating. So you can say get pods -w. So -w will run this command in the watch mode and you will get live status updates. So as of now, the status update is not there because it's already changed to running. Okay, so to exit, you can say Control C or Command C on Mac. So this will update and this is known as a watch mode. Okay, so this way you can get your pods created and you can view them. So this is all about pods. Just remember one thing, that Kubernetes does not allow you to make changes to containers within a pod, and it is recommended to create new pods with the desired configuration and terminate the existing pod. Okay, so just make sure to keep this in mind. All right, so this is about pods and how they work. Hey there, welcome back. So let us start talking about service in Kubernetes. So what is a service? So service in Kubernetes is an abstraction that defines a logical set of pods and a policy by which to access them. And this is sometimes called as microservice. Now what I mean by this in simple terms is a service is nothing but a way using which you can access the pods. All right. So why do we need such a thing? So this is needed because pods in Kubernetes are ephemeral, which means that they can be created anytime and they can be destroyed, right? So you cannot rely on pods or pod IP to access them because IP is dynamic and it will change if a new pod is created and added to the cluster. So how would you access and make sure that you have a single access point to your pods or containers? So this is where service comes into picture. So with the help of service, you can have persistent connection to the pods it needs to access and regardless of changes in those pods. So this is irrespective of changes in the pods. So services enable you to help communicate with the pod. So now, given the ephemeral nature of pods, this greatly simplifies the network configuration and provides a simple way for us to access other pods, right? Now, the question is, how do you define a service? So here on my screen, you can see a simple YAML file, and this file specifies the application classification, the ports, protocol, and the set of pods that can be targeted with the service. Okay, so here you can see we have specified the API version first, then the kind of the object this is. So it's a service kind, and this specifies the type of Kubernetes object or resource that you are creating. And then you have the name that you have given to this particular service. And this comes under metadata, and metadata is the data that helps you uniquely identify the service. Like for example, its name. Then you have the spec, and this section specifies the desired state of the service. And this will include various properties like selector, ports. So selector, this field is a map of key value pairs, and a service will route the traffic across the set of pods that match the selector label. Okay. Then you have ports, and ports is the array that defines protocols and ports. Okay. So here you have TCP protocol, ports 8080, and target port is the port on the pod where your traffic is routed. Okay. It can be a port number or a name. If not specified, it defaults to the same as the port field. So this is the definition. So now let us head over to Visual Studio Code and let us start defining our service. So here I have this notepad wherein I have written the definition of a sample service. Now what I'm going to do is I'm going to copy this information and I'm going to create a file over here. Okay. And I'm going to call this as first service.yaml. Okay. And I'm going to paste the service definition over here. Let me hit save over here. So be sure to save the file. Now, if you switch over to your terminal, you need to run a command. So here we will say kubectl apply -f, and here instead of first pod, we will say first service, like so. And I'll hit enter. Now you will see first service is created, and you can get the service using kubectl get service, and you will see that there is this service that exists, which is of type cluster IP, and you have this IP here, and this is the port, and the age is it was created 8 seconds ago. So this way you can check for services. Hey there, welcome back. So let us start talking about how you can expose your application. So let us talk about 3 types of services that we have when it comes to Kubernetes. And the type of service determines its accessibility, whether it is from within the cluster, from the node hosting the pod, or from outside the cluster entirely. Okay, so this brings us to the most common types of services, which is cluster IP, node port, and load balancer. So cluster IP is the default type of service. So whenever you don't specify the type, you will get the service of type cluster IP. Now, what does it do is it gives a service its own IP address to communicate with other services within the cluster. And these services are only reachable from within the cluster, and they are not exposed outside. Okay. Then you have node port, and node port expands on cluster IP and exposes the service on the same port across each node. Okay. And this makes the service accessible from outside the cluster using node IP, okay, and node port. So this way you can access the service using node port. Now, what is load balancer? So load balancer exposes the service externally using the cloud provider's load balancer. So you can think of it that it builds on node port and assigns a fixed external IP to the service. And this is typically used in cloud-based environments where load balancer can be provisioned automatically. Okay. So if you have to see how you can specify the type of the service, you can see this example over here. So here in our example, we did not specify the type. And when we created the service, you can see that we got the service type of cluster IP. But if we specify the type, you will get the type as that of load balancer over here if you run this. Okay, and this is used to expose your application to the outside world because it will give you a fixed IP to your service which can be accessed externally. So this is about types of services and how you can expose your application to the outside world. Hey there, welcome back. So let us start talking about replica sets. So what are replica sets? So replica set is a Kubernetes object that is used for managing and scaling a set of identical pods. Now, why would you need a set of identical pods? So there is a reason for this, and one reason is high availability. So running multiple identical replicas of your application's pod ensures high availability. So if one pod fails or becomes unresponsive, the other replicas can continue serving the application's workload without any interruption, and this redundancy can help maintain the overall availability and reliability of the application. Then you have load balancing. So identical pods enable load balancing across multiple instances of your application. So by distributing incoming requests or traffic evenly among the replicas, you can handle increased load and achieve better performance and scalability. Load balancing also ensures that there is no single pod that becomes overwhelmed with traffic, and it allows for efficient utilization of resources. Then you have scaling. So having identical pods makes it easier to scale your application horizontally, because when the demand for your application increases, you can simply scale up the number of replicas to handle the additional workload. And Kubernetes can automatically distribute the load among the replicas. And this enables your application to handle more traffic without compromising the performance. Then you have something called as rolling updates. So identical pods play a crucial role again during rolling updates or deployments. So when you need to update your application to a new version, Kubernetes follows a rolling update strategy, which involves gradually replacing the old pods with new ones. And having identical pods ensures that the application remains available throughout the update process as new pods are gradually introduced and the old ones are gracefully terminated. Then you have service discovery and load balancing. So identical pods with a common label can easily be discovered and load balanced with or by another Kubernetes resources such as services. Now services can automatically discover and distribute the traffic to all the pods that match a specific label selector. And this provides a seamless and a consistent experience for client accessing your application. Okay. So why do we need replica sets? Okay. So pods are ephemeral in nature, and again, they can be created and destroyed, right? And ephemeral nature makes it challenging to rely on a single pod to provide a particular service. So replica sets mitigate this problem by ensuring a certain number of identical pods are always up and they are always running. And this is really crucial for load balancing and for ensuring the availability of the application. So this is about why we need replica sets. Then what is replica set not? Okay, so a replica set is not designed to handle rolling updates or deployments. Now, replica set only focuses on maintaining the desired number of replicas at any given point of time. So if there is a rolling update or deployment happening, even at that point, replica set will be responsible for making sure that there are some X number of replicas available. And another point is it does not provide declarative updates to the pod it manages. Okay, so to update the pod, you need to create a new replica set with updated configuration and delete the old one. So this is about replica sets. Now, what should you keep in mind about replica sets? So replica sets use a selector to identify the pod it manages. All right, so this is one point, and selector defines the criteria for matching pods. So selector is nothing but a label that is used, or a criteria that is used, that enables replica set to identify which pod it has to manage. And this is something that we'll see shortly in practicals. So also, when creating a replica set, you specify the desired number of replicas that you wish to have at any given point of time. All right, so this is something that you have control on as a developer. Also, if a pod is managed by a replica set gets failed or deleted, the replica set will replace it automatically to maintain the desired replica count. So this is another point. Then you have replica sets are often used with deployments, and deployments are the ones which provide updates, and rolling deployments are defined there, and these are done by managing the replica sets. Then you need to keep in mind that when updating the configuration of pods such as image versions or resource requirements, it is 100% recommended to use deployments instead of directly modifying the replica set, because deployments will make sure that the updates are done properly and are applied to the respective pods. So let us take a look at an example of a replica set. So here I have a notepad file which defines the replica set over here. And you can see over here the API version. I have defined the kind of object that it has, and I've specified replica set over here. Then I have metadata defined over here. So this provides the data that helps you identify the replica set uniquely, like the name of the replica set. Okay. Then you have the spec defined over here. Now spec has multiple labels over here, as you can see. Okay. So here we are talking about replicas. So like I said, that you as a developer has the ability to define how many number of replicas you want at any given point of time for a particular pod. So here I have specified 3 as the count. So at any given point of time, 3 replicas will be made available for this pod over here. Now here I have selector field, and this section is used by replica set to identify the pods that it should manage. Okay. So for example, here I have specified match labels and app::nginx. So replica set will manage this particular pod. Okay. And it will make sure that there are 3 replicas always available for this particular label. Then we have template. So this section defines the templates for the pods that replica set will create. Okay. So metadata under the template defines the metadata for the pods, and it includes the labels that will be assigned for that particular pod. So this is the label that is being assigned. And here you can see this is the label that is being managed. And then you have spec over here, and spec under the template tag defines or describes the state of the desired pods. So in this case, we are specifying that each pod should run a single container using this nginx image, and this is a version of the image. And we are also specifying the container port over here. Okay. So this is the definition of the replica set file. So I'll just copy this and I'll head over to Visual Studio Code. And here I'm seeing a pop-up which says Docker is installed on my system. Do you want an extension for this? Okay, from Microsoft for Visual Studio Code. So you can just say install if you wish to. So this will just enable you to manage Docker. Okay, so back to this particular thing here. And here I'm going to again create a new file. Okay, so I'll say replica set. So I'll say replica set.yaml, something like this. And I'll paste the definition over here. Okay. So I believe the extension is installed now. Okay. So you can see it makes working with Docker easy with all the syntax highlighting and everything, build image and all. So it's good to have this. So yeah, I have created a replica set over here, and now let us create this. Okay, so let us create this using terminal. So I'll head over to my terminal here, and here what I will say is I'll say kubectl apply -f, and here I'll say replica set.yaml. Okay, I'll just remove this dot and /. So you have this command here. Now if I say enter, you will see the replica set is created. So you can now check the pods in the watch mode, and you will see the pods are running, and you can see there are like 3 replicas of this pod here. Okay, because you had specified 3 in the count when defining the replica set. So here there are 3 replica sets that are like 3 pods from the replica set that are running over here. Okay, I can just exit the watch mode, and I can even say get pods normally, and you will see the same output. I can even get the replica set using this particular command. So I can say replica set here. Okay, you can see desired count is 3, current is 3, and ready 3, and the age is 46 seconds. So this was created just 46 seconds back. Okay, now let us say I delete a pod, or one pod gets deleted. So how do you delete a pod? So you will say kubectl delete pod, and you will specify the pod name. So let us say we delete this particular pod here. Okay, so I'll copy and I'll paste. Okay, and delete spelling is incorrect, so I'll just make it correct. Okay, so kubectl delete my replica set. Okay, now if I run this, the pods gets deleted, and now if you run this in the watch mode, you will see that there is one more pod that was created automatically. Okay, and this was created without you doing anything, and this is replica set in action right now. So you can see how it's managing the replica. So one pod was deleted and another one was immediately created. All right, so you can see over here it was within a fraction of a second. So if I keep this open over here, okay, like so. Okay, so let me keep this open here. And what I will do is I will open another instance of PowerShell over here. So let me say, so I'll create one more instance and I'll open this like this in a new window. Or how do I move? So let us now begin talking about the concept of deployments in Kubernetes. So what is a deployment? A deployment in Kubernetes is a high-level concept that manages the replica set, and a deployment provides updates for pods and replica sets. So if you take a look at pods and replica sets, they cannot be changed, right? Now you need a way to seamlessly roll out updates and everything during the deployment and development process. Now, how would you do that? So this is where the deployments in Kubernetes come into picture. So what you have to do is you have to only describe the state in the deployment object, and the deployment controller changes the actual state to the desired state at a controlled rate for you. Now, this means that you can seamlessly roll out new features or roll back to previous versions without any interruption, because deployments is working for you. So let me show this to you. So we are going to create a new file, and I'm going to call this as first deployment.yaml, like so. Okay. Now here I'm going to have a notepad being added here. So you can see I have this notepad over here where I have written the definition of my deployment file. Okay, so here you can see I have the API version defined, then the kind of the object that I'm creating, which is deployment. I'm specifying the name over here. So metadata helps you uniquely identify a particular object. And here I'm saying my deployment is the name of this object. Then I have spec created over here. Okay, now spec defines the desired state of the object. So this includes the number of replicas, the selector, and the template over here. Okay. Now replicas specify the number of replicas that you want to run for a particular pod. And in selectors, you specify which pods you want deployment to manage. Okay. So in this case, the selector is looking for the pods label app my app. Okay. You can see this is the label over here. Okay. Then you have template. Then this template is used for creating new pods. Okay. And this template includes the pod specification or spec, which includes things like pod containers, the names of those containers, and the images the containers should run. So this is all the definition that we have. Okay. So what we are going to do is we are going to move this to our Visual Studio Code over here. Okay. In the first deployment.yaml file. Now, as you can see, you have created the deployment object over here. Now, why do you need deployment objects? So number one use case or the reason you have is automated rollouts and rollbacks. So deployments are designed to facilitate updates to your application in a controlled manner. Now, when you update your application version or configuration, Kubernetes will replace or it will gradually replace the old instances with the new ones, ensuring there is no downtime during the transition. And if something goes wrong, Kubernetes can also roll back the changes. So this is a benefit. So this is about automated rollbacks and rollouts. Then you have scaling. So deployments also allow you to scale up or scale down to match the demand. Okay. And then you have health monitoring. So Kubernetes continuously monitors your health of the pods in deployments and restarts any pods that fails. It ensures self-healing of your application. Okay. So we have created a deployment file. Okay. Now let us head over to the terminal. Okay. And I'm going to just minimize this one. Okay. And here I'm going to just create that particular deployment. So I'll say first deployment .yaml. Okay. Sorry. So I got an error. It says no objects, and the reason is I have not saved the file. Okay. So you need to make sure you save the file, and then here you need to run this command. So you will see the deployment is created over here. Now you can say kubectl get deployments to get the deployments that have been created, and you can see the status over here. Okay. So this command will give you the deployments, and you can even get the pods over here. So I can say get pods like so, and you can see image pull back off. So you can see there are quite a few pods that are up. So let me run this in the watch mode. Okay. So you can see there are quite a few pods that are running in. Okay. And there is, I believe, some error that is coming in this image. Okay. But this way you can see the deployments going on, and you can even take a look at the pods that have been created by the deployment. Now you also have describe command, which enables you to see the event related to your deployments, including any errors, warnings, or anything. Okay. So you can say kubectl describe deployment, and you can add the deployment name over here. So the deployment is my deployment over here. Okay. So I can say something like this. Now you can see all the events over here. Okay. So you can see 3 desired, 3 updated, and 3 total. 0 are available and 3 are unavailable. Okay. Now, if you see over here, so you can see all the logs over here as to what happened. Okay. So you can just go through this if you wish to, and if you wish to describe your deployment. So you can even check the logs for your pods. So I can say get pods, and you can say kubectl logs, and you can add the log, like the pod name over here, like so. and you will get the logs for that particular pod. So this pod does not have any logs. Is that so? So yeah, I believe there is nothing for this particular pod, but let me check for these pods. So you can see over here, container my app in is waiting to start and failing to pull image. So there is this error that we are seeing. Okay, and wait a minute. So my app. So there is no container called my app over here. Is what I can see. Okay, so it's failing to pull the image, and that is why it's failing over here. So here, like image. So this image does not exist. Okay, so we need to add a valid image over here. And if we do that, so let me add this image here and let me apply this. Okay, so if I save this and if I go over here and if I say apply the deployment, and if you go in watch mode, you will see, okay, so this pod is being terminated, the deployment is being terminated. So let me check the status. So I'll just run pods over here and you can see it's started now. Okay, because we have specified a valid image name here. Okay, so it terminated everything and it started the required pod over here. Okay, so yeah, so this is deployments in action. Okay, you can even use describe to describe your deployments. Now, how would you manage changes in pods with the deployments? So to update the pod and add more containers, the recommended approach in Kubernetes is to use a high level resource called deployment. Okay, now this is because deployment manages the life cycle of the pods. Okay, so a typical workflow to update the pod and add more containers using a deployment would be to have a deployment file. Okay, and in the deployment specification, you can specify the number of replicas. So let's say if you want to make any updates, you can update the changes over here. Okay, and if you want to add any containers, you can add more containers over here. And then you go back and apply the deployment and the changes would be applied. And this is similar to the change that we just did over here. So we just updated the image name over here and you could see those changes applied. Okay, so make any changes over here and apply, and those changes will be reflected in your application. So this is about deployments and how you can work with them. Hey there, welcome back. So let us begin deploying ZIPKIN, RABBITMQ, Postgres to Kubernetes. And for that, we will first define the folder structure or the project structure over here. So here I have some files, but I will be creating a new folder over here. Okay, so I'll say one folder can be Bootstrap and I'll have one more folder. Okay, so this folder won't be under this one, but it would be in the main directory. So I'll say services. Okay, so these are the two folders that will have everything that we need for deployment. Okay, now within the services folder, I'm going to have a folder for defining the configuration and the deployment for ZIPKIN. Then I'm going to have one for RABBITMQ, and then okay, so they all are being listed under ZIPKIN. So I'll just drag this to under services. Okay, so we have under services, we have two folders now, and I can add one more folder over here. Okay, so one is for ZIPKIN, one is for RABBITMQ, and then we have one more service, Postgres. Okay, so I'll add one for Postgres here. So this is where we have services. Now under Bootstrap, we can have all our microservices. Okay, so you can have company. Okay, and then under Bootstrap, you can add one more folder. You can call this review. And then under Bootstrap, you can add one more folder. And you can call this as job, like so. Okay, so you have multiple folders like company, job, review. And then you have services. Okay, so it's good to organize things this way, okay, because organizing things helps you find important things and also helps you with easier deployment. For example, if you want to deploy all your services, like not your microservices, but all these services like Postgres, RABBITMQ, and ZIPKIN, so you can just run a simple command kubectl apply -f, and you can say k8s/services. So this particular command will take everything, like all the files under all the subfolders as well under services, and it will deploy them. Okay, and to deploy the microservices, company job and review, you can run the same command, but instead of /services, you can say /bootstrap. So this can help you with different aspects like organization, maintainability, and also add modularity to your structure. So this is a structure that we are going to follow. Okay, and what you can do is, if you don't want, you can just move these files. So I'll just create one more folder. I'll say first, and under first, I'll move all the files that I have over here. Okay, so that will just make things look a bit cleaner over here. Okay, so this is the structure that we are going to follow and we are going to build on. Okay, so yeah, I would recommend you all to create these folders and then we can get started with the next step. Hey there, welcome back. So let us start defining the configuration that we need for ZIPKIN to be deployed into Kubernetes. So we are going to need a couple of files over here. Okay, so here under ZIPKIN folder, I'm going to create a new file. I'm going to call this as ZIPKIN service.yaml, and I'll add one more file over here. Okay, I'll say ZIPKIN deployment. So this is the deployment file that I need. Okay, so why do we need deployment and service file? So deployment will be responsible for maintaining a specific number of replica pods running in the cluster, and service will be responsible for providing the network access to one or more pods. Okay, so I have the configuration ready with me, and the configuration is here in this notepad. Okay, so you can see here I have, like, this is the deployment, and let me move this to the respective files. Okay, so I'll copy the deployment first, I'll paste it over here, and I'll hit save, and then I'll move the service part as well. Okay, and I'll copy this and I'll paste it over here. So let us understand what is happening now. Okay, so let's talk about deployment first. So here we are specifying the API version, the object kind, and then we are specifying the metadata. So this is the name of the deployment here, ZIPKIN. And then we are telling ZIPKIN, or then we are specifying that we need only one replica, and that is what this deployment tells. And then we have the selector defined. Okay, so we say app ZIPKIN, and this selects the pod with the label app:ZIPKIN to manage. Okay, and then you have the template over here, and this template also has labels of app:ZIPKIN over here. Okay, so this defines the labels to apply to pods created by this deployment. All right, and then spec defines the container definition. Okay, so you have container with the name ZIPKIN, and here is the image that you are using, and then here is the container port that you are exposing. So what you're saying is, you're saying I want to expose 9411 within this particular container, and this is a standard port for ZIPKIN's HTTP collector interface. So that is what we are defining and creating in this deployment file. Now in the service, what we are doing is we are exposing or providing network access to one or more pods. Okay, so here we have this general tags that we have mentioned, or general properties, and then over here we are specifying the port under the spec. Now port uses TCP protocol is what we have mentioned over here, and target port is 9411. So this defines the port configuration for this particular service, and it maps the port 9411 on the service to port 9411 on the target port. Okay, or on the target pods, not port, sorry. So this is what it does. And then you have the type of the service defined here. And the type you are creating is load balancer. Now a load balancer service will provision an external load balancer that can route traffic to the pods selected by the service. Alright, so I hope this makes sense. So I'll hit save and we will save this configuration for ZIPKIN. So together these configuration will deploy a single replica of ZIPKIN running in container. So this container name is also ZIPKIN, and this container will expose the port 9411. And we also have a service named ZIPKIN that routes the external traffic to the ZIPKIN container through a load balancer. So I hope this is making sense as to how service and deployment both will work together to bring ZIPKIN to life from within the Kubernetes cluster. So this is about ZIPKIN and the configuration that we need for ZIPKIN. Welcome back. So let us start talking about the configuration that we need to define for RABBITMQ. So here I'm going to create a couple of files. So I'm going to say RABBITMQ -service.yaml. Okay. And I will duplicate this particular file and I'll paste it over here in the same folder, and I'll refactor it and I'll rename it to deployment. Okay. Like so. So I have defined two files, or I've created two files for deployment and service of RABBITMQ. So I have the definition ready for the deployment as well as the service. So I'm just going to copy this entire file and I'm going to head over to deployment and paste it. So the bottom part is of service. So I'll cut this over here and I'll move this to service.yaml over here. Okay. And I'll save both the files. So just don't forget to save. Okay. So we are creating two files here, a deployment that will manage the desired state of our application. And it has all the definitions that are needed for the deployment to be created. And we have specified the replica over here as 1. Okay. So this will make sure that there is only one replica for RABBITMQ up and running at any given point of time. So this deployment file is necessary for this very reason, where it helps you to manage the number of replicas, the updates, and even self-healing. So let's say if I have defined one replica over here, and if this one replica fails, then the deployment will make sure that there is one more instance that is created for RABBITMQ and the service is not down. Okay. And we have specified the container over here, like the container definition, wherein we have said the container name is RABBITMQ and image is this image, and we are exposing a couple of ports over here. Okay. And we have specified the app label over here as well. So this is about deployment. And then we have service file, and service file, like we know, it enables us to get a stable IP, since pod can be deleted and created anytime. So IP keeps on changing for the pod. So service file helps us with a stable IP, and it's also helping us with the load balancing. Okay. And it also enables us to access this particular service from outside. So that is why we are creating this service file, and this particular file is enabling us to define the service for RABBITMQ. So this is about the RABBITMQ service and deployment. Welcome back. So let us get started by defining the configurations for PostgreSQL. So handling of PostgreSQL will be slightly different as compared to the other services, RABBITMQ and ZIPKIN, that we have over here. And there is a reason for this, because we want the data in Postgres to persist and also there are some connection details and little bit of configuration that we have with PostgreSQL. So how do you manage this? So when deploying a PostgreSQL database on Kubernetes, it makes sense to use a config map, stateful set, volume, and a service. So these are the 4 things that we are going to need. Okay. Now, what is a config map? So config map is used to store configuration data in key value pairs. So let me show you the configuration. So I have this notepad here wherein I have the definition for all the 4 file types. So you can see this is config map, and here I have the definition of configuration or the configuration settings in the form of key value pairs. And this can include things like connection strings, memory strings, and other things as well that can be used for PostgreSQL tuning. Now we are creating a separate file to maintain the configuration. And the reason for this is it helps in separating the configuration from the image and the deployment, and allows for a bit of natural adjustment if we want to in future. Okay, so that is why we are creating a separate file over here. And also this can be reusable. So this is another reason why you should have a separate configuration file. So you can reuse this with different environments and instances. Okay, so this is about config map. So we are just storing configuration in config map. Now the next thing we have is service over here. So service, like we know, it is used to provide a stable endpoint for the applications to connect to PostgreSQL. Okay, so that is what we are doing over here. And then we have a stateful set over here. Now, what is a stateful set? So stateful set is used to manage stateful applications because databases require persistent storage and specific network identity, right? Because pods can be started and killed. So you need to have a mechanism for data to persist. And that is where stateful set come into picture. But the next file we have is the volume file, and this volume file represents a storage location. And for a database like PostgreSQL, where persistence is crucial, we need a volume file. Okay. Now, this is needed because we need data persistence. Now, when a pod dies, the data in its storage can be lost. And using a volume like persistent volume or persistent volume claim, like we have defined over here, it can ensure that the data remains intact. So this is one reason why we have used, and also performance. So you can choose different types of storage backends based on your performance requirements here. Okay. But persisting data is the main reason why we are adding a volume. So let us move all of this to Visual Studio Code. So I'll just copy all of this and I'll create a file over here. Okay. So let me create a file called config map. So I'll say config map.yaml and I'll paste everything. Now let us move everything to their respective files. So I'll create one more file called service.yaml, and I'll create one more file called stateful set. Okay, so stateful set.yaml here, and I'll have one more file created here. Okay, and I'll call this file as volume.yaml. Now let us move the code in their respective files. Okay, so here after config map, I'll copy everything. Okay, and the next part that we have after config map is service. So I'll head over to service. I'll save this and I'll head over to service here, and I'll move this to service. So this is the service definition here. Okay, so if you scroll up, this is the definition of service. Okay, so I'll just select all of this till the end. Okay, and then we will head over to stateful set. Okay, here, and here at the top I have the definition for stateful set. So I'll press backspace and I'll copy the volume definition to the volume file. Okay, So I'll move this to volume file here, like so. So we have all the definitions set. Okay. Now let us understand what each thing means. So we'll start with config map. Now here in config map, we are actually specifying the API version, the kind of the object, the name of the metadata. And here we are specifying few configurations, as you can see. So these are key value pairs that represent the configuration data. So we are saying the database name is EmbarkX over here. And then we are saying the database user is EmbarkX again. And then we have the password as EmbarkX. Okay, so these are three configurations that we have added. Okay, then we have the service file. So service defines how to access the pods. Okay, and here we are specifying like the metadata, the kind and API version, the selector, the ports, and the type, which is cluster IP. So service type says it's of type cluster IP, and cluster IP makes it reachable only within the cluster. All right. Then we have stateful set. So stateful set will manage the deployment of a set of a pod and guarantee the ordering and uniqueness. So here in the beginning, we have standard things like API version, kind, metadata, and so on. And then we have defined the spec over here. Okay. So we have specified the service name as Postgres, the replica as 1. And we have the selector, which matches the label of Postgres over here. Okay. So what it will do is it will select the pods with label app:/Postgres. All right. And now under template, we have defined the template for creating the pods. So we have the metadata wherein we are specifying the labels over here. And then we have the specification of the containers. Okay. So this defines the configuration for the container named Postgres over here. Image we are using is of the Postgres SQL. So this is the official image that we are getting. And we are specifying the image pull policy over here. Then we have env from. So this is going to import the configuration and environmental variables from the config map named Postgres config. Okay, so if you go over here, you have this config map called Postgres config. So this is going to be imported over here. Okay, and then we are defining the resources over here. Okay, so we are saying requests. Under requests, we have CPU 100M and memory of 256. And limits, we have specified some limits over here. Okay, so these are like different configurations of the memory and CPU capacity that you wish to have. Okay, and then you have volume mounts over here. So this defines where the volume will be mounted in the container. Okay, so we have specified the name and the path of the volume mount. Now if you scroll down, we have volume claim templates. So this is a template for creating persistent volume claims. Now, what does persistent volume claim mean? So persistent volume claim requests a specific amount of storage that can be used by a particular pod. So we are saying access modes as read write once. Okay, this is the access mode that we are specifying, and we are specifying the storage wherein we need 5 gigs of storage. Okay, so this is the definition of the stateful set. And then we have volume.yaml, okay, wherein we have created a volume of persistent volume claim. All right. And we have named it as Postgres PC volume claim. And the label of the app is Postgres over here. And then within spec, we have defined the storage class name as manual. And this specifies the storage class name to use. And then we have the access mode and the resources again specified over here. So this is the configuration that we need to do for Postgres SQL, and these configurations together set up a single replica Postgres SQL database within the Kubernetes cluster, and they include the configurations for environmental variables, how to access the pods, and how to manage the deployment, and how to handle storage, ensuring that the data persists even if the pods are restarted. So that is really important. So this is about the configuration for PostgreSQL. Hey there, welcome back. So now we have the configuration set for all our services, and now it's time to run them. So what I'm going to do is I'm going to delete first whatever I'm already running. So if you see over here, and if I run get pods, you will see there are quite a few pods that I'm running already, and there are quite a few deployments as well, like so. So instead of getting deployment pods and services individually, I can say kubectl get all. And you will see that it gives me a list of everything like replica set, deployment, service, and then pods as well. Okay. So what we need to do is we need to start deleting all of them, and then we need to start deploying our services. So this is something we created for learning purpose. So we will delete all of this. So I'll start by deleting deployments. Now I'll say kubectl delete deployments -2 times all again, and then I'll say namespaces like so. Okay, so this will delete all the deployments. Now I need to delete all these services. So I'll just run the same command, but I'll replace this with services. Okay, and then I'll run the pods over here like so. So you can see now everything is deleted. Okay, and you can like run kubectl get all. You can see few replica sets still exist. Okay, so you can even delete them. So I can say replica sets. Okay, and if you say get all, you will see like nothing exists now. Okay, so we have cleaned everything. It's important that you go in order essentially. So you delete the deployments first, services first, and then you have pods. So if you're deleting deployments first, deleting deployments will cause the associated replica sets and pods to be deleted as well, because you're deleting the higher level entity. And then if you delete the services after deployments, this ensures that you don't have services attempting to route traffic to non-existent pods. And then you finally delete the pods which are not managed by any deployments out there. Okay, and you need to be careful about the delete commands. Okay, because we are running them across all namespaces. So everything is deleted here. So now since we have deleted everything that was running, now it's time to run our services. So we are going to start with PostgreSQL. So right now I am in k8s directory, and I'm going to say kubectl, and I'm going to say apply -f, and let me say services, and I'm going to go to Postgres, and I'm going to run deployments. Okay, so for Postgres, we do not have deployments.yaml. So you just have to go to the directory here, and you just have to press enter. So it will pick up all the files, and it will get everything created. Okay, so now if you say kubectl.get all, so you will see like everything for Postgres is up and running. So you have a pod, you have a service, and you have a stateful set as well. All right. So this is how we can get PostgreSQL up and running. ZIPKIN and RABBITMQ is something we will touch upon later, but for now, let's get started with PostgreSQL. Hey there, welcome back. So we now have PostgreSQL running in Kubernetes. Now what we need to do is we need to log into Postgres, and we need to create the databases. So remember, our microservices need 3 databases: job, company, and review. So we need to set that up. So what I'm going to do is I have everything up and running. You can see over here, I have the pod, the service, and the stateful set up. Now what I can do is I will say clear. I'll say kubectl, and I'll run this command I'll say hyphen IT Postgres hyphen 0, and I'll say hyphen 2 times PSQL underscore U embarkx. So let me explain what this command means. So here, this command is used to log into the terminal of PostgreSQL. So we are saying kubectl execute exec, and this is a command that is used to execute a command in a already running container within Kubernetes cluster. All right. Then we are saying IT. So these two flags, I and T, stands for interactive, and T stands for TTY, which stands for terminal. So together they allow you to interact with command you are running inside the container as you were connected to the terminal session in that container. All right. Then we are saying Postgres hyphen 0, and this is the name of the specific pod that the command will be executed in. Then we have hyphen 2 times, and this symbol signifies the end of the command line options for kubectl exec. So this was the command line option for kubectl exec, and we specify that it's end of the command line options and the beginning of the command you want to run inside the container. So now inside the container, we are running this command. So we are saying psql hyphen u embarkx. So this command gets run inside the container. psql is the command line client for interacting with the PostgreSQL database, and hyphen u embarkx part specifies that you want to connect to user embarkx. So let us press enter and let us see what's happening. Okay, so it says Postgres hyphen 0 does not have a host assigned. So I'm getting this issue. Now what I'm going to do is, I don't know why this issue is coming in. So I will be restarting Minikube. This could be one of issue with Minikube. So I'll say Minikube stop, and this will power off Minikube, and I'll say Minikube start. So I'll say Minikube start over here. Okay. So it will restart Minikube for us, and then I'm going to redeploy or rerun PostgreSQL, and then I'm going to try this command again. So the restart is complete. You can see the logs over here. Now what I'm going to do is I will apply. So let me say apply services Postgres, and you will see everything is created now. Okay. And now I will, let's say, I'll execute this same command here. And now you will see that we are logged in to the terminal of our container. All right. Now we need to start running some commands here, and we need to get our databases up and running. So what we can do is we need to first check the list of databases. So I'll say hyphen and I'll say L. Now here you will see these are nothing but the databases over here. So you can say /L or /n list. So if you say, so here you have more list, okay, and you end over here, okay. Okay, so the command is done, and you can see we got 4 records here. So either you run -L, sorry, not hyphen, or /L, or you can say list over here, okay, and you will see the same thing. So you have this database, or you can see like you have this database created here, embarkx, which exists already. Okay, so I'm just going to press enter, and we will exit this. Okay, so I said Control C on Windows, and then I pressed enter for the output to exit. Okay, or you can press Command C if you are on Mac. All right, now what I'm going to do is I'm going to create the database. So I'm going to say create database job, and I'll end this with semicolon. Then I'll create a database called review. It will create the database, and then I'll create a database called company, and it will create the database. Now if I run list, you will see we have all the databases up and running. Okay, you can see there are 7 rows now. So we have company, job, Postgres, and review. So company, job, and review is what we will be using. So now to exit this, I'll say Control C and I'll press enter. Okay. So we have now successfully created the databases within the container. And now we need to exit this shell. Okay. We don't need to stay in this shell now because we have a database that we have created. So I can say Control D on Windows to quit the shell. And if you're on Mac, you can say Command D. All right. So this will quit the shell and you are back to the normal PowerShell. So if I say pwd, you will see that I am in my normal directory now. So that's about Postgres SQL and how you can set it up within the containers.
Hey there, welcome back. So let us start talking about API Gateway and Eureka Server when it comes to Kubernetes. So in traditional microservices architecture, tools like API Gateway and Eureka Server are often used to manage and discover services. Now by Eureka Server, it's a service registry from Netflix suite of tools. Now when transitioning to Kubernetes, many of these functionalities are either built into the platform or can be managed through other tools that are designed to work natively with Kubernetes. So let us talk about each one of them. So a simple answer to this question, like do we need API Gateway and Eureka Server in Kubernetes? The answer would be no. And I'll explain you why. So let us talk about API Gateway. So for API Gateway, there are multiple ways like Kubernetes ingress controllers. So Kubernetes provides ingress controllers to manage external access to services within the cluster. And these controllers can handle load balancing, SSL termination, and path-based routing. So this reduces the need for API Gateway. Instead of this, service mesh can also be used for even more advanced traffic routing options and even fault tolerance and security. Okay, so this negates the need for traditional API Gateway in the Kubernetes environment. And then talking about Eureka Discovery Server. So service discovery is also managed internally in Kubernetes. So when a service is created, it is automatically discoverable by other services within the cluster using its service name. So this is taken care by Kubernetes itself. So this negates the use of an external API gateway or service discovery for our architecture. But we will be having this on our local environments. So like we have different properties file. So what we can do is we can have API Gateway and Service Registry for our local environments and Docker. But for Kubernetes, we can negate this and we can do without these services. Okay. So to summarize, the core functionalities provided by API Gateway or Service Discovery tool like Eureka either built into Kubernetes or can be supplemented with Kubernetes native tools. And therefore, it's possible to use these tools within Kubernetes environment, but they might add unnecessary complexity since Kubernetes itself provides mechanisms like routing, load balancing, service discovery, and so on. And these are sufficient for most of the use cases. And this negates the need for tools like API Gateway and Eureka Server. So basically, we can get rid of these services in Kubernetes environment. Hey there, welcome back. So let us start with the job microservices and we will begin setting up the application properties for the Kubernetes environment for our project. So here, as you can see, I have a sample application.properties file, and this is something that I have written for Kubernetes. So we'll move this file to our project and we will discuss the changes. So I'll copy this entirely and I'll head over to my project here. Now here under SRC, I'll go to main resources and here I'll duplicate this particular file. So let me see whether we have a duplicate option. Okay, so we don't have a duplicate option. So I would rather go ahead and create a new one. Okay,
So I'll say new file and I'll say application hyphen k8s and I'll say properties like so. And I'll paste the contents that I have copied. Okay. So this file is now created in the jobs microservice. Now let us go through like everything that we have done in this particular file. So this particular file is the configuration for the microservice that is to be deployed in the Kubernetes cluster. And this file has various settings related to service discovery, data sources, and so on. Okay. So here to begin with, we have the list of service URLs. And these are the services that our job service will interact with. And in Kubernetes, you will notice that we have directly used the service name. Okay, so you can simply use the service name over here as the host name. Here we have specified the port. We have H2 database, which is disabled. Here we also have Eureka that is disabled. So here I have made a few changes, as you can see. So I have disabled the Eureka service URL and I have specified the application name as job service. And also here I have said register with Eureka false, fetch registry false. So if you go to the Docker file, your application.properties for Docker, you will see here I have the service URL for Eureka and I'm registering with Eureka and fetching the registry as well. But here I have disabled both of them. Then I have the logging level, which is set to debug, which is fine. And then I have the config server that has been disabled. So we don't even need to use an centralized config server. So in Kubernetes setup, you can make use of config map or secret objects instead. So I've disabled this. Then you have the resilience 4J configuration. And these are for setting up circuit breaker patterns and other resilience patterns for our service. All right. And circuit breakers, like we know, prevent failures from cascading in distributed systems. Okay. And these configurations will control how circuit breakers behave, like how many failure it takes before opening the circuit and so on. So these are all the configurations for that. Then I have the ZIPKIN configuration and the actuator configuration. So for actuator, I am exposing all the endpoints. And for ZIPKIN, I am sending the trace data to this particular endpoint over here. Okay. And then I have the Postgres SQL configuration over here. So I'm pointing to this database and I have all the details like username, password, and so on. So this is the configuration file for Kubernetes for job services. All right. So we will save this file and we will go ahead with the next step. Hey there, welcome back. So now is the time to set up the deployment and service for our job microservice. So what we are going to do is we are going to copy this entire file. So this is a notepad that I have written. So I'll copy this entire thing. Okay. So this notepad has the definition. So it has the definition for the deployment file as to what it's supposed to contain. And it also has the definition for the service file as to what it's supposed to contain. So now what I will be doing is I'm going to copy this entire thing, like the entire file. Okay, so these two definitions will be copied and I'll head over to Visual Studio Code. Now here you will see three folders. Bootstrap and services are the main folders that will be running our application. So here under Bootstrap, I'll go to job and I'll say create a new file. Okay, and here I'm going to define the deployment file and the service file for the job microservice. So I'm going to say job-deployment.yaml like so. And I'll paste the entire file that I had created. Okay, so this has service file as well. So I'll just clean this up. But before that, I'll say job-service.yaml. something like this. So we have deployment and service created. Now what I will do is I'll cut the service part over here and I'll move this to the service.yaml. And here in deployment, I'll just get rid of this until over here. And I'll scroll up and I'll even get rid of this title here. Okay. So we have everything set up. Now let us save these two files. So don't forget to save. And let us talk about what we are doing in this particular file. So deployment file has the configuration for deployment. So we are defining the API version, the kind of Kubernetes object, and the name and the labels. Okay. So this contains the information of the deployment itself, like the name and the label. Then we have the specs, and specs has the number of replicas. So we are keeping the number of replicas to that of 1. We have the template defined over here. Now template defines the blueprint for the pods that will be created by this deployment. Okay. And here under template, you have a spec field or a spec label, which defines the specifications for the containers that will run inside this pod over here. Okay. So the specification says we have one container and its name is job. And we have this particular image that we are pulling in. Image pull policy is always, and it means that it will always pull the image from the registry even if it already exists locally. So you can change this if you wish to. And you have the ports set to 8082. And then you have the environment. So this defines the environmental variables inside the container. And here, since we are saying Spring profiles active, and we are setting it to k8s, which means we'll be enabling a particular configuration, like this particular configuration, when the application runs. And then you have restart policy as always. So if the container crashes, Kubernetes will restart it. And then in the end, we have selector, and this defines how deployment finds which pod to manage. And here it's matching the pod with label app:job. So this is a definition for the deployment file. Now let us talk about the service file or the service configuration. So here, like always, we have API version, kind, and metadata set. Okay, so metadata contains the metadata regarding the service here, because this is a service object and it has the name here. Then we have the specifications defined. So here we are specifying the selector and ports. Now selector is how the service finds which pods to send traffic to. And here it matches the pods with label app:job. Okay. And then here you have ports defined. So this defines the port that service exposes. So the port on which the service will be exposed in this case is 80, and the target port on the pods to which the service will be sent, here it corresponds to that of 8082. So this is the service definition that we have. So deployment and the service are the two configurations that we need to set up under job folder within k8s folder that we have. And these two will define the Kubernetes configuration for job microservice. Welcome back. So let us now start talking about the properties file for the company microservice. So I've already created the properties file and I've defined it here. So what I'm going to do is I'm going to copy this entire file and I'm going to move to IntelliJ. And here I'm going to head over to company microservice, src, main, and under resources, I'm going to create a new file over here. So this is going to be the application k8s properties file. So I'm going to say application -k8s dot properties, and I'm going to paste the entire file. All right. So this is the configuration that we are setting for the company microservice to run in Kubernetes. Now let us understand what everything means and what are the changes that we have done in this particular file here. So we begin with the definition for service URLs. Okay, and these are the URLs that our application will interact with. So we have defined URL for all three services, and in Kubernetes, you can make use of container names as host names. So that is what we are using. We have specified the port number over here for the company microservice. We have disabled the H2 database, and here you can see I have disabled Eureka. So here I had the URL specified for connecting to Eureka client, but this is something that I have removed, and I have mentioned explicitly over here that I want to disable the Eureka client, and even register with Eureka and fetch registry is set to false over here. The service name is set to company. Now if you scroll down, you will have RABBITMQ configuration over here. Here you have the actuator configuration. So here I'm exposing all the endpoints of actuator. And then you have the ZIPKIN configuration. So we are specifying the endpoint where we will be sending the tracing data to. And we are mentioning the probability, like the sampling probability or the sampling rate, to 1.0. And then over here, I have the settings for PostgreSQL. So I've defined all of this, and this is a separate configuration which will be used for Kubernetes deployment. Okay. And it has all the configurations that is relevant for Kubernetes. So we don't have Eureka server. We have disabled Eureka server. Company microservice didn't have config server configured. Otherwise, we would have got rid of that as well. But these are the changes that we have done so far in company microservice. Hey there, welcome back. So now let us set up the deployment and service configurations for company service. So here you can see I have a notepad where I have defined the deployment as well as the service configurations for company. So what I'm going to do is I'm going to copy this entire thing. I'll head over to Visual Studio Code, and under Bootstrap folder, I will expand the company folder. So right now I don't have anything within company folder. So I'm going to add a new file over here, and I'm going to call this particular file as company, and I'll say deployment, and I'll add the YAML file here. Then I'll add the company and service. So I'll say company-service.yaml. Now I'll paste everything into deployment file, and then I'll copy or cut the service part to company service over here. Okay. And then within deployment file, I'll just get rid of this end part here. I'll just delete this. And if I scroll up here, I'll get rid of this as well. And I'll save both the files. So don't forget to save here. So I have deployment configuration and the service configuration set for company. Now let us go through and understand what each thing means over here. So here in deployment file, we begin with the specification like API version, the kind of object we are creating, and the metadata about the object. Now here in metadata, we are specifying the name of the deployment and labels to identify this deployment. Then we have specs that we have defined here. And under specs, we have things like replicas, template, and spec again. Okay. And then we have selector too. So under replicas, we are mentioning how many replicas of a particular pod we want to be running. So we keep this to 1. Template defines the pod's specification. So here we are saying the name is company, and this is the name of the pod. And the label we have is app:company, and this is to identify the pod. Now, if you scroll down here, we have the specifications, and we are specifying the containers over here. So this is the list of containers that will run within the pod. And we have specified the container name as company. which has this particular image, and it runs on this particular port over here. So these are the ports that are exposed from the container. So we are exposing 8081. And then we are specifying the environment property over here, or environment variable of the container. And the value we are passing in is k8s, because the properties file that we have created is -k8s. And then we have the restart policy over here. So restart policy says always, which means if the container stops, it will always be restarted. And then we have selector defined over here, and this selects the pod with label app:company, ensuring the correct pods are targeted by this deployment. So this is the definition for deployment file. And then we have service file, wherein we have the specification like API version, kind of the object, and metadata defined at the top. And then we have the selector defined over here, and this selects the pod with the label app:company. And then we have the port specified over here. So ports mentions the list of the ports that we wish to expose. So we are exposing port 80 to the external clients, and target port 8081 means the port on the container to which the traffic will be routed. Okay. So this is where our application will actually be running. So you can see over here, it's running on 8081. So service is listening on 8080, and it will route the traffic to the 8081 port of the container. So we have specified the type as load balancers, and this will allow external access to the pods. Okay. So this is how we have mentioned the service and the deployment configurations for company object, or for the company microservice. Hey there, welcome back. So now it's time to set up the application properties for our review service. And I have already defined the configuration file over here in the notepad. And I'm going to copy this and move this file into our review microservice. So I'll head over to src main resources, and I'll create a new application.properties file over here. So I'll say application -k8s. So this is the application.properties file for Kubernetes. So we'll specify that over here. And then I'll paste in whatever I have copied. Now let us go through this file. So we begin by defining the service URLs. Okay, and these are the URLs wherein we are trying to access the containers with the help of the service names. And with Kubernetes, it is okay to use container names as host names. Then we have the server port defined for the review microservice over here. I have the application name here. We are setting debug level to debug over here. And we have disabled the Eureka server over here. So I'm saying register with Eureka false, and fetch registry also false. And I'm disabling this URL over here, the service URL for Eureka. Then here I have the RABBITMQ settings, wherein I'm adding some resiliency and I'm configuring the RABBITMQ server. Then here I'm defining the actuator configuration, wherein I'm exposing all the actuator endpoints. And then I have the ZIPKIN configuration defined here. Now ZIPKIN configuration defines two things. We have the endpoint for ZIPKIN and the sampling probability, which is set to 1.0. And then in the end, I have the settings for PostgreSQL database. And here I'm specifying everything like the container, okay, how to access the container or Postgres instance. And then I have username, password, along with the database specification over here. So I've specified everything over here, okay, and you can see this is the database name in the end. So this is a file that will be used to work in Kubernetes environment. All right, and this is what we have configured with our project. Hey there, welcome back. So let us set up the configuration for review service, and we are going to define the Kubernetes configuration for this particular service. So here I have a notepad file created, and I have two things in this file. One is the deployment configuration, and here I have the service configuration. Okay, so what I'm going to do is I'm going to move both these things to Visual Studio Code, and I'm going to head over to Bootstrap, Review, and I'm going to create a new file. I'm going to say review-deployment, and I'm going to create this as YAML file, and I'm going to create one more file. I'm going to say review-service, like so. Now under deployment, I'll paste whatever I have copied, and I'll cut the last part of the file and I'll move it to service here. Okay, and I'll save this file. Now I'll do some cleanup in the deployment file. So I'll just remove this from here, and then I'll scroll up and I'll remove the deployment heading at the top, and I'll hit save. So we have two files added. One is for deployment and another one is for service. So you can see over here, it begins with the general information like the API version, the kind of the object that we are creating, so deployment in our case, and then we have metadata specified, and this is the metadata about the object like the name and the label. Then we have spec defined, and spec contains the specification for deployment. So we have the replicas configured here, so we want only one replica for this particular deployment. Template, we have the template definition for this particular pod, and then we have the container definition for this particular pod. And here you can see we are pulling in our image. This is the container name. We have the image pull policy, and we are also specifying the environment as to how we are supposed to run this microservice. And here in the end, we are adding a match label. Then in the review service, I'm creating a service object wherein I've specified some information as to the API version, the kind of the object, and the metadata which defines the name of its service. Then I have the specification of the service. So I say selector is app:/review, and this specifies which pod the service should direct traffic to based on their labels. And in this case, those with label app:/review is where the service directs the traffic. So here you can see we have defined the label here. And then we have the port information. So here we have mentioned the protocol, and 80 is the port that service listens on, and the target port is 8083 where the traffic is forwarded to. And this should match the server's port in our case. Okay, so this is the thing that we have specified for review. So here one small change I'll do. So here we are forwarding to 8083. So here I'll add container port as 8083 because that is where the traffic is being forwarded to, and I'll hit save. So this is the configuration that we have defined for our review service to be deployed and running on Kubernetes cluster. Hey there, welcome back. So let us now talk about the deployment of our microservices. So we have done quite a few changes to our microservices. So we have microservices like job, company, and review that have undergone changes. And now it's time that we should deploy these changes onto Docker. Okay, so we don't need to get the other things like gateway, config server, service reg, and so on. But we need company microservice, job microservice, and the review microservice. And we need to create new Docker images for these, and we need to push them to Docker Hub. So let us head over to our terminal and let us get this rolling. So here I have some Docker commands already written. We will be making use of Maven wrapper, as you can see over here. And I will be heading over to the terminal to execute these commands. So I'm here in this directory. Spring Boot where my project exists. Now, if I say ls, you will see this project over here, or not project, this folder over here, k8s. Okay. And what I will be doing is I will be switching over to company microservice. So I'll say cd, I'll say company microservice over here, like so. Okay. Now we need to run the command which will create the image for this particular service. So I'll copy this and I'll paste it over here. So just be sure that you are in company microservice project and you are running this command. Okay. And I'll press enter. Now this will take some time depending on your system and the internet, and this will create the Docker image for me. Also, one thing to be sure over here is just make sure you have PostgreSQL and everything up and running on your system. So I don't have that running right now, and that is why it failed and I got this error. So what you can do is you can go to company microservice only. So here in company microservice, we have Docker Compose YAML. So I'll say Docker Compose up and I'll enable this in the detached mode. Okay. So this is going to create a few services like job, company, review, and so on. And along with this, what we need is Postgres and pgadmin, ZIPKIN, and so on. So this error that we got will go away. Okay. So you can see over here, it is unable to open the database connection. And that is because the database is down. Okay. So let us now try running this command again. So I'll run this command since I'm in the same directory right now, and let us see whether it works this time. So after doing Docker Compose up, you can see that the image creation is in process and we don't see any errors. Okay, so clearly it was because the Docker Compose was down. So when running the command, we made sure that Docker Compose is up. Now, why did we do that? So we did that because here we are running or we are creating the Docker image, but we are not specifying the profile over here. So this is still using the default profile, which points to the Docker container and the local instance of PostgreSQL. Okay. So we need to make sure that we have the PostgreSQL and all the other services up and running so that the image at least is created. Okay. Now, once this is done, I will simply say Docker push space and I'll simply copy this and I'll paste this. Okay. So when we create an image with this particular command, it is still pointing to the local instance and not the actual Kubernetes instance which we have deployed. Okay. So the PostgreSQL in Kubernetes is still running, but this is not pointing to that. So you can see over here, push was successfully done and we have the image being pushed to the remote server. And now I'll switch the directories. So I'll switch to job microservice. Okay. I'll go over here and I'll copy the command for job microservice and I'll paste it. And this will take a little bit of time again, depending on your system. So the image creation for job microservice is also done. Now I'll get it quickly pushed to Docker Hub. So I'll say Docker push and I'll paste this over here. So this will again begin the process and our image will be pushed. Okay. Now after this process, I need to switch my directory to review microservice. So I'll head over to review microservice here. And then I'll copy the command that we have for review microservice. And this will create a Docker image for review again. So the image creation has succeeded. Now I'll say Docker push and I'll copy the image name over here and I'll paste it. So it will create the image or it will push the image that is created. Okay. So you can see it is proceeding and the pushing is done. Now let us head over to Docker Hub, and here as you can see on the dashboard, I'm logged in already. And here if you hit refresh, you're going to see all the images that you had pushed appear over here. So you have review microservice, job microservice, and company microservice as well. So these are the latest images which has the code that point to Kubernetes instance. Okay.
and we need these changes to be up on Docker Hub. All right. So now we are done pushing the changes, and now it's time to go to the next step. So now it's time that we understand how we can enable and access the services with the help of Minikube. So here in the terminal, I'm going to say Minikube service, and I'll say ZIPKIN. So let us try accessing ZIPKIN. Now the thing is, ZIPKIN is a service that is running in Kubernetes. Okay. And Minikube allows us to access that particular service. So you cannot directly access the services running in a Kubernetes cluster. You need to run this command and get the service URL. So the moment I say this, and if I press enter, you will see Minikube responds with this particular URL. And it says, because I'm using a Docker driver on Windows, the terminal needs to be open to run it, which is fine. So what it's telling is I need this terminal engaged open over here. If I close this terminal, or if I press Ctrl C, then the service will stop running on this, or I won't be able to access the URL over here. Service won't stop, but I won't be able to access the URL. So this accessibility will be cancelled. So I'll copy this URL. Okay. And I'll head over to my browser here, and I'll paste this particular URL over here. And the moment you paste, you will be able to access ZIPKIN that is running right within the Kubernetes cluster. And this is possible because of Minikube. So Minikube, with the help of that command which we just executed, it is allowing the access to this particular service within Kubernetes cluster, and it is accessible with the help of this URL. Okay. Now, if I go over here and if I close this, so if I say Ctrl C, so it has stopped, and I can run one more command over here. And now if I try to access, it won't work. You see, it's gone. And now let us run this command again. So I'll run this again. And now you can see the URL is slightly different. So the port is, earlier it was 53769. Now it's 53787. So it changes. And now if I paste, so this won't work. Okay, this is the old URL. Now if I paste this over here, it will work. And it's the same ZIPKIN dashboard which we had accessed earlier from the different URL. So this is how you can get Minikube to enable and access services. So Minikube is indeed a really handy tool. Hey there, welcome to this class. So now it's time that we test the application onto the Kubernetes cluster. So the first step, what we are going to do is we are going to deploy everything to Kubernetes. Okay. So I have to make sure that I'm in the right directory. So I am right now in review microservice. So I'll just change this to the root directory, and you will see that I have this folder here, k8s. Okay. So this is a folder where I have every microservice that is there in my architecture, and we are going to make use of k8s. Now, if I say kubectl get all, you will see we have RabbitMQ, Postgres, ZIPKIN running in the Kubernetes cluster. Okay. Now what we need to do is we need to deploy the job microservice, review microservice, and the company microservice. So I'm going to say kubectl apply, and I'm going to say k8s, and I'm going to say job first. So k8s bootstrap and then job. Okay. And it is throwing an error. It says kubectl-h for help and examples. Okay, so we missed the -f flag, like this flag, that is what we missed over here. So I'm just going to add the flag f, and I'm going to say enter. And you can see deployment apps/job is created and service/job is created. So two things are created. Now after job, I can say company, and that will also be created. And here I can say review,
and that will also be created. So you can see how with the help of organizing things, we have been able to deploy everything to Kubernetes. So we just had to change the folder and everything was deployed, and it's pretty organized. And now if you say kubectl get all, you will see you have job, review, and company up and running. Okay. So these are the apps slash. So these are replica set, and these are deployments, service, and then we have pods as well. Okay. So we have everything up and running. You can see the status is running for everything. Now what we can do is we need to start testing our application. So what we are going to do is we are going to start accessing our application one by one. Okay. So I'm going to first get the URL for job. Now you cannot directly access the services because they are actually running in Kubernetes cluster, and you need to get the URL first. So I'm going to say minikube. I'm going to say service job, and I'll say hyphen URL. So this is going to give me the URL for job service. So you can see over here, it has given this particular URL here. Now I cannot close this terminal. If I close this URL won't be accessible. Okay. So what I will do is I'll open another instance of the same terminal. I'll zoom in a bit and I'll run the command again, but this time for company. So I have the company URL as well. Now I'll duplicate the terminal again and I'll get the URL for review over here. So I'll say review like so. So we have the URLs for 3 of our microservices and we can now start accessing them. So I'll copy the one for jobs over here. Now let us head over to Postman. So here in Postman, I'll go to job microservice. I can, let's see if we can duplicate this all. So I can duplicate this entire folder over here. Okay. And here I can simply say k8s. Okay. Instead of copy, I can say k8s like so. Okay. And here I can now start replacing the URL. So this is a URL and this will not be constant. It will forever be changing. So I'll now create the job first. So let's say this is the URL and this is the request body. And let's say I create this. So you can see job has been added successfully. Okay. Now, if you switch over to your terminal, okay, let me open one more instance or one more window over here and let me run this command get all. Okay. So with this, you can get everything like all the pods, like everything that is running like pod, service, deployment and replica sets. Okay. Now let's say I want to check the logs for jobs microservice. So I can copy this and I can say kubectl logs and I can just paste the name over here. And you will see like here we have the logs and you can see the insert query was triggered over here because we just did a post request. Okay. And this is within Kubernetes. Okay. And if you scroll up here, you can see all the logs that have happened over here. You can see the service was started and then you can see like different logs over here. You can just go through and see what's happening over here. Okay. So yeah, so this is how it's working right now. And if we switch over here, we can like add company as well. So what I will do is I will just duplicate this. So instead of changing the working URLs, I'll just duplicate. I'll add k8s over here like so. And from here, I'll go to company and I'll copy this. And I'll switch over here and here I'll add in the post request like so. And I'll get a company created as well. So I'll say company 1 and let me trigger again. So company 2. Now if I trigger a GET request over here and if I change this to the new URL and if I run this, you see I have the logs, or not the logs actually. This is a response from the company microservice. So it's working in Kubernetes cluster. Okay. Now, if I try a GET request over here, so let me copy this URL here and let me paste it over here like so. And let me say get. So you will see you have the job as well as the company and the reviews as well. So the services are able to communicate as well amongst themselves. Okay, so it's indeed working perfectly fine. We can also test with review. So I'll just duplicate this particular folder here. Okay, and I'll change this name to k8s. Okay, and let us get the URL for review. I'll copy this and here I'll paste this. Okay, and you can see this is the post request and the review was added successfully. Now if I try to get jobs, you'll see we have review coming in. So this is working perfectly fine. All our microservices are doing good. Now what we can do is let us see everything in ZIPKIN. So here in terminal, I'm going to say service Kubernetes minikube service and I'll generate the URL for ZIPKIN here. So you can see this is the URL. So I'll copy this URL and I'll head over to the browser and I'll paste it over here. So you can see I'm able to access ZIPKIN, and if I say run query, you will see all the traces and all the requests that we have just executed some time back. So everything is working perfectly fine, as you can see. If I expand all, you should be able to trace all the requests and see what's happening with every request, right? So it is working perfectly fine as well. Now here in the terminal, what I can do is I can open a new terminal over here and let us log in to the database and let us see the changes that we just did. So to log into the database, I have this command already copied, written over here. So I'll copy this and I'll paste it. And we are connecting to this particular user here. Okay. So I'm here. So the command was /L or /L. I'm sorry, it was /L. I just forgot the command. And you can see over here, we have the list of all the databases. Now what I can do is we can switch to the respective database and we can see the tables from within the database. Okay. Now how do we switch to this database? So you can say /C and let's go to job over here. Okay. So you are now connected to job database as user embarkx. Okay. Now we need to run one more command over here to get the list of tables. And this is the select query. So I can just copy. So this select query, if we execute, will get the list of all the tables within a particular database. Okay. So I get an error and it says syntax error near list. So let me see what the error is. Okay, I just run the query again and it seems to have worked fine now. And you can see over here, we have one table, job. Now I can say select star. I can say from job and I can press enter. So you can see this is the job that we have added over here. Okay, so the data is being added to the database and I can switch to a different database. I can say /C company. Okay, so we are now in company. Now let us run the same query wherein we are querying information schema.tables and we are getting the list of all the tables. So here we have the single table, and if I run select star on this table, you will see two companies appear because we had added two companies. So you can see over here, two companies have been added. Okay. Now we can even switch to review over here. Okay. So we can go to review and we can run this query. You will have a review table and then you can say select star from review like so. And you will have review appear over here. Okay. So this way you can check the changes as well within the database. So indeed everything is working perfectly fine and the requests are being accessible from Postman and we are seeing the changes propagate to the database. So our application is
working on Kubernetes cluster. So that's about this class, and I shall see you all soon. Thank you.